of the hottest jobs of the day. So in today's video, we will be seeing how we can combine both, that is Python and data science, where we will not only be learning Python at the same time, we'll also be learning about how Python can be used on data science as well. So before we get started with this tutorial, let's meet my colleague and who is also a data science enthusiast. He has helped us in terms of creating this tutorial for the day, and let's meet him and discuss with him as to how this is basically designed. So hi Hemant.
Hey Manoj.
Thanks for joining the session today.
Sure.
So let me straight get into the questions. So my first question, across let's say all blogs today, I think there is a sentence which is repeated that data science is the hottest job of 21st century. So I, along with the entire audience, is curious to listen from you. Is really data science the hottest job of 21st century? If so, why?
So I'll not say whether it's a yes or no, but let me tell you like this. So since internet became huge, right, from the year 2005, we are collecting data and we are storing data exponentially every day. The size of the data is increasing every day, right? And earlier, whatever business decisions we used to take, that also has changed now. From the time when we used to discuss it with the stakeholders, they used to come up with a decision based on their experiences, and that's how any business decision was done. But now it has become imperative to basically not only discuss, but to also have facts or data to back what your business decision is going to be. Now, you may think it is up to the company how they want to, decide this, but think about this way. Let's say you're my competitor, right? So you are using data science to decide how your product should be, and I'm not using, right? So obviously this thing becomes a liability for me that I'm not using data science and you are, and chances of you seeing a success is obviously going to be more because your decision is not only backed by whatever stakeholders you have in the company, but also by data which is basically about how you have seen success in the past, right? So that's why I feel data science has become a necessity now, not only because, decisions which are backed by data are good, but also because of the fact that everyone is using it. So if I'm not using data science today, I'm actually going to lag out in the future, right? So that's why I feel data science has become the hottest job in today's world.
So guys, please understand, data science is the hottest job of 21st century. Alright, so my next question is Python enough to become a successful data scientist, or the aspiring candidates who are watching this video should also focus on learning languages like R, SQL, or even SAS for that matter?
Alright, so it's a good question. So basically, if you look at the job descriptions for data science and if you search for the data science profile on any job portal, let it be Indeed or Naukri or anywhere else, what you will notice is that most of the job descriptions ask for Python. I would say around 60 to 70% of the job descriptions, they ask for Python as a skill set in the data scientist that they're looking for. And yes, there are other job descriptions as well where they will expect programming languages like R or probably any other statistical language like SAS, which is again something which is there in the data science world. But the agenda of this video is that after watching this video, you should be able to cater to most of the data science profiles which are out there, right? So if somebody studies the concepts that we have taught in this video, after seeing this video, he should be able to apply 60 to 70% of the jobs which are out there in the market for the data scientist profile. So I hope that answers your question.
Of course it answers. Yeah. So let me get into the penultimate question.
Sure.
So today's video is a complete one. We all know it's a Python for data science video. So I just want to understand, is this course enough to get into the data science career?
Sure. So this course has all the skill sets which are basically, or this video basically has all the skill sets which are required to become a data scientist, right? But in our experience of training, what we have understood is that people will always have questions no matter how well you teach, right? And it's very important to basically answer all those questions while the concept is being taught, right? So for anyone and everyone who is basically looking out for an experience where he wants to be taught by a data scientist live so that he can also clear up his doubts on the go, then I think that person should basically go ahead and take up the course. Now, another thing that is very important when you apply for any data scientist interview is that they will ask you for the relevant experience, right? So how many years of experience do you have in data science? So to answer that particular question, the solution is that you should do a lot of projects on data science. And in this course, we have included a lot of case studies, a lot of projects which are real life problems, which you will be solving while you're going through the course, right? And that will help you not only include the skill sets or the relevant experience in your resume, but also to answer that question that have you worked on data science in the past, right? So I think this is how the course is going to help you. So if anyone is interested after seeing this video, if you feel that you like our way of teaching, you can actually go ahead and have a look at our data scientist course as well.
Right. So guys, in case you are looking to make a complete career transition into data science, then you can look out for a master's in data science course as well. So what next? We can quickly get into the tutorial. Before that, let's take a look at the agenda for today's session.
Alright guys, so first we'll go ahead and understand how you can basically start off with Python in the topic Introduction to Python. Then we're going to move on and discuss what is data science exactly, followed by how you can use Python with data science. Once we're done with that, we'll move on and then talk about how you can basically do data extraction using Python. After that, we'll go ahead and understand how you can import data sets in Python. Once we're done with that, we'll understand how data manipulation is done in Python using the Pandas library and how data visualization is done using the Matplotlib library. After that, we'll introduce you to what machine learning is and its various algorithms. Once we understand machine learning algorithms, we'll do a quick hands-on on how you can implement machine learning algorithms to basically do a market basket analysis, which is basically a demo that we will be doing after you learn the machine learning algorithms. And after that, we'll also teach you how you can go ahead and create a chatbot in Python. Alright guys, and finally, we will basically talk about top interview questions in data science, which can be asked to you in your next data science interview. Alright, so guys, this is the agenda for this video. I hope it is clear to you. Now let's move on and start off with the first topic, which is Introduction to Python. Alright guys, now before we begin, if you haven't already, please subscribe to the Intellipaat channel and also click on that bell icon to never miss out on any updates from us. Also, if you like our content, please hit the like button on this video and also comment down below what are the next videos that you want us to upload. So with that guys, let's go ahead and get started.
First things first, Python is an object-oriented programming language. For somebody who comes from a programming language background, you would understand what object-oriented programming means. Python is an object-oriented programming language and is also an interpreted language, which means that there is goodness of writing complex programs like what you can do in, let's say, a Java or let's say C# or any other programming languages, as well as there is the simplicity of any scripting language. So one of the reasons why Python has been picked up as a tool of choice is because Python has got a lot of goodness goodness coming in from different sides of the industry. One, of course, where people would want to write very complex programs. People would want to write, let's say, build web applications, build games, and so on and so forth. While that is one side of the story, there is the other side, of course, like people like us who would want to use this particular tool for performing data science and for performing any kind of analysis using data science and so on, right? So the best part about Python and why Python has gained so much traction is because Python sort of brings two different worlds together. It combines those two different worlds together. Hence, it has become almost an ubiquitous tool today. Everybody eventually lands with Python for whatever may be the complex job that you have today. So the other thing is Python is a high-level programming language. So when we say high-level programming language, when you talk about programming, right? Programming is essentially a form of computer science where you tell a machine to do a certain kind of actions. Now, there is a way that you could write programs at, let's say, a very, very low level, which means, let's say, you're writing some kind of programs at a, to to tell a hardware, for example, Microsoft microprocessor programming, or writing some programs at, let's say, at an embedded chip levels. They are low-level programming languages. They're sort of a little complex. You're writing in machines language. You and I understand a lot of digits that we as human beings have created. Machines don't understand all of that. Machines just understand zeros and ones. So what Python does nicely for you is Python is a high-level programming language, like every other programming language. Like, for example, Java, C#, .NET, Python, R. All of these programming languages are high-level programming languages because you don't have to worry about what happens under the hoods. You can just say 1 plus 2 and boom, the answer comes up as 3. You don't have to worry about what happens under the hoods. The programming language takes care of that. Hence the line over here which says that you can concentrate on the business logic, you can concentrate on the logic of performing certain things. You don't have to worry about the underlying complexity of it. Now, the second line is more or less true for all programming languages. This is all high-level programming languages. Like, for example, even for C#, .NET, Java, any of the other programming languages, this is basically true. There's nothing different about Python. But I think the most critical point why Python has become a popular tool of choice is because it brings the goodness of two different sides. One, it brings the ease of scripting languages, and it also brings in the complexity of object-oriented programming. So you can decide to do whatever you want. And the other thing also is that Python, right? The man that you see on the screen right now is the one who's actually created Python, and was created way back in 1994. Of course, the version 0.9 and let's say version 1, which is the more stable version, so to say, was originally created in 1994. Now, trust me, the current version of Python that is sort of popular outside is Python 3.678, so to say. 3.7 is probably the most. 3.8 is more or less the latest version of Python. And Python has only started to become more and more popular over the last 8 to 10 years, if I were to say. Prior to which Python wasn't all, if I were to say Python probably wasn't all that popular. People were more inclined towards tools like Java and .NET. .NET also not as much, but Java, so to say. But only recent past where you've seen Python actually become very popular. And there are multiple reasons for it. And as I said, one of the primary reasons why people like to work with Python is because it's easy. The programming language is not very complex. It's simple. The constructs are easy. The syntax is simple. It's basically like any other. It's not like any other programming language in the sense that it's easy to work with when it comes to Python. Some history about what Python is. As I said, Python as a programming language, it's been named against a particular person, a particular TV show, Monty's Python Flying Circus. It was a BBC show back then. That's what that is how it has become popular, if we were to say. But then it has no relevance to what we are learning. Yeah, it's been named behind this particular program, and a late 90s, an early 90s BBC show, late 80s, early 90s BBC show. So yeah, okay. There are thousands of languages. Why Python? Python is simple, easy to learn. The thing about Python, of course, is that Python, because it's an open source programming language, it's an open source tool. I'm sure all of you have already installed Python on your machines by now. So because Python is an open source programming language, what do we mean by open source? It is basically free to use. There is no licensing cost. It is not controlled by any third party. It is not controlled by any proprietary organization, if we were to say. So it is free for everyone, which means, now the best part about the computer science industry is that the moment something is open source, everybody contributes to it. Everybody contributes nice, easy to use programs, easy to use software packages along with it. What that has done is Python has become more and more popular over the last few years. What we've seen is people have written interesting frameworks to build web apps. People have built interesting frameworks to build, let's say, desktop applications, or let's say people have built amazing capabilities and have contributed back to the Python industry, to the Python programming language in the field of data science as well. There's a lot of statistics and data science, machine learning based libraries and software frameworks that people have built and have contributed back to Python. These are all modules. We call these as modules or libraries. And what it does is it makes life very, very easy for people who are working on the programming language. It's not all. So libraries and packages are basically reusable pieces of code that have been put together by people. And because it's an open source world, everybody believes in sharing, and hence that's how a lot of interesting libraries have come in. I'm going to talk about these libraries in a bit, but it'll make it easier for you to understand what I mean. What do I mean exactly by libraries, and what do I mean by um, what do I mean by these packages, and what is this reusable pieces of code? I'm going to talk about that briefly as we go along. But the point is that there's a lot of community support. And because there's a lot of people using it, a lot of people are contributing to it, Python has become really popular. That's one of the cool things as well. It's reliable, efficient, and time saving. Well, it is reliable. It is definitely efficient, but is it the fastest programming language? That's debatable. That's arguable. Um, there are certain reasons why it is probably not the fastest programming language. Java and .NET are still very fast. C++ for that matter are very, very fast. Python is probably not the fastest, but that's arguable again because it depends on the kind of tasks that you're performing. But it's definitely reliable, efficient, and more importantly, easy to use. That's one of the cool things about Python. Um, Last but not the least, because of the fact that there's so much goodness in the tool, suddenly what we've realized is that there are a lot of career opportunities today in Python as well. So be it as a Python programmer, be it as a data scientist who uses Python, or be it, let's say, anybody else who belongs to the software industry who just want to use Python as a tool to get your job done. We've suddenly seen a spike in the number of Python programmers that are there outside, and also there's a large demand in the Python industry as well. Okay. Where can you use Python? Here they are, right? So you can use Python basically using these. You can use Python in any of these 5. This is just a small example. Of course, the 5 that you see on the screen are just examples, but then you can essentially use it anywhere you want. Like for example, starting from number 1, web applications, right? Application development. So for example, if you want to build a simple web app, or you want to build an API, or you'd want to build a small web page, let's say, right? Or you want to build a website or a web page, all of that is quite possible using frameworks like Django, Flask, Tornado, Bottle. There are a lot of Python. These are all Python packages, the Python frameworks that help us build interesting web applications. That's number 1. Desktop applications, while web applications are one, websites and web pages are one side of the story. You can also build desktop applications. When you say desktop application, like for example, the tools like these, the timer tool that you have over here. This is a simple desktop application, a Windows desktop application. This timer app that you see on the screen right now, that's a desktop application. Similarly, you could also use Python's libraries to called as PyGTK, or let's say Coco, to build these desktop applications as well. On the other hand, machine learning, data science, deep learning, this is really taken off. This particular field has really taken off. You see that almost, if I were to say almost is an understatement, and all would be an overkill as well. But I can comfortably say that almost 95%, 95 to 99% of people who work on data science and deep learning today work with Python. There's no question about it. There's no two ways about it. Python has become more or less the eventual tool of choice for people who are working in the field of data science, statistics, machine learning, and so on. There are other tools as well, like R and so on, R, SAS, and so on. What we've seen increasingly is that people have realized that they're great tools for performing ad hoc analysis, but if you were to really build production grade, enterprise grade solutions, then I think the popular tool of choice has become Python eventually. And that's one of the reasons why you also will see that a lot of data science, and that's one of the reasons why this course is centered around Python. Not just this course. If you check for any course outside today, it's always Python, right? and you go back at least 5 years, 8 years, let's say 5 years. When I started with R. Right? R was our primary tool of choice in data science when we originally started. But then slowly, what has happened is things have taken a slightly different direction. People have started to move on towards Python. Hardware programming, cloud, and DevOps. So there is especially in cloud and DevOps as well. What we're seeing is increasingly there are a lot of tools that are based on Python. For example, any cloud application or any cloud framework that you pick up, be it let's say AWS or Azure or any of these applications, a lot of these a lot of these SDKs, right, software development kits, are based on Python as well. So which means that if you're a Python programmer and if you know how to use let's say Python libraries, then you could basically use Python to let's say deploy resources, to perform any kind of resource and to let's say create any kind of deployment pipelines, and perform any kind of build any kind of APIs and resource creations and so on. All of that can happen using, let's say, using Python. Again, the reason there being these cloud providers are providing you abilities to interact with these cloud resources via Python. They're providing you Python libraries with which you can interact with all those resources. Hence, that is one place where I think Python has become really popular as well. So I think this answers your question, Vikram, right? So what is the relevance? I think it's becoming more and more relevant over a period of time in the cloud industry as well. Okay. So the point, of course, is that there's a ton of things that you could do, but then at the end of at least the next weekend, am I going to learn all of this? I hope, I wish to say yes, but then the answer is no. You will not be able to do all of this right away. What we're going to do is, at least over the next this weekend and the next weekend, what we're going to do is we're going to try and learn the basics of Python. The basics of Python, in the sense the most essential components of Python, which is, let's say, data types, data structures, all of this that you've seen here. We're going to learn all of this. Now, this is basically the foundation for any of these activities that you'd want to do, right? Any of these activities that you want to do, this becomes a foundation. So what do I mean by that? See, if you observe Python as a, right. So what we've seen is that there is basically your Python basics, right? And on top of this is basically an essential building block. This is like the base for everything else. And on top of this, you have other blocks, right? Where each of this block is basically meant to do different things. Let's say your data science. This is, let's say, your application development, or let's say this is your cloud, any cloud SDKs that you're working with. Or let's say any desktop application that you want to build. Now the choice is yours. You want to build, let's say you want to perform some kind of games. The basics of Python will remain the same. So what we're first learning is this, right? We're going to learn the basics of Python and how to basically interact with Python. Once we tick this off, then we have the flexibility to progress in whichever direction you want based on your interest. What that means is the ones who signed up for the data science course, so what we're going to do is we're going to first learn these basics, and then we're going to learn the data science specific libraries of Python. Similarly, the ones who've signed up for, let's say, any kind of cloud-based courses, we're going to learn Python basics, and then after that, you're going to progress into picking up those cloud SDKs, if I were to say. Right. Let me just go back. The other thing, of course, is that almost all companies today more or less use Python. What that means is, based on the type of companies and the organization structure, of course, most organizations use a lot of different combinations, a lot of different combinations of tool stack. Python is definitely one of those these days. Python is definitely one of the preferred tools of choices, if I were to say. Still, a lot of these companies use Java, or let's say C# or .NET as their front end tools. That means for example, building complex web applications, still a lot of companies still prefer using Java because of the performance, because of a lot of other issues with Python. People prefer still Java and the others. But if you were to perform any specific task, let's say for data science, or let's say your let's say cloud-based applications that you'd want to build, or any simple web applications that you'd like to build, Python still has got its place. So when you say Google only doesn't work, of course, on Python. They use Python and a combination of other tools as well. Similarly, even let's say at Microsoft, we use Python as one of the tools. The other tool, of course, we use C# quite a bit, and so on and so forth with every other company as well. So all companies use Python. It's not that they don't. It's just that it's a combination. It's a combination of a lot of tools. Yeah. Okay. I'm just going to talk about the tool stack that we are associated with Python. So for example, what you have currently done is, let's say you have the open source version of Python, let's say a 3.7 or 3.8 or whatever, or let's say you must have installed, let's say a 3.6 version of Python. You must have installed this, right? And typically what happens is Python is available to download. You can just visit python.org and you can just install Python, right? But then the issue with Python is that Python by itself has certain base capabilities, right? Like for example, doing any kind of simple programming language elements, like let's say running for loops or running some kind of if-else constructs. Any kind of citing some simple business logic can be done in Python alone. But the problem here is that eventually what will happen is, let's say if you want to perform any kind of, let's say, an activity that has got to do with web scraping, or let's say you were to do any kind of data science activity, or let's say you want to connect to a database and fetch data from a database via, let's say, ODBC connectivity or anything of that sort. What you will essentially have to do is you'll have to install a library on top of it, right? You will have to install a library from a particular from a particular repository called as Python package index, also referred to as PyPy. PyPy is a very popular repository of Python where you have a ton of libraries that have been written by people like you and me, and have been and people have stored them in those, but in a specific repository. So what you will have to do is you can install Python, and you can start individually downloading these packages. Now, when you individually download these packages, mind you that every package has another dependency. Let's say this package is dependent on, let's say, some other package, and this package could be dependent on, let's say, a ton of other packages or modules, so to say. Hence, you are free to install Python directly from python.org and then do all of this manually, or you can do all of this, or you can simply install a distribution, a Python distribution. When we say distribution, what do we mean? When we talk about distributions are of different kinds. So one of the most popular distributions of Python is Python distribution is Anaconda. Right? Anaconda is a popular distribution. There is also another smaller variant called as Miniconda. Right? I don't know their fetish towards snakes, and this is Python, this is Anaconda. I have no idea why that is the case, but they've named it that way. Anaconda and Miniconda are popular data science library, data science / Python distributions. You can do more than just data science, if I were to say. So what are these? What they do is they give you Python, but along with Python, what they also give you is they give you a ton of packages along with it. They give you pre-installed, libraries along with this particular distribution. And as a result of that, what it does is it eliminates this additional hassle of installing each of these libraries individually. That is one of the primary reasons why people do not manually install Python and manually install libraries. People prefer, let's say, an Anaconda distribution of Python, but because it gives you a host of libraries along with Python. And that is one of the reasons why you were asked to install an Anaconda distribution of Python. Okay, so please do not get confused with installing, let's say, Python from python.org versus installing Anaconda distribution. Both install the same Python. What Anaconda distribution simply does is it basically takes Python from python.org. So you have the regular Python from python.org and plus packages, plus it gives you something called as an environment manager. plus a package manager. All of this put together is what Anaconda is. This Python is the Python 3.7 or 3.8 that you have downloaded from python.org. That is essentially what Anaconda distribution is all about.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Okay. Now the thing is, these packages, what are these packages and from where have these packages come? These packages have all come from PyPy, Python package index. On a normal day, you would have manually had to install Python and manually install PyPy, but because over a period of time, people have realized that there are certain combination of packages that people more often use. Hence, all of this have been bundled together, and they're providing this to us for free, called as an Anaconda distribution. Okay, so that is one of the primary things that you'll have to understand. Now, the next thing is about how do you write code, right? This is all great, but where do you write code? So now coming to the IDE, right? IDE meaning an intelligent development environment. So when you or integrated development environment, whatever you want to call it, the popular Python IDEs are as follows. There is Jupyter Notebooks. There is PyCharm. There is Eclipse, and so on and so forth. There are a ton of other IDEs that are available. Now, why are these useful? So, for example, if you are doing any kind of quick ad hoc, if you're writing some quick ad hoc programs, if you just want to work instantaneously, and if you don't want to let's say build any production grade code, and if you just want to do some quick and dirty analysis or dirty piece of coding, Jupyter Notebooks are very, very good, because what they give you is they give you a very nice UI where you can of course write code, plus you can also do some kind of dashboarding, or let's say you can essentially, collaboration becomes very easy with this. You can share this with anyone. But if you are working in an enterprise environment, if you're working in, let's say, a full-fledged enterprise grade environments, then VS Code or let's say PyCharm are two very, very popular tools. These are super popular, if I were to ask. I personally prefer VS Code. I used to write a lot of code using PyCharm. I currently prefer VS Code. It's very light, very easy to work with. Jupyter Notebooks is something that I of course do as well for any kind of quick and dirty analysis that I prefer to do. I prefer Jupyter Notebooks as well. The first and the most important thing, of course, I'll first show you how Jupyter Notebooks looks like. So what you can do is you will also have something called as an Anaconda Navigator. You can just go here. If you open Anaconda Navigator, it'll take a couple of seconds for it to open. Okay, here we go. That's the Anaconda Navigator. Now, if you observe here, Anaconda Navigator is essentially a wrapper on top of your Anaconda distribution. So what it does is it has a ton of information over here. You can launch Jupyter Notebooks from here. You also have something called as Jupyter Lab. And there is something called as Spider. I forgot to mention, there is a tool called as Spider as well that you could use. I personally hate this. This is super slow. And there are a ton of other tools also that are available here. There's something called as Orange and so on. The most important thing that I'd like to let you all know is the term Jupyter stands for Julia, Python, and R. That is why the term Jupyter, Jupyter, means Julia, Python, and R. That is why you have the term Jupyter. So which means that using Jupyter Notebooks, you could basically write code in R, Python, or whatever. You'll essentially have to link it with a backend. For the purposes of this particular session, I'm gonna kickstart the Jupyter Notebook. So if you just click on launch here, it launches the Jupyter Notebook, or you could also directly search for Jupyter Notebook from your start menu, and you can just click on the app as well. That will also launch the Jupyter Notebook for you. Okay. As you could see here, it opens Jupyter Notebook in the location where your Anaconda has been installed. So this is where my Anaconda has been installed on my machine. This is C drive, more or less, right? So you can create, I'm just going to do for my, let's say I'm going to create a quick folder. And inside this particular folder, let's say I'm going to create a Python 3 notebook. And that will kickstart a Python 3 notebook for you here. Okay. Now, this particular notebook, I can rename this notebook over here on the top. If you observe, there's something called as untitled. Just click on that and you can rename your notebook. Let's say Python session. That's basically the name of the notebook now. And here is where you're going to write your code, right? Each of this line or block that you see is called as a cell, right? You can write your code here and you can execute it. Now remember, the way this works is this is a browser based tool. That means you will need, let's say, an Edge browser, or let's say a Firefox or Google Chrome or any of your browsers to basically be installed on your systems to use this. So you can start writing your code over here. X is equal to 10, Y is equal to 20. And I could simply say print X plus Y. Don't worry about all of these statements here, but essentially, now that you've written your code over here, let's say these are a few lines of code, and I can simply execute this. To execute this particular line of code, I'll have to hit a control enter. Will execute that cell for me. Or you could simply click on the run button that you see over here. Yeah, you see this run button? You can just click on that particular run button. It'll execute it for you. Okay. Now that you've written your code over here, if you want to, let's say, write some additional line of code, you can simply create one more cell. To create another cell, you can just click on the plus button that you see here, or you can hit the letter B on your keyboard and it'll create a cell below, right? So if you hit the letter B, it'll create a cell below, and then you can execute something else. Print, let's say, X times 2. That'll print my value of 2 times X as well over here. Okay, I want to create one more cell. Let's print X times Y. That'll print that particular value in itself. Now, the other point, of course, is that if you want to, let's say, create any cell in between these two, you can go to any of these cells. Remember one thing, a very important thing that people often get confused with. If you remember the color over here, if the cell is highlighted as green, that means it's in an edit mode. That means you can basically write whatever you want. If you hit an escape, right? If you hit an escape, basically it comes to a blue mode wherein you can move from one cell to another cell, right? This is in an edit mode. To exit the edit mode, just simply hit escape, and then you can move from one cell to another cell. If you hit a B, then it would basically create another cell. If you hit A, it'll create a cell above. Okay. You can familiarize yourself with the other shortcuts if you want over here. So you can just look at keyboard shortcuts. There are a ton of shortcuts that are available. Honestly, you might not need all of those. If you ask me, they are basically not so useful at this particular point. At least you can familiarize yourself with those as you go along. But then, at least to get started, I think the most important things that you need to know is functions like, let's say, your things like just learn about control enter, which is to execute a cell. Control enter is to execute a cell. A is to create a cell above. B is to create a cell below. And if you want to delete a cell, hit double D, hit D twice, and that will delete a cell for you. Or if you want to delete all, select and then delete. Okay, that is basically how you can work with your Jupyter Notebook. So this is basically going to be your environment in which you're going to work. We're going to learn about what to write and how to write in a few minutes, but this is basically going to be the environment in which you're going to work with. Okay. Now, between a cell to another cell, so this is, let's say, cell number 1. If you look at this, I have assigned x as 10. I can access the same value of x beneath as well. So variables that I create in this complete notebook are accessible all throughout my notebook. Right? Variables are not just available within that cell, they're available across all cells as well. Okay. So that is your environment to work with. But then the point, guys, is more about, see, whenever we're going to work with Python, you're typically going to work with a Jupyter notebook, at least for the larger part of our session. We're going to work with Jupyter notebooks. This is essentially going to be the environment, our go-to environment, so to say. Okay. Now, if you were to access Python directly, right, whenever you install Python, right, along with your, if you've installed, now that you've installed Python on your machines, you would realize that along with the Anaconda navigator and everything, if you search for Anaconda on your machine, in the search bar, you would see something called as an Anaconda prompt. Right? You would see something called as an Anaconda prompt. If you just open that, Anaconda prompt, it will essentially open a command window, a command prompt. And this is assuming you're using Windows. If you're using, let's say, Linux, or let's say if you're using Mac, you can just open your terminal, and then you will be able to simply type Python. And then if Python was already installed in your path, you would be able to pull this up. So in the command window, just simply type Python. And what you would see is, you would basically see that it opens up an interactive shell. Right? It opens up an interactive shell. This is basically referred to as a Python interpreter. Whatever you're seeing over here is the Python interpreter. This has nothing to do with Jupyter notebooks. This is simply a Python. If I were to refer this back to whatever we just spoke about, this is the Python kernel. Think of it as a Python kernel at the background. This is the Python interpreter, right? I can basically do whatever I want over here. X is equal to 10, Y is equal to 20, sorry, and print X plus Y, right? Well, but because working in an interactive shell like this is going to be a pain in the backside, I think the best way to work is to use, instead of writing code like in this interactive shell, or writing the code in an interpreter would be super complex or super difficult to work with. Hence, what we do is, instead of working here, we work in the we work in any of these IDEs. And one of the primary IDEs that I just mentioned was your Jupyter notebook. Either you can write code here or write code here. If you keep writing the code in your interactive shell, then it will be really very difficult for us to track what has been executed. That is one of the primary reasons why we don't do this. Okay. Now, this is called as a Python interpreter. Basically, whenever you spin up a Jupyter notebook, at the background, it interacts with a Python interpreter. At the background, it spins up a Python interpreter session itself. That is exactly what happens at the background. It looks something like this. Basically pulls up this whole thing, and you see this particular thing happening at the background. Okay. Now, the question is, how do I convert, going back to the question that Arnab has just asked, this is a Jupyter notebook, but how do I convert this into a Python script? What you can do is, you can just go to File and go to Download As, and under the Download As section, you would see something called as .py. You would see something called as, under the Download As section, you have something called as python.py. Just click on that, and it will automatically download a Python file for you. Right? It creates a Python file for you. Now, so you can just open this and open it in any of your in any of the notepads that you have. Let me just open this in this is a notepad. This is a text pad that I have. If you see, the same piece of code that we just wrote is now nicely available for us over here. This is just a comment, so ignore the comments. So if you see, I have X is equal to 10, Y equal to 20, X and Y. These are the few lines of code that I had just written earlier in the Jupyter notebook. That is nicely available for me over here as well. The same piece of code is available for me in a Jupyter, in a Python file as well. Okay, great. Basically, a variable as a concept is very simple. It's a memory location at where you store any value. A variable is, basically, for example, if you go back and see here, when I say x is equal to 10, x is a variable, and I've assigned a value 10 to this particular variable. And what happens is your Python stores this value of x in a particular memory location. So it stores the value of 10 as a memory location, basically. So that is what we mean by a Python variable. So x becomes a variable in this particular case.
Also guys, if you're looking for an end-to-end training in Python for data science, Intellipaat provides a Python data science course and training which covers all of the concepts which you need to learn and also will help in getting you a job. So for more information, check out the description box below or visit intellipaat.com.
Simple ways, of course, as x is equal to 10, a is equal to 10, and so on and so forth. These are all simple ways of assigning values. So you can assign, so when I say a is equal to 10, that's basically assigning a particular value. Y is equal to 20 is also assigning another value. Similarly, I can say x is equal to y is equal to 100. When I do this, what do I mean? I'm saying that x and y, both x and y have the same value in it. I can say print x, it says, and similarly print y is going to do the same thing for me as well. Simply going to print 100 as a value out for me. Okay, moving on. Multiple assignment, this is what we just spoke about. You can either say x a is equal to b is equal to c, or you can also simply say x comma y is equal to 100, x comma y, sorry, x is equal to y is equal to z is equal to 100. How many ever variables, it really doesn't matter. How many ever variables you want, you can basically assign it to this particular value of 100, so to say. Or if you would like to assign different values to each of these, what you could do is you could simply do something like this. Sorry, x comma y comma z is equal to 100 comma 200 comma 300. Basically, those corresponding values are essentially going to get assigned to this. This is not a very popular way of assigning values in Python, at least. I mean, you can do it, but it's not really a popular way of assigning values. We don't use it as much because it makes the readability slightly questionable. So it's there, but then the choice is yours if you want to use it or not. We don't use it as much, at least. Tokens. What is a token in Python? A token is basically any line of code is essentially a token. A token is typically made up of these 4 types called as keywords, identifiers, literals, and operators. You don't have to remember all of these. Something that comes very naturally to you. You will understand this as you go along. So for example, so when you talk about when you talk about this particular statement, let's take this statement, x is equal to 10, right? And let's say print x. Let's take this, right? When you say x, let's take the first line of code. X in this particular case is an identifier because you're identifying the value 10 with x, right? That is basically what an identifier is. Next, the term equal to is an operator. It's an assignment operator. In this particular case, equal to is an assignment operator. Okay. And third, the value 10 is a literal. A literal is simply nothing but the actual value in itself. All of this put together, this whole thing put together, it's a token. So a token, if you observe, is made up of an in this particular case, the term x is equal to 10 is made up of an identifier, an operator, and a literal. A literal is simply nothing but the actual value in itself, right? An identifier is basically the value or the variable against which you are assigning that particular value, and the literal is the value in itself, and this is your operator. The term print, because it's a reserved word and it is a Python understood word, print in the next line becomes an keyword. This is a keyword in this particular case. So x is equal to 10. In this case, x is nothing but an identifier, equal to is an operator, literal, and a keyword. And that's exactly what we're talking about over here. So for example, under keywords, if you see under keywords, all these are basically your keywords. There are certain Python specific keywords which you cannot use as identifiers. So all these keywords, you cannot use these as keywords. So for example, I simply cannot say print is equal to 1. You can say it, you can assign this value against print, but then when you're accessing this particular value, or let's say when you say print of, that's when it starts to throw an error. Or let's say print, when you start accessing this function, this particular keyword and the value, Python gets confused. It gets confused towards, are you using the term print as the variable, or are you using the print as the keyword? That is basically the value that you have, that or the keyword that Python understands by itself. While you can assign these values, this is not typically suggested. Not suggested. The point is, do not use keywords as variables. Now, this is not just the case with Python, guys. This is a common practice across any programming language as identifiers, rather. Do not use keywords as identifiers. It's a good practice across any programming language. Don't use things like these. Becomes very confusing. So these are certain keywords. These are not the only keywords. There are a ton of other keywords as well. But we'll know more and more keywords as we go along. Okay. Identifiers. There are certain naming, when you basically create an identifier, right? There are certain naming standards as to how you create your variable names. For example, except for underscore, you cannot use any other special character. Your variable name cannot start with a number, so I cannot have I can have something called as A1 is equal to 100, but I cannot have 1A is equal to 100. This is not allowed. You cannot do something like this. Similarly, I cannot have a let's say $1 is equal to 100. You cannot do that either. You cannot use any special character. The only special character that you can of course use is an underscore. A_1 is equal to 100. You can use an underscore. That's the only allowed special character. You cannot use anything else. Okay. And Python is case sensitive. Remember that. When I say a is equal to 10 and a is equal to 100, these two are two different variables. Unlike SQL, where variables are not case sensitive, Python is case sensitive. These two are treated as two completely different variables. Okay. Now, coming to literals, when we talk about literals are essentially the values against this. So there are primarily these type of literals. Under literals, you can think of literals as integers, long, float, and complex, right? Do not confuse too much between an integer and long. It is just an internal way of understanding large integer values. Unlimited integer sizes essentially is what is called as long values. But technically, from an execution standpoint, they both have no difference whatsoever in Python. So those are just for representation's sake only. But internally, everything else means the same. And even between you and me, when we use integers, when you create integers, everything is one and the same. So you have float values, and then you have complex numbers. So let me quickly show you a few values here. So for example, if I say a is equal to 10, and if I let's say b is equal to 10.0, though both of these have almost the same values in them, they are essentially different values. So if you look at type of A is basically going to tell you what is the data type of the value of A. So now A we are saying is an integer. Now when you say type of B, This will give you the data type of b, which is a float. Though the value is the same, though we say a is equal to 10 and b is equal to 20, both of these more or less have the same exact value. One is an integer, but the other is a float. The data types are completely different. Okay, so remember that in the first place. Next, what are complex numbers? So for example, if I have, going back to your knowledge about complex numbers and real numbers from your school. Complex numbers are numbers that are typically used, or rather your number system can be split into two major numbers. One is called as complex numbers and the other is real numbers. We don't use complex numbers as much, at least in our regular math or in our regular day-to-day analysis. We don't use complex numbers as much, but just to kind of give you an idea about how complex numbers can be used, you could simply say x is equal to, in this particular, as you can see over here, you can simply say x is equal to 3 plus 5j, right? Where j is simply nothing but your iota. If you remember, j is nothing but your square root of minus 1. If you don't remember it, it's okay. It's totally fine. We're not going to work with complex numbers anyways. We don't work with them as much. But this is just to kind of show you that if you want to work with complex numbers, you can work with them as well. So basically, this is your imaginary part and this is your real part. So 3 is your real part and 5 is your imaginary part. Okay, these are complex numbers. So if you look at type of x now, it's a complex number. So x is now a complex number in this case. This is an integer value. So this is an integer value. A is an integer value. B is a float value. X is a complex number. The other literal that you will also come across quite frequently is a string literal. So let's say my name is Srinath. And when I assign this and when I look for the type of name, it's a string literal in this case. So because I've assigned this as a string. Now, when you deal with strings have to be assigned under quotes. Just like any other programming language, you have to mention strings as quotes over here. That is a mandatory aspect, right? Within Python at least, right? Either within a single quote or a double quote. You can do this or you can do this as well. Both are fine. You can give it under a single quote or a double quote. Either ways, your name is a string literal. Okay. Now, one key point that you have to understand, guys, here is that Python is an interpreted language, which means if you've observed until this particular point, I have nowhere declared that a particular variable should have a certain value, which is unlike every other programming language that you would have learned until this particular point, if at all you have learned, of course. If let's say you've learned Java, or let's say C#, or let's say C++, or any of your other programming languages, so to say, you would have, before let's say assigning a value to a variable, you will typically have to declare that x is an integer type, and then you will have to say x is equal to 10. And let's say by chance you pass under the integer type, let's say you say x is equal to Srinath, then it would end up throwing an error saying x cannot have, let's say, or you will have to do declare x as an integer, and then you will have to say that x is a Srinath. If you say let x is equal to, let's say, 10, it would take the value 10 because 10 is an integer value. But if you pass, let's say, Srinath to it, it would throw an error saying that x can only take an integer value. You cannot pass a string value. Now, this is the typical concept of any declarative programming languages. Like, let's say this is how you do it in, let's say, a Java or C# or C++ or any other programming languages that you would have learned until this particular point. That is not the case in Python. In Python, you can simply say x is Srinath, and Python would interpret this value and it would assign the data type of this particular value to x. It would automatically say that x is, let's say, a string value, right? If I simply say, type of X, it will automatically say that X is a string value. Now what I can do is I can now say X is equal to 10. Remember, what is the current value of X? The current value of X is Srinath. But now if I say X is equal to 10, Python comfortably converts this into 10. And now if you check the type of X, it says that it's an integer now. So this concept of automatically changing the data type of the value is something which is not new. This is not new, but at least it is new to people who probably come from a different programming background. This is called as dynamic typecasting or typesetting. And the idea, of course, over here is that you don't have to declare the type of your variable upfront before assigning a value to it. You can automatically assign the value, and then the programming language will take care of assigning it the right data type as it goes along. Okay.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So that's an important point. Now, the other point over here is that because X is equal to just a second. The other point over here is, let's say X is equal to 10. And if I say type of X, of course, this is a string. But if, let's say, I say X is equal to integer of X. Now, what am I doing here? This is converting any value of X into an integer. This is essentially, rather than converting, I think we should call it coercing. We are forcefully doing this. This will comfortably do it because X, it tried to convert X into an integer, and it comfortably converts this into an integer. However, on the other hand, let's say I had something like this. Let's say, I don't want to sound or self-obsessed, but Python underscore 10, let's say I have the value Python 10 in this. And if I now try to convert this into an integer, what do you think would happen? It should throw an error. And if you see this, invalid literal for integer with base 10. So what it's saying is integer does not expect a string literal like this. Even if it expects a string literal, it can parse it if it can actually be done. So currently it throws a value error and it says that invalid literal for integer. So your int function is unable to convert this into an integer. That's the most important thing. Okay. Now the other thing over here is about, let's say, so when I do this, what's going to happen? Error 25 concatenate. Yeah. So first things first, what do you think will happen? These are X and Y are string literals. Basically, this is a string literal, and this is also a string literal. So when I add these two, now it's not going to add the values because it doesn't assume that these values are integers anymore. These are string values. So when you do an X plus Y, it would simply concatenate these two for you. It's a string concatenation that happens. Right? That's a string concatenation. Essentially, both of these will get concatenated together. Yeah, that's one point that you have to understand. Let's say, for example, on the other hand, Now what is going to happen? It will throw an error. It says that it throws a type error, and it says that, yeah, definitely error. Yeah. So if you read the error, it clearly says that one is an integer, and the other is a string. It struggles to concatenate these two, right? Either both of them can be numbers, or both of them can be integers. But in this case, one is a number and the other is an integer, and it struggles. It fails to do that for you. Okay, perfect. Now that we all kind of understand how these simple executions work and how all of these are, when we talk about literals, we spoke about three kinds of literals. One is a integer literal, float, and we spoke about string. There are two more. One is, let's say, your Boolean literals, and the other is Boolean literals, and the other is special literals. And these are all literals. Let me call these as literals. Okay. So when I talk about Boolean literals, if let's say x is equal to true, now if you observe, true is a keyword. True is essentially a keyword. So if I say x is equal to true, and if I look for type of x, it's a Boolean literal. Now what do we mean by Booleans? Booleans are 0 1s. You can either simply, and they are quite useful whenever you're doing any kind of checks. For example, x is equal to true, you can say y is equal to false. If you look for type of y, these are called Boolean literals. They'll be very useful. Boolean literals are quite useful, especially whenever you're doing any kind of conditions, whenever you're performing some kind of conditions. We'll come to them. We'll come to use these when more significantly when we learn about operators in a minute. We'll learn about other kind of operators, and you'll use them more frequently as we go along. There is another type of literal called as a special literal. A special literal basically none. So I can simply say y is equal to none. So when I say y is equal to none, and if you look at type of y, it's a none type. Right? Until this particular point, we looked at integer type, float type, and string type, Boolean type as well. But this is a none type, meaning there is no value in y. It's a null value. Think of it as a null value, an empty value, a null pointer. If you remember from other programming languages, if you are familiar with, this is essentially a null value. With a capital N, remember, when you try doing this with a small n, it'll throw an error. It'll say that none is not defined. So it has to be with a capital value, capital N, and that's how it works. The same here as well. This would throw an error. It says that capital TRUE is not defined. It has to be capital T with another small camel case. Okay, perfect. These are the other kind of literals, so to say. Okay, let's move on. Operators. So if you remember when I spoke about operators, this is a very popular operator that you remember, right? So while we talk about operators, one thing that I'd like to introduce you all notebooks is about something called as markdown cells. We'll come to operators in a minute. I just want to introduce something called as markdown cells. Now, what do I mean by markdown cells? I'll show you. So as I said, Jupyter notebooks are also quite useful for doing some kind of dashboarding or doing some kind of quick presentations, right? So what I can do is I can simply convert this into a markdown cell by hitting an M. If you see this here, I can select a cell. I can either call it code, where I can write the actual code, or I can select markdown, and I can use HTML tags to, if you've written blogs on Medium, or if you've written blogs on Jira or on Confluence or any of the other popular documentation places, these are commonly used tags for mentioning headings. So I can simply mention this is a heading, and when you simply hit a Control Enter, it's a nice way of representing your headings. Now the same thing, I can put double hash, and it'll give you a smaller heading, a subheading, so to say. And you can do the same once more as well, and you can keep doing this and so on. So one more hash, another hash, and another hash. so on and so forth. So these are different kinds of headings that you can perform. The cool thing is each of these headings basically has its own link. So if when the moment you click on this, you have its own link. As you see, it has a hash heading over here. It automatically takes you to that particular location. So it's very useful whenever you're doing any kind of quick dashboarding or quick presentations, so to say. So for example, what I'm going to do now, is I'm simply going to say operators, and under the operator section, I'm going to start mentioning about all the operators that I know. The first one is let's say the first one is your equal to, the second one is not equal to, the third one is greater than, fourth one is less than. These are very common stuff that you already know. I don't have to mention these to you all time and time again. That's it. So yeah. Just a second. Yeah, this is the markdown issue. Let's not worry about it too much for now. So these are a few popular operators that you have, and they're going to be quite useful. Let me quickly show you how you can use them. So for example, when you say x is equal to 10, one more that I forgot. The most popular one is of course single equal to. When you simply say x is equal to 10, the single equal to, this is a simple assignment operator, right? If I say x double equal to 10, this is basically for a check. It's a condition. It's an equality check in a way. Let's call it equality check. So when I say double equal to, it essentially checks if the value of x has the value 10 in it or not. What will this return? What will be the value that this is going to return? Absolutely, yes, a Boolean type and a true. It returns a value true, and this is, if you check the type of this, this is a Boolean type. Okay, so that is essentially what this is going to be. Similarly, you can also check for this. If you put a greater than, that's false, less than is false, less than or equal to is true, greater than or equal to is true, and let's say not equal to will return a false. This is the not equal to check, right? So these are basically a few logical checks that you could do. Now what you could also do is, let's say x is equal to 10, y is equal to 20, print. If let's say you'd want to do two conditions at the same time, what you could do is first condition x greater than 5 and y less than 10. What will this return? This returns a false, absolutely. The reason being, this one is essentially going to return a true, right? And the other one will return a false. So basically when you do a true and false, that would basically return a false for you, because it is the simple Boolean algebra. Okay, it would only return a true if both the conditions are satisfied. If I put a greater than, then it would return a true. If I put a less than, it would return a false. On the other hand, I could do the same thing with an OR condition, if I put an OR condition on the other hand, this would return a true, right? If I put an OR condition on the other hand, it returns a true. So these are a few arithmetic and the assignment operators. So let's quickly look at a few arithmetic operators that we know of: plus, minus, multiplied by, divided by, percentile, and star star. These are pretty standard stuff. Arithmetic operators for doing addition, subtraction, multiplication, division. The modulo over here is for computing the remainder. So for example, you could do 10 modulo 2 or 10 modulo 3 would return, anyone? 10 modulo 3 would return 1. Yeah. So 10 modulo 3 would return 1. And on the other hand, you could do a 3. This is the value of x. So x star star 2 would return. Star star is basically exponentiation. Basically, this is power to 100. Perfect. Absolutely yes. These are standard stuff. Greater than, less than, and less than or equal to. We've done all of this. This is pretty straightforward. And we've also done logical operators like and or. We've done these as well. And or is also something that we've done. Not is basically a negation operator. So for example, you could, whenever you're doing any kind of conditioning, you could use the not as a negation operator. Typically, the not operator is something that we would generally be using in the not operator is something that we would generally be using whenever you be doing any kind of conditioning using conditional statements. We'll use this when we get there. Right now, probably not the right time for us to use it. One thing that I want to talk about in detail is these assignment operators in Python are actually quite interesting. So for example, currently, if I say x is equal to 10, right? If I say x is equal to 10, if I say, instead of saying x is equal to x plus 10, which is basically, or x plus 5, which is basically incrementing x by 5, in Python, you could write this in a slightly different way. You could simply say x plus equal to 5, right? You could simply say x plus equal to 5 instead of writing x is equal to x plus 5. This basically means the same. It is incrementing x with 5. So you can simply say x plus equal to 5. This is a very popular way of incrementing values in x in Python. I'm sorry. So it takes an impact on readability, but it's a nice way of writing it. Similarly, you could do the same with minus equal to 5, and basically it subtracts. So this is essentially x is equal to x minus 5. That's what this means. You could do the same with x. Now it is plus equal to, it's not minus equal to plus. It has to be plus equal to. That's the format. Yeah. It cannot be written the other way around, Vikram. You could do the same for all the others as well. So for example, you could simply say multiplied, and you could simply do this as well, divided by the same thing as well. So essentially, x plus equal to 5, x minus equal to 5, x multiplied equal to 5, x divided equal to 5. Yeah. So all these are essentially the same ways of the simple ways of doing x is equal to x plus 5 and so on. These are different kinds of, similar types, but yeah, that's it. That's what they are. Now, what your bitwise operators are, there are other bitwise operators as well. Like for example, you can do a left shift, right shift. It's not very useful for us, so I'm not gonna worry too much about it at this particular point. So for example, if you want to quickly do a left shift of a right shift, it is so for example, you want to do, let's say x is equal to 10, and if you do a x left shift of 1, it returns a value of 5. So when you do, so this is a right shift, I'm sorry. So when you're doing a right shift, you're basically adding a 0 to the right hand side. So sorry, you're 0 to the left hand side and moving all the digits. to the right hand side. So that way the value in itself reduces. Essentially what happens is when you do a right shift, this is 1010. When you do a right shift by 1, the whole thing gets moved in this direction and you add a 0. So we are essentially going to 4 bits going forward. So it'll be 0101. Yeah, correct, exactly. So it moves this 0 to this particular side. So and 101, this value is nothing but 5. That is what you get over here. Similarly, you can do a left shift as well, and so on. I'm not going to worry too much about it right now, at least. Yeah. The is and is not operators are basically like your equality operators only. Equal to and not equal to operators only. They're not very different. They're exactly the same. You can either use double equal to, or you can use is also if you want. So yeah, it's essentially the same stuff. Okay. In, not in. In is a very popular operator, and we will use more and more of in as we go along. So one simple way of checking in is, let's say x is equal to, in strings it comes very handy. So let's say x is equal to a, b, c, d, e, f, and if let's say I want to check de in x, so I'm checking if this particular string is in x or not. The answer is true. So it does a substring search. So it checks if the term de, because it is there in x, it returns f, and if I say not in, it returns a false simply. That's what your in and not in are really useful for. We will use this more and more when we learn about lists as we go along. We'll learn about something called as lists, and then we'll learn about that when we get there. Okay. So far, so good. I'm assuming this is super basics in Python. So we're going to talk about data types in Python. This is one way of categorizing data types in Python. If you would want to call, these also have data structures, so to say. So on the left hand side, if you see, they are immutable data types, and on the right hand side you see mutable data types. What we mean by immutable and mutable is, once a certain value is assigned to a particular variable in that data type, that variable can only be overwritten, but the value inside that cannot be changed, so to say, right? And on the other hand, if you see, there are mutable data types called as lists, dictionaries, and sets. You can also call lists, dictionaries, sets, and tuples as data structures, if you want to call them as data structures, because these hold more than one value. They just don't hold one value in them, while strings and numbers are more or less like literals, where they just hold one particular value. On the other hand, dictionaries, lists, sets, and tuples hold more than one value in them. So you can also refer to those as data structures. Okay. We already spoke about numbers, right? Integers, float, and complex values, so to say. We already looked at it in detail. I think what we have to talk about is, again, we also spoke about strings a little, but I think we're going to dig a little more into strings. We're going to look at a couple of more examples in strings. So let's talk a little about strings and how you can work with strings. So for example, let's say x is a value, which is hello. And if we already spoke about this, x, if I say x plus equal to hi, what would this return? What would be the value of x now? Would there be a space, Kuldeep? This would be without a space. Perfect. Now, if you look at x now, this is the value of x. And if you hit a dot, now this is, you hit a dot, and if it hit tab, there are certain methods that you have over here. There are certain functions or methods, you can call them functions or methods. We'll talk about difference between functions and methods in more detail when we go along. But there are certain, because this is a string, the type of this is a string, and all string types have certain functions that come along with it. Like for example, I can do dot upper and it will convert the whole thing into an uppercase. Okay. But now if you observe X is still hello hi, and why hasn't it become the uppercase hello hi? That is because I haven't assigned it back to the actual value in itself. Right? Remember, these are immutable. When I say immutable, what do I mean? These values cannot be changed. I've assigned X as hello hi, but the only way I've assigned X as hello hi, the only way I can change this particular value is by overwriting this particular data type. I can overwrite this value, this particular variable, with a new value. That's when X becomes a new value. X is now hello hi, right? With the capitals. So whenever you apply a method to a string or a number, remember that until and unless you don't assign it back to the same variable, the value will not be updated. That is exactly what I mean by immutable. So strings and numbers, both these are immutable. So are tuples. We'll come to tuples in a minute, but both strings and numbers are immutable. For example, if let's say X is equal to 100, and if I say X dot, or rather, there are certain functions that I have over here. So these are okay. Numerator. This is not a method, but let's say denominator. Let's say X is equal to 100. I can get all the properties of the value of X in this particular case. For example, if let's say X is equal to 100, and if I do X by 10, I do get an output of 10, but the value is not assigned back to 10. The only way that will happen is if I assign X is equal to X by 10. So what that means is X, because it is a string data, numeric data type, that is also not mutable. You will have to assign it back. That means you will have to overwrite that particular value. That's a key point that you will have to understand. This will come in handy at a later point. So tell yourself that whenever you're dealing with immutables, you will have to assign them back to persist the output. Whatever output you've got, if to persist that, you will have to assign it back to the original variable itself, or any other variable if you want to. Right? Wonderful. Okay. So this is X. Now X also has lower. Sorry. Yeah. So this is X. I can also have dot lower. Right? And this would basically convert my X into a lowercase. X is equal to, so now if you observe X is in lowercase. Now, if I want to, let's say, extract the first character of X, I can do that by using square parentheses. Square parentheses is basically extracting the first character. I can simply say a 0, because Python's indexing starts from 0. We all count from 1 in our fingers, but Python counts it from 0. Right? So 0, 1, 2, 3, 4. The 0th value is essentially going to be, when I say X of 0, it'll return H, the first letter in this particular thing. Right? So if I say 0 colon, if I say 1, it would return E. If I say 2, it would return L. If I say 20, it would throw an error. Why? It says index error, string index out of range. So this particular index of 20 is out of range because you don't have 20 characters here. Right? So if you do a -1 on the other, so let's put 0 over here. Similarly, if you do a -1, that is reverse indexing. We're coming from the back. -2 is you're coming from back now. This is -1, I is -1, H is -2, and so on. So this is reverse indexing, so to say. On the other hand, I can also index this from 0 and :2. Right? When I say 0 : 2, what is essentially going to happen? So remember, this is at the 0, 1, 2, 3, 4, 5, and 6. This is basically the index. This is your index. On the other hand, what is basically happening here is when you say this is x, right? When you say x of 0:2, Python, right, always treats the 0 left value that you're using on the left. This is inclusive, and this is exclusive, or the second index is excluded. 0, 1, this is 0 is included, 1 is included, 2 in this particular case. Do you think 2 is included or excluded? 2 in this particular case is excluded. Left inclusive and right exclusive. Is left inclusive and right exclusive always. So value starting from 0 up to 2, and 2 is not included, remember. Okay, starting from 0 all the way until 2. So if you look at this, H and E, that is what it returns. Always remember this. Whenever you're doing any kind of indexing in Python, it is always left inclusive and right exclusive. That's basically more or less a rule of thumb, right? Left inclusive and right exclusive. Right? This is like a rule of thumb. Remember that always. Okay. On the other hand, if I say x of 3 colon.
Also guys, if you're looking for an end-to-end training in Python for data science, Intellipaat provides a Python data science course and training which covers all of the concepts which you need to learn and also will help in getting you a job. So for more information, check out the description box below or visit intellipaat.com.
Just a quick info guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
So when I say 3 colon, that means it starts with 3 all the way till the end. Starts with 3 and all the way till the end. So it starts, when I say starts with 3, it starts at the third index here. Starts here all the way till the end. It's going to be LOHI. That is what is simply going to get returned. So if you run this, LOHI. Okay. So this is the position starting from 0. Okay. This is not the third. This is not. So we tend to get confused because we start counting it like this. So we tend to consider it from here all the way till the end. I don't know why people confuse with. I mean, we get confused so much. Is it us who's at fault or the programming language creators who are at fault? They could have made our life easier by simply starting this with 1, but yeah, for some reason they started with 0 to make our life exactly the output that you last see. Hell, right? Back here again. Cool. So that's a little. The other thing that you could also do is you have x dot. So let's say if x is equal to, right, let's say there's a lot of space, trailing spaces that you see. So you could simply do, or let's say if there are leading spaces as well, you could simply use a function called as strip, and that would strip all the trailing and leading spaces. You could simply strip spaces, but remember, you will have to assign it back again. That's the only way it would. It's more or less like trim. Okay. So the strip function is basically like the trim function in your SQL. Yeah, there it's very similar to that. On the other hand, you also have replace. So if you look at the replace now, here is something that I want all of you all to know is whenever you use a method like this, like let's say, firstly, x dot, and when you hit a tab, you get all the functions. You use capitalize, for example, and it'll convert this into a sentence case, so to say. On the other hand, what you can also do is, let's say there is a function called replace, but now you'd want to understand how this function really works. So what you could do is you could simply go there, hold shift and hit a tab. Hold your shift and hit a tab, right? Now, when you hold shift and hit a tab, what it does, single shift and tab will open this. This is basically your help, right? You can hit it twice. If you hit it twice, it'll drop it down. If you hit the same thing thrice, it pulls up the help for you down beneath. Now, this is a functionality of Jupyter Notebook. This is how the help can be pulled up in Jupyter Notebook. So to pull up help, what you need to do is shift plus tab, right, to pull up help. That's how you pull up help. So now you can basically pass any old value and then you can replace it with another value. So for example, you can replace E with, let's say, a star. So now if you observe, right, so you can simply replace E with a star in this example. So x dot replace. But remember, this will again have to be assigned back. That's how you have to perform this particular thing. Will it replace all occurrences? Let's give it a try. So let's go back to X. This is X. Let's try and replace L now. Dot replace of L with, let's say I want to replace this with a hash or a dollar. It does it for everything. By default, it does it for everything. If you just want to do it for one of the counts, you can just say count, comma, count equal to, let's say 1, only the first occurrence. I think this does it by default. This used to change earlier. Yeah, but the default value is -1, which replaces all. Only the first, yeah, which is my argument count is given. Only the first occurrences are replaced. So it doesn't take a keyword argument. That's okay. So you can just mention how many times do you want it to change? Just the first one or the second one? The default is -1, which means it does it for everything. Okay. So these are a few string operations. A couple of other string operations that I just want to show you all is, let's say this is X. And if I do, what's going to happen? X multiplied by 2. It multiplies, it basically repeats. It essentially repeats the whole thing for you. So it's basically concatenation. So that's as far as numbers and strings is concerned. There are a lot of other methods also that are available. We'll now talk about something called as tuples. But before we talk about tuples, I think it's only fair that we start talking a little about tuples, and then we're going to learn about lists, tuples, dictionaries, sets. Until this particular point, we've been talking about variables, individual variables holding a single value in them. But from now on, we're going to talk about variables that hold more than one single value in them. So you can call these as data structures as well if you want to, Python specific data structures. The thing is, broadly speaking, lists are mutable, and this is the only immutable data structure. Everything else is mutable. This is also mutable. In a lot of ways, lists and tuples are very, very similar. We'll talk about what they are in more detail as we go along. In a lot of ways, lists and tuples are very, very similar, except for the fact that there are certain operations that lists can do which tuples cannot. Dictionaries and sets are also quite popularly used. Dictionaries are probably one of the most frequently used data structures in Python. And dictionaries and lists make Python extremely powerful programming language. So what we're going to talk about is, we're going to talk about what are lists and what is the benefit of having lists. We'll talk about how can you add values into lists and how can you remove values into lists and some other functions that are specific to lists. Okay. We'll start with lists and then go into tuples. The reason why I want to do that is because lists are a much larger umbrella. Tuples are one specific case of a list. So I'd want to talk about lists first, and then we can talk about tuples as we go along. Okay. So what is a list? A list in Python is basically a data structure which can hold any kind of a value inside it. Right? When I say any kind of a value inside it, it can hold any data type inside it. It can hold a string. it can hold a number, it can hold another list, it can hold a dictionary or a tuple. It can basically hold anything inside it. Think of it as think of your a list as a bag of think of this as a large bag, and you can basically dump anything inside it, right? um, and you can store all of them at the same exact time, right? So list is basically a single data structure that can hold homogeneous or non-homogeneous data values within it. It can hold a number, string, integer, float, uh, a set, a dictionary, a list of lists, and so on and so forth. It can hold anything inside it. So for example, a list is generally represented using a square braces. You can simply you can either say something like this, right? This is basically initializing a list, right? This is essentially initializing a list. So now if you look at type of X, this is a list, if you observe. The cool thing about a list is, as I said, it can hold anything inside it. So what I can do is I can basically create a list. If I want, I can create an empty list like this, or if I want to create a list with some values in it, I can comfortably do it. I can do this 1, 2, 3, 10, 20, 30. Hello. So on. Let me not. That is what a list is. So now if you look at the type of X, X is a list. As simple as that. Now, first things first, if I want to look at the length of this particular list. So somebody has given me a list of values. Firstly, why is this useful? Why is the list of values useful? Now I'll tell you why this is useful. So for example, let's say in your Python programming, let's say you are analyzing, or you would want to store the values of all the students in this particular, store the ages of all the students in this particular class, right? Let's say there are at this particular point, there are 34 people in this particular class, and I'd like to store the ages of all the people in this particular class. So how do I store it? I cannot have 34 variables. If I create 34 variables, then probably that is the most ridiculous way of handling all these variables. It becomes very difficult for me to store these values, right? Instead of storing all these values in 34 different variables, Python gives me the flexibility to store all of this in one single data structure. And one of the most popular ways of storing this is a list. There are certain challenges with lists as well, which other data structures overcome. But for now, a list is basically an array of values that it can simply hold. So currently what I've done is, let's say I've stored a lot of values, a lot of ages, and along with it, I've also stored some other string values along with it, right? So if you were to quickly check the length of this particular list, I can simply say len, and it says there are 8 values in it, or there are 8 variables in it. Now I can say, if I want to extract the first, I can simply say x of 0. Now this is very similar to what we did with your strings a while ago. If you remember the co0, 0 colon 2, and so on and so forth, it's very similar to that. If I say 0, it'll give me the 0th value. If I say 1, it'll give me the first value. If I say 1 colon, it'll give me all the values starting from the first index all the way till the end, right? Starting from the first index all the way till the end. Similarly, if I do -1 colon, what it does is it is left inclusive. It starts at -1, and we are saying colon, meaning all the way till the end. That is the end. There's nothing else after this, right? Hence, it doesn't return anything. A simple -1 would return high. But if I say -1 colon, that means starting at -1 till the end is what I'm asking it to go. But -1 is the end, hence it doesn't go anywhere after that. Okay, so -1. So going back here, -1 is here. It doesn't go anywhere after that. That is more or less the end of it, so to say. On the other hand, what I can do is I can do this. when I say -2 colon, what would it return? Right, hello and hi. It starts at -2, goes all the way till the end. Just because we're doing reverse indexing doesn't mean it starts here and goes to the left side. It starts here and goes all the way till the end on the right hand side. End is only at one side, so it returns hello and hi for us. Okay, perfect. Now, on the other hand, you could do this as well. -3 colon -1 would return -1, -2, -3, left inclusive and right exclusive. So -3 colon -1 would give 30 and hello. That's about it. Right? -3 colon -1 will basically start at -3 and go all the way until -1. -1 is excluded. -1 is not included. We'll just print x over here just for reference sake. Right? So let's quickly check that. X of colon -2. What colon -2 has done is it starts from the beginning all the way until -2. Starts from the beginning all the way until this -2. This is -1, -2, and this is not excluded. This is not included. So it starts from here all the way until this particular point. Now, there are certain methods that you can use. So for example, this is x, but let's say you would want to add a value at the end. Right? Let's say you'd want to add a value, or when I say add, I mean you want to insert a particular value at the end. What you could do is you can simply do an append. You could simply do an append. And when you say append, I can, let's say, append 100. So now what happens, remember, before I execute this, I just want to show you one thing. Lists are mutable. So when I simply say append of 100, look what happens. Nothing gets returned. But now if you look at x has now changed automatically without even assigning back. The value of x has changed. It's because I have added an additional value over here. On another day, I would have had to, if I were dealing with immutable data types, I would have had to do something like this. I would have had to say x is equal to x dot append. But because lists are mutable, I simply said x dot append of 100 and the value has automatically got added back into it. Okay. Now, if I want to, let's say, that is how I'd append a value. But if I want to, let's say, insert a value in a particular location, let's say I want to insert a value between 188 and 23. Between 188 and 23, I'd want to insert a particular value. So I have a method called dot insert. But at what location do I, firstly, it would ask me at what location do I want to insert? Between 188 and 23 would be what value? What index? Index at 1. And what will be the value that I want to insert? Let's say I want to insert 1000. Perfect. Now if you look at the first index, I've inserted the value 1000 comfortably. Now when you look at the length of x, you can either check length of x. It is 10 because I've added two values. I added 100 here and then I added 1000 here. Okay. Now, if I want to, let's say, remove a particular value, let's say I want to kick the last value out. I want to kick the last value out. Typically, if you are familiar with stack, if you've done, anybody has exactly. There's a method called as pop. Exactly. Last in, first out. Absolutely correct. LIFO. So the ones who are not familiar with it, don't worry about it. So basically, there's a method called as pop. And when you do a pop, what happens is from your x, the last value gets kicked out. Right? The last value gets kicked out. So this particular value gets kicked out. And now you have x, which is just this much. So this value has been kicked out. When you say kicked out, it returns that value for you. And then the remaining values are just this. Correct. It's not the last added value, Devang. It is basically the last value in the index in this case. In Python's list scenarios, it is basically the value in the last index is what gets kicked out. So whenever you append a value, essentially all the values will get inserted at the end. So that value gets kicked out. That is how pop works in Python, at least. Yeah. The other thing is, so let's say you want to remove the value 10 from this particular list now. You'd want to remove this. So now what you could do is there's a method called remove. Now it'll ask you to, now when you say remove, it's asking you what value do you want to remove. Let's say you want to remove 10. Perfect. Now look at X. The value 10 has been removed. Right? The value 10 has been now comfortably removed. So these are a few popular methods, right? So under the lists, we looked at a couple of methods. We first spoke about how one could create a list. The best way of creating a list, of course, is by simply passing a list of values in square parentheses. Remember, you have to pass them in square brackets. That is what a list is. And when you check for the type, it says it's a list. If you want to quickly check the length, you can use the len function. And we also spoke a little about how you can slice a list. This is your list slicing, right? List slicing, where we spoke about how you can extract slicing and indexing. All right. Slicing and indexing essentially is extracting a part of the list or extracting a particular element by the index or by, let's say, the position of that particular element. So x of 0 and x of 1 will essentially give us the value in the 0th position under the first 0th index and in the first index. -1 : we looked at it, and it basically gives you all the values starting from -1 all the way till the end. Starting from -1 all the way till the end essentially means starting from high until the end is basically high itself, and it's not going to give us anything else beyond that. -2 : would basically start from hello and will go all the way through till the end. We can also, of course, the obvious way of slicing a list is something like this. You could say 1:5, 1:4, and then you're essentially going to get values starting from 23 all the way until the 4th index. Remember, it is left inclusive and right exclusive, which means that the first index is included and the 4th index is excluded from this whole equation here. That's one. The other point also is, we spoke about this a little, and then we spoke about a couple of methods. The first one is, of course, append. This is to add an element, or when I say add, it is to append an element. The thing about append as a function, as a method, is that append always appends the element at the last, right, at the last of the list. So whenever you have a set of values, like for example in this case these are the values in X, and the moment you say X dot append of 100, the value 100 always goes and sits at the end. That is what X is. Currently this is where we are. And if you want to, let's say, insert a particular value in a specific position, let's say you want to insert the value 1000 in the first index, that means between 188 and 23. The 188 0 and 23 is 1. So now you're basically inserting somewhere in between here. So the new index for this particular value will be 1. So you're making way for 1000 in between 188 and 23. And when you call that function, suddenly now if you would see that the value 1000 is now inserted in between 18 and 23, essentially at the first index. Pop is to remove the last value, right? Basically, it's called as a LIFO. That's a common terminology. LIFO stands for last in, first out, right? Which means that whatever element was inserted at the last or appended at the last would be kicked out first, according to pop. So if I say x.pop, the last element is going to be kicked out, 100, and now you would see that the updated list will have lesser number of elements. The key point that you all always have to understand with a list is that lists are mutable, which means that whenever you call these method, you don't have to assign this back to that particular list in itself. So that's one of the most important things that you have to understand as well. So this is where and if you want to remove a particular value from the list, you could simply call the remove function. .remove of 10 will only remove the first occurrence of that particular value. So for example, if you have multiple occurrences of the value 10, it will only remove the first occurrence of that particular value. So remove will do it only once, so to say. Okay. For example, if let's say I want to understand, let's take X for example. Let me just remove all of these until here. Let's say for example, I insert at index 1, I insert a value 10, and similarly, let's say I insert at index 4, I insert a value 10, and let's say, and let's insert one more. At index 6, I want to insert a value 10. So currently what I've done is at these 4 indexes, I've inserted the value 10. So now if you look at X, I would see that at index 1, 4 and 6, I've inserted additional values now. So this is my new list, as you observe. Now I'd want to understand, let's say, how many occurrences are there for a particular value, right? I'd want to understand how many occurrences are there for a particular value. So what I can simply do is I can simply do x.count, and I can say 10, and it would say 4. So it's basically telling me that X occurs 4 times in this complete list as of now. Okay. Now, the other point about index. So for example, let's say I'd want to identify at what location is the value 23 in the whole thing. At what position is the value 23 in my complete list? I can simply do an x.index of 23, and it will tell me that 23 is at the 3rd index. It's not at the 3rd position, but rather at the 3rd index, 0, 1, 2, 3. So the index 23, or the value 23 is at an index 3 in this complete list. That's what it says. If let's say, for example, I do this for 10, what would it give me? It says that it's only present at 1. But then 10 is present in for multiple occurrences, but still it simply says that it's only present at index 1. Why does it do that? Index also only runs until the first occurrence. Right? It works only until the first occurrence. That's basically what it is. The next part is about, let's say you have 2 lists, right? Let's say this is, the current list is X, and let's say I have another list Y, which is, let's say 1, 2, 3, 4. Let's give it a slightly different. Right. These are 2 lists. X and Y are now 2 lists. Now let's say I would want to now add this list to this list. Now when I say add, what do I mean? When I say add, what do I mean? I would want to, let's say, append all these values of A, B, C at the end of this particular list. Correct. So the way that you could do it is by, you could simply say X plus Y, and what this does is it essentially appends all of these values at the end, right? But then once you do this, you will have to assign it back to another variable. Let's say you can simply say Z is equal to X plus Y. So now if you observe Z is now a new list with all these values. Or if you want to use any of the inbuilt functions that are available, what you can do is you can simply say X dot extend of Y. This is X, and I have my Y over here, which is ABC. I can simply say X dot extend of Y, and what it automatically does is now X simply gets updated with the values ABC at the end. Right? Yeah. So the other point about using the other point about these methods that we see over here is that there are a couple of, yeah, absolutely, Farooq, I see your question. You can also do the other way around. If you do a y dot extend of X, that also will work. When you do a y dot extend of X, you're essentially appending all the values of X to Y. So you're updating Y here. This is updating list Y. And when you do this, x dot extend of y, you're updating list x. You can do both ways. Anything is fine. Yeah. The other point about lists, of course, is that there are certain other inbuilt functions, like for example, you could use functions like min and max. Let's say, for example, you have x. This is your current value of x. You can use min of x and max of x as functions within lists. However, if you currently observe, in this particular case, it says that your strings and integers cannot be compared, or because when you essentially do a min or max, what happens is all these elements are compared against each other and the minimum or the maximum value is extracted out. But because in this particular list I currently have a combination of integers as or numbers as well as strings, it fails to compare these two, hence it throws an error. However, if let's say I had a list which had values which were just numbers, I could have comfortably used the min of list 1.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And max of list 1. Min of list 1 and max of list 1, and this would have comfortably worked. So remember, the most important thing, if you want to use the min and max functions, you are free to do that. However, you will have to keep in your mind that this will only work if and only if the numbers are all your values in your list belong to the same data type. The same can also be done, for example, in this scenario. When I do a min and max, it does return values, but in this particular case, when it returns these values, in a dictionary sorted fashion. So the minimum of list 1, when I call a minimum of list 1, because all the values are strings here, it sorts it in a lexicographic fashion, and that's the reason it returns those values in that particular order. So the minimum of this list is A and the maximum of this particular list is hello. Okay, now let's talk a little more about nested lists, right? So when you say about nested lists, what I mean is, let's say this is my list 1, and let's say, and this is list 1, and let's say this is list 2. Now, if, for example, let's look at these two say these two expressions, list1.append of list 2 and list1.extend of list 2. What is the difference between these two? So if you look at the first result, currently I'm using an append, and here in the next example I'm using an extend. So if you look at the difference between these two, in the first one, what happened was your list 2 is now assigned as a single element in your complete list. Whereas in the case of extend, what it has done is it has merged both the lists together. So this is extend will always yield a flattened list. The output from extend is always going to be a flattened output, versus the output from append will always return a nested list. A nested list meaning one of the elements inside your list is a list, right? So the last element will be a list in itself. So when you do an append, the last element, whatever may be the value inside this append function, will be added as a last element, right? So that is how it typically works. Okay, let's take for example this particular output. Let's take for example the output that is coming out of append. So now if you look at my list one, this is how my list one looks like. This is how my list one looks like. Now let's say for example, I would like to extract this element. I'd like to index element A out of this complete list. How do I do that? Right. So to extract the element A from this particular list, what I would have to do is list one. Kuldeep, you're correct. So you're probably not correct, but I'd want to extract A, not B. So you probably might have to correct yours a little. So remember, how many elements do I have here? 1, 2, 3, 4, and 5. Totally 5 elements. So which means this last list is at the 4th index. So when I say list one square parentheses of 4 would extract the complete brackets, will extract the complete list out for me. Okay. Now that this is a list, I would want to extract element A from here. So how do I do that? Of 1. Right. So what we are doing here is to extract a particular value from here. This is essentially a nested indexing, meaning I'm first extracting a value, and from that value, I'm extracting another value. Okay. Now, when we do list one of 4, what do we get? We get the complete list. Okay. Now, when I do 4 of 2, what am I going to get? So list 1 is now this complete list. Now from this list, I want the second element. So 0, 1, and 2. The second element or the element in the index is hello. Spot on. Perfect. It is hello. Now from here, I want the third element. What is the third element here? 0, 1, 2, 3. At the third index, I have this hello, the one that I'm just highlighting. That L in the hello is what is essentially going to get returned. Okay. Remember, you can also index strings from yesterday's session. Okay, strings can also be indexed, and that is essentially what we've done here. Right? So let's say, for example, let's say I do this. Let me keep this. Dot append of HELLO. Okay. So now if you look at list one, this is how my list one looks like. Okay. Now, what is the function that what is the method that I can use to enumerate the number of elements of a given value in a list? What method will I have to use to identify the number of elements of a given value? So for example, if I want to identify how many times number 10 is present in a particular list, count, correct? Absolutely, count. Yeah. So to do that, what you will have to do is, so let's say I do a dot count of hello. What will be my output? Is it 1 or 2? Right. So let's execute it. Let's have a look at it. The answer is 1. The reason why it is just 1 is because hello is in this list. The elements in this particular list are 100, 102, 20.1, 42, this list and hello. So when you do a count, it simply counts the values in the top layer of this particular list. It doesn't go into the list. It doesn't go into the values inside that particular list, right? So when you simply count for hello, it simply counts in this particular level how many values are there. So hello, it only sees it once. You might have hello 100 times inside this, but it doesn't care because it treats this complete list as one single element, right? So that's the reason why hello is not going to be, this hello is not going to get counted. The hello inside this particular list is not going to get counted. Only this hello will get counted, which is at the end, right? Perfect. So that's one. One more last thing that I'd want to talk about in lists is, for example, let's say, and this is one of those common things that you will come across. Let's say I have a list, right? And let's say dot append of 100. Let's say I do it twice. So this is list 1. So I have 100 multiple times now. Now I want to remove all the occurrences of the value 100. I would want to remove all the occurrences of the value 100 from here. So how do we do? How do you remove a value here? How do you remove a particular value here? You can use a function called, you can use the method called as remove. But when you use remove will only get rid of the first occurrence. Remove will only get rid of the first occurrence, right? So if I say dot remove of 100, it will just get rid of this one. But then I want to get rid of the others as well. And at times it might so happen that I might have such a large list that I might never know where these values are. I might never know how many times that particular value is available. So I would never know how many times to execute this particular function, right? So what do I do then? The remove method by default, will by default just give me will just get rid of the first occurrence. But I want to remove all the occurrences of that particular value. So what do I do? What is the best way of dealing with this? Del will get rid of the complete complete list, Devang. So I see what you're saying. So you basically want to say list 1 of, you can do that. That is totally fine. But then you can get rid of that particular value, which is totally fine. This is basically del of list 1 of 0, basically saying get rid of a value at the 0th index. But you don't know what index these values are in either. So this is your list 1 now. So del will simply get rid of a particular value at a particular position. But let's say, for example, I have a list where I have the value 100 repeated multiple times. How do I get rid of it? Pop function will only kick values at the end. It will not kick out values somewhere in between. I don't want to get rid of all the values. So what I will have to do, count for all hundreds. So first thing what I'll have to do is I'll have to basically count for all the values in that particular list, count of 100. So firstly, at least let's get to understand how many hundreds are there in the first place. So list1 dot count of 100 will tell me that, okay, there are 500 in this particular list, which is great. Now what? Okay, you will get the index, let's say. Even when you do an index will only give you the first occurrence as well. So if you do an index, it will tell you the first occurrence. That's it. How many ever times you execute it will simply give you the first occurrence. Right. So what you will then have to do is you'll have to loop through the list. There is no other way out. So you will have to iterate over the list. When I say iterate over the list, that means you will have to recursively perform a particular action until a certain condition is met. So you'll have to keep doing something until a certain condition is met. Like, for example, what you can do is you can use a simple for loop or a while loop. We will come to those for loops and while loops later. But I think the point that you have to understand is that when you would want to perform the same action multiple times, or you would want to perform the same activity n number of times, then there is no straightforward way of doing it. You will then have to combine these methods with for loops, with conditional flow statements or looping statements. Only then you will be able to achieve this particular activity. So let me give you a simple example in this case. In not just in Python, any programming language will have a concept called as loops. So one of the most popular loops is a for loop. So what I'm currently doing is for list 1, for I in list 1, when I say I is simply a variable. You can put I or you put your name, doesn't matter. You can put whatever you want. For I in list 1, when I say print of I, I'm just briefly introducing this concept to you all. We're going to deal with this in more detail later on. It'll make it easier for us to work with for loops. So when I say for I in list 1 print I, what I'm going to do is for each value of list, I'm simply going to print the value of I. So what is typically happening is in list 1, these are the values that I have in list 1. So I'm starting with 20, then I go to 20.1, then I go to 42, then I go to 100. So there is a cursor. This I, let's say, is a cursor. It starts at 20 at the 0th index. Then it goes from here to here. Then it goes from here to 42, from 42 to 100. Then from 100 to this complete list. And this from complete list to hello. And then those eventual values. So whenever you're writing this simple for loop, what you're doing is you are iterating through every value in this particular list. So when you say for I in list 1, print I, every time it is in that particular position, it is simply printing that particular value. Okay, that is what we are doing over here. So what I'm essentially asking it to do is for I in list 1, print I is what I'm saying. Now, what I can do is I can say for I in, right? For I in, let's say I would want to perform a particular activity 5 times because I know that 100 is present 5 times. So first things first, what I'm going to do is I'm simply going to perform something like this. If let's say x is equal to number of hundreds is equal to list 1 dot count of 100. So now I know that there are number of hundreds is 5. So I know that there are 500, right? So now what I'm going to do is for I in just
Also guys, if you're looking for an end-to-end training in Python for data science, Intellipaat provides a Python data science course and training which covers all of the concepts which you need to learn and also will help in getting you a job. So for more information, check out the description box below or visit intellipaat.com.
don't worry too much about all these terminologies here. Just have a look at how I'm combining a for loop with this. We're going to discuss about for loops in more detail later on. So I'm just trying to show you all how typical activities are generally done with for loops and the list methods in combination, how they work together. That is essentially what I want to show you all. So for I in range of number of hundreds, that means when I say range of number of hundreds, what am I going to get? When I simply say list of range of number of hundreds, I get 0, 1, 2, 3, 4. That means 5 times I'm going to run this for loop. This for loop will basically execute 5 times. Okay. And what am I doing? I'm simply going to do list 1 dot remove of 100. Because now here I know how many times 100 is there. I know I've identified how many times the value of 100 is there. Now I'm simply running a simple range function to iterate those many number of times. So if I simply run this, now if you observe, if you look at list 1, I don't have any value of 100 available in it anymore. Right? Does that make sense? Kuldeep, no. List 1 dot remove of I will not work because I is going to be 1, 2, 3, 4. I is simply going to be 1, 2, 3, 4. Remember what the values of I are. Right? Okay. So that is typically what it is going to work here. Is it necessary to get the number of count of hundreds? You will need to know how many times 100 is available. I mean, at least that is one way of doing it. Because what we are doing over here is we're first trying to identify how many times hundreds are there, and then we're trying to remove the values. Or there is another way of doing it, but that would require a little more knowledge about how these constructs are written. What I can simply do is I can simply say for I in list 1, if I equal to 100, if I equal to 100, then I can simply say list1 dot remove of I or 100, whatever. I could also do this. This will remove all the hundreds, right? Because when I say I in list1, so I'm iterating through the complete value of this list. I'm iterating through all the values of this particular list, and I'm going to remove it. So, guys, I think we're basically putting the cart ahead of the horse here. So let's not worry too much about this right now. The only point of me trying to show you this is to tell you all that lists by themselves cannot survive. So if you want to write any kind of complex logic, lists by themselves are not sufficient to perform all the activities. You will have to combine the lists with loops, with looping statements like what we've currently seen here. Only then we will be able to achieve what we want to achieve. Okay. So combine your lists with looping statements. That is where looping statements and conditional statements. That is where we will be able to achieve these complex business logics that we'd like to build. Okay. So from lists, what we're going to do is we're going to move on into tuples. Right now, tuples are basically a specific scenario of lists. Right, as you see here, tuples are essentially a specific scenario of lists. The only difference between lists and tuples is the fact that lists are mutable, tuples are immutable. That means whatever functions we had in lists of where you could change the values inside a particular list cannot be done in the case of a tuple. So you cannot change any values inside a list. You cannot do anything to any value inside a list, inside a tuple. I'm sorry. What do I mean by that? Let's go back here. Let's have a look at this. Firstly, to create a tuple, what we will have to do is you can do it. It's very, very similar to that of a list, but the only thing is instead of using square braces, you will have to use round braces. That is a tuple. So now if you look at type of, it says it's a tuple, as you can clearly see here. Right? So that is basically a tuple here. Now, what in the case of a list, for example, right? In the case of a list, we had methods like remove of 100, right? We don't have any such method here. Right? Tuple does not have a method called as remove. Why is that the case? You cannot remove the value 100 simply because the value lists tuples are immutable, and you will not be able to change or get rid of any values from your tuples. That's the most important thing that you have to understand. Similarly, you will not have insert either. You cannot insert a value either inside in a tuple. So the only thing that you can use a tuple for is you can slice a tuple. You can slice a tuple. That means you can extract a part of the tuple. Right? Let's say I can say 1:2, or you can do 1:3. You can slice a tuple. That can be comfortably done. So slicing is possible. All the slicing functionality that we had earlier in the case of a list is completely possible. Like for example, -1, -2, all of that is conveniently done. Everything else stays. The thing is, you will not be able to either remove a value or add a value back into this. Right? One way of either removing or adding a value back, I mean, you can forcibly do it. So for example, what you can do is, if let's say, for example, this is tuple 1. If I say tuple 1 of 0, I'm going to get 100. But if I say tuple 1 of 0 is equal to 1000, it says tuple object does not support item assignment, meaning that you cannot change the values inside a tuple. But the same thing would have been completely possible with list. This was a list. List 1 of 0 would have been 20. I could have simply said list 1 of 0 is equal to, this is list 1. List 1 of 0 is equal to 2000. Now if you look at list 1, I've simply overwritten the existing value inside my list. So lists allow us to change values. Tuples don't assign us to change any values. Okay, then what use is of tuple then? Right? Yeah, tuple has a few methods. Right, tuple has a few methods. The only two methods that are available in a tuple are count and index. Right, you can do a count, tuple1.count. So for example, you can count how many values are there of a particular thing. So I can simply say count 1 of 100. I can do a count, and I can do an index as well, meaning I can identify at what is the index of the value 200. It says it's at index 1, right? So let's say, for example, you have written an extremely complex piece of code, right? Let's say you have written an extremely complex piece of code, and for certain reasons, let's say your tuple takes in, so let's say your program requires, let's say, username and password. Take for example usernames and passwords. So you've got your username and password. For example, if you've put it inside a list, there is a chance that somebody within that particular program may edit those values, right? There could be a chance that the username and password might get edited. Just not username and password, it could be any value. Let's say, for example, there is a complex method that you've written, and the complex function or the complex program that you've written outputs a certain value. But imagine somewhere, unfortunately, unknowingly, you have in one of your steps overwritten the values somewhere, right? Or somebody else is, let's say, meddling with your code, and unfortunately somebody else has realized that they have unknowingly, let's say, overwritten the values inside that particular list. So if you put your outputs inside a list, or you put sensitive information inside a particular list, there's a very good chance that the values can get overwritten. So if you want the values to not be overwritten, if you want your data to be untouched, unchanged, all throughout the complete execution of your program, the best way to put your values is inside a tuple. Because a tuple, the only way that you can do with a tuple is just delete the tuple. That's the only way you can get rid of the complete values, because as long as the tuple exists, nobody can change the value inside that particular tuple, right? Okay, so that's the primary difference between a tuple and a list. So for example, let's say you have tuple 1, and let's say you create a tuple 2, which is, let's say, 10, 20, 30, or let's say hello. Right, 10, 20, 30 and hello, tuple 1 and tuple 2. What you can do is you can do tuple 1 plus tuple 2. You can do this comfortably. Tuple 1 plus tuple 2 is possible. But remember one thing, when you do a tuple 1 plus tuple 2, you are of course you are combining these two tuples, but you are not updating any of the existing tuples. None of the existing tuples will get updated. You can assign this back to, let's say, tuple 3. That is the only way you are essentially creating a new tuple over here completely. The existing values are untouched. Still tuple 1 and tuple 2 are still untouched. So nothing happens to tuple 1 and tuple 2. They're still the same. So currently what we are doing over here is we are overwriting, or we're recreating a new tuple. That's about it. Okay. So that kind of brings us to the end of tuples. What we're going to do next is we're going to introduce ourselves to another really important data structure called as dictionaries. Dictionaries are probably as important as, let's say, lists. There's so much that you can do with a list. Similarly, there's a lot that you can do with dictionaries. Dictionaries are key value pairs, so to say. So dictionaries are basically, think of dictionaries as hash tables. If you're familiar with hash tables, if you are, great. If you're not, it is even better, because it makes my life easier. The point is that if you can think of a dictionary as a key value pair, That is what a dictionary is all about. So if you think of this, let me give you a simple example. So let's say you have, let's take a simple example. Just a second. Yeah. Let's take a simple example. Let's say I have, let's say I'm trying to make a note of the marks of students in a class, right? Let's say I have the number of marks that a set of students have scored: 10, 20, 30, 25, 28, 39, and so on and so forth, let's say. But along with these marks, I just don't want to store the marks, but I also want to store who has scored these marks, right? The name of the student, right? Let's say A, B, C, D, E, and F, right? I want to store both. I want to store the marks as well as I want to store the name. Now, one way of doing this is, one very rudimentary way of doing this, of course, is I can store two lists, right? I have a name list, right? And I have a marks list, right? I can store all these values, all the name values inside this, and I can store all the marks values inside this particular list. But then the problem here will be that whenever I store values in this particular fashion, if let's say I would want to identify the marks that are scored by student C.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
How would I be able to extract his marks? Technically, what I will have to do is I would have to first identify where, in what positions C is. So I will have to search through this list. I will identify where C is in this particular list, identify the index, and then use this particular marks list. And then I have to index that with, let's say, this particular position. Let's say this position is in position 3, then I'll have to extract something like that out, right? I will have to do something like this. So basically I have two lists that I have stored. List number 1 is where I'll have to fetch where this particular person is. And from list 2, I will have to pull up this particular value. Now imagine what we are doing here. What we are essentially doing here is we are doing two searches, more or less. First search is to identify where this particular person is, and search 2 is to pull up the value from this particular list. This is a very tedious task. First things first, searching in itself, this whole searching affair itself is a very, very painful affair. For example, let's say for the worst nightmare, let's say I have 10,000 students and I'd want to search for a person who is somewhere at the end. I will have to search through this complete list and identify where that particular person is. So I'll have to do 10,000 searches, 10,000 comparisons, and then identify that particular person's index and then use that index in here to pull his marks out. While this is doable, there's nothing wrong with this. You can do this, but this is extremely inefficient. For this particular use case, using lists is probably the most ridiculous way of storing these values, right? Hence, what we generally do, hence what has been proposed, is that instead of working with lists like these, a very interesting data structure has been proposed called as dictionaries. Right? They are a very, very popular way of storing these values. Dictionary is simply nothing but a key value pair. Right? So dictionary is basically a key value pair. So you have a key and then you have a value. You have a mapping between a key and a value. So a key is simply nothing but a name, and the value, let's say in this case, is marks. Or this can be an employee ID, and let's say this can be his salary. Or this can be, let's say, I don't know, this can be, let's say, your name, and this can be, let's say, your location of where you stay, and so on and so forth. So there can be numerous ways of storing this particular information. So that is what a key value pair is all about. That is what a dictionary is all about. And the best part about these dictionaries, one of the best things about these dictionaries, is searching via the key is extremely fast. Searching via this particular key is extremely fast. So that what that means is, if let's say I suddenly look for a person with a specific name or specific key, my dictionary can pull up that value in a jiffy. So there are certain techniques that have been used at the background to store these names in a very, very efficient fashion, or to store these keys in an efficient fashion, so that if anybody checks for a particular name, if anybody checks for a specific name, there is a small logic written which will directly take me to the location where the respective value has been stored. So such a technique is called as hashing. There's a technique called as hashing. A hashing basically is simply like this. So for example, let's say a very simple example, your mom, or let's say people in your house, sort things out for you inside your house in a specific order. If you don't find anything, the best thing that you do is, instead of you searching all over the place for a particular item, you directly go to your mom and you ask for your mom, where is, let's say, my shoes, where are, let's say, my shoes, or where are my I'm unable to find, let's say, my laptop. And because they know where a particular item is available in their heads, there is a map that they have in their minds which very quickly retrieves, okay, laptop is in so and so particular location, so you are directly directed to that particular location. So that combination, or that mapping that is available in your mom's head, is what a simple hash map is all about, right? Because they know, based on the key that you're looking for, the key that you're looking for is, let's say, a laptop, and based on this laptop you want the location of that particular laptop. So your mom in her head remembers where this laptop is available, so you directly go to that particular location and get that particular item for yourself, instead of searching all through the house. The mapping that is there in your mom's head is what is typically called as a hash map. So dictionaries work on the concepts of hashing. Okay, so simply put, a dictionary is simply nothing but a key value pair. So instead of storing values like how we were storing in two different lists here, what you can do is you can simply store all those values using a key and a value. So you can have name of the student A, and marks is, let's say, 25, B 28, C 33, D 45, and so on and so forth. This is called as a dictionary, right? Now, if let's say I would want to extract the marks that are scored by a person C, what I'm going to do is, let's say this is dict1. What I'm simply going to say is, I'm going to say dict1 of person C. And the moment I say person C, this dictionary object remembers where the value of C is exactly stored in the memory. So it automatically goes directly there and pulls up the value, and it says the value is 33. It simply returns that particular value out as 33. Okay, so there is a nice mapping that is stored. So extracting values from a dictionary is one of the most efficient ways of extracting values or pulling up values. So dictionaries are super efficient. Okay, so this is called as a key and this is called as a value, and this whole combination of a key value pair is what is referred to as a dictionary. Now, there are certain ways of how you define a key and a value. A value can be anything. This can be anything. When I say anything, this can be a number, this can be a value, this can be a string, this can be a list, this can be a dictionary. The value can be anything. The value can be another list, the value can be another dictionary. This can be anything. Nobody cares what the value is, right? All that you have to make sure is that the key is unique. As long as the key is unique, I can store whatever value I want inside this. By doing that, what happens is I can efficiently retrieve all the values inside this particular list, inside this particular location. Does that make sense? Yeah. This is what dictionaries are all about. key things about dictionaries is that, so the key thing about dictionaries is that A, they are used for quick retrieval. B, there's a mapping that is maintained between key and value. Third thing is the key has to be unique. And the fourth thing that you have to understand is the values can be anything. Right? You can have any value. So you basically have a list, or you can have a list, or you can have, let's say, a number or a string or whatever. But whatever you have to make sure that it is one element. One element. That means it can be a list of many values, or it can be, let's say, a tuple of many values. But it is basically one element. There is one key and one value, and the value is only one single value. So each key will only have one value against it. And inside that value, you can have as many elements as you want. One value essentially means an element, an entity. It could be a number, it could be a string, it could be a dictionary, and inside the dictionary you can maintain another key value representation. Inside that dictionary you can maintain another nested dictionary. That is totally up to you. Okay, that is essentially what a dictionary is all about. Great. So let's quickly see this in action. Let's quickly see how to create a dictionary into action. Let's take, for example, a simple example of an employee database. Right? Employee database. Now, in a classic employee database scenario, what would you have? I would want to retrieve all the, let's say, retrieve all the details of a particular employee based on the name of that particular employee. Or let's say, instead of the name, let's say on employee ID. I want to retrieve, let's say, some information about that particular employee based on the employee ID. So how do you create this dictionary? So the way you're going to create that is you're going to say, the first thing is, of course, you're going to maintain the ID over here. The ID is simply nothing but, let's say, ID is, let's say, one employee number. Think of it as employee number, or 101. And let's say the name is, let's say, John 102. And let's say Emma 103. Let's say whatever. 103 is, let's say, Ben, and so on and so forth. Let's say 104 is anyway. So this is my dictionary one. That's as simply as that. Yeah. So dict one, as you see, these are my names that you see as of now, and I have a key and a value representation. This is a key and this is a value. So I have a nice key value representation over here. So if I want to extract a particular value, I would want to extract the name of a particular employee based on his employee ID. Let's say I'd want to get the employee name of employee ID 103. I can simply do that, and I get the value of that particular employee ID in this particular employee here. So dict one. Yeah. Similarly, if I want to extract the name dict one of, let's say, 101, I can get the name of that particular person. So if you see, based on the name, based on the ID, employee ID, I'm able to get the name of that particular person. On the other hand, let's say I just don't want to store the name, but I would want to store the name, location, salary, multiple information. Right? Let's say I'd want to store more than one. Instead of just storing the name, I'd want to store more than one information over here. So how do I do that? That is completely possible. One way of doing this is I can store these values inside a list. Correct, exactly. So what I can do, I can store these values inside a list. Let's see how we can do that. So I can create a list, name. Let's say the salary is 1,000, and location is, let's say, I don't know. Location is, let's say, A. You could also store, let's say, the age for that matter. Let's say age is 23. Similarly, I can do the same here as well. comma 2000, B, location is B, and the age is 26. Similarly, I can store the same information for Ben and for Rufus as well. 2500, location as A, and let's say the salary is and the age is, let's say, 32, and let's say 1500, D, let's say 28, 24, whatever. Okay, so that is basically another list that I have simply another dictionary that I have simply created right now. Just give me a second. So now if I want to extract the information of, let's say, employee ID 103, what I can simply do is dict1 of 103, and I can get all the information of that particular person. And now remember, this is a list in itself. So now I can extract these values out from here. So let's say I want the name. Oh, sorry. I want to extract the name. I can get this out of here. Right? So, or similarly, for example, I can do the same thing here as well. For another employee ID 101, I can get, let's say, I would want to get his, let's say, salary. I can simply say of 1 would give me my salary. But then think of it this way. If, let's say, for example, somewhere over here, instead of entering the data in this particular fashion, first things first, the most important thing that I have to remember is I have to remember in what order I have given this data here, because that becomes very important. I need to know that the first element is a name, the second element is salary, the third one is location, and the fourth one is age. I will have to remember that. But can I maintain that structure within this itself? Can I actually build this dictionary in such a way that I can maintain this smartly itself? Absolutely, yes. What we can do then is I can create the value. Instead of the value being a list, I can create the value itself as another dictionary. So now look at it this way. So what I'm going to do is I'm going to maintain the value itself as another dictionary. So look at this name. The name is John, and age is, let's say, 23. Salary is, let's say, 2500, and age is, let's say, oh sorry, age is already done. Location is, let's say, A. Similarly, I do the same thing for this as well. This is Emma, age is 27, salary is 2000, and location is B, let's say. Okay, so now I have created, so now I've created another, now I've simply created another dictionary over here. But this dictionary now, remember with this dictionary, now I have a nice key value pairs. The issue with this particular example is that I need to remember what this order is. And there could be a very good chance that somebody might have entered this data incorrectly over here. Right? Somebody might do something like this. Right? Or let's say, for example, somewhere in this particular case, let's say I might not enter a certain value in itself. So in such cases, it could become a big problem. Hence, instead of storing these values and then remembering the order of the values, here what I can simply do is I can maintain the value itself as another key value pair or as another dictionary. So now look at this. Now if I want, let's say, the age of employee 102, I can simply say 101 of age. Boom, I get the age of that particular person. So because 101, what 101 will simply do is 101 will return a dictionary for me. This is a dictionary. If you look at the type, this is a dictionary. So now from this particular dictionary, I would want the age of the person. So how do I get the age? I can simply extract that by the age of that particular person. right? So this is essentially one way of extracting values based on this is essentially one way of extracting values based on a dictionary. Now, the question, what if we have to create the dictionary for 100 people, right? Typically, you are never going to create a dictionary like this. Dictionaries are a very popular form of representing data in the IT industry. If you have ever heard of a format called as JSONs, right? Java, there's an extension to JSON. It's not hitting my head right now, but the JSONs are a very popular form of representing data within the IT industry. So anybody, for example, any two systems when they interact with each other, JavaScript object notification, correct? Thanks so much, Farooq. So you can typically you can essentially transfer data. You can essentially communicate between any two systems using a JSON object. A JSON object in typically in the application world is nothing but a dictionary in the Python world. So JSONs are a very, very popular way of transferring data or communicating between any two systems. So the point that I'm trying to drive here is that we will never actually be creating a dictionary ourselves. We will never actually type out a dictionary by ourselves. So in most cases, what we would be doing is we would either be using a data and then transforming it into a dictionary format. So you would already probably have some information somewhere. You'll write a simple logic to insert this data in a certain way. So you could have, let's say, data of age and name in, let's say, two different lists. So you would probably write a simple logic to insert this data into a dictionary so that you can use it in an efficient fashion inside your program. Great, guys. So that is essentially about how you create dictionaries. Now, when you have a dictionary, let's say, take for example, dict1. This is your dictionary. Dictionaries come with a certain methods in Python. Let's have a look at those. So there are certain methods that you have over here, and let's have a look at each of them. The first one is clear. Right? There's a method called as clear. Dict1.clear will essentially wipe the slate clean. So if you look at dictionary 1, it's an empty dictionary. Dictionary exists, but it's an empty dictionary. Right? So clear doesn't delete the object, it empties the dictionary. Right? It gives you an empty dictionary. It doesn't delete the object. If you want to completely get rid of the object, then you can do a del dict1. That will completely delete the object for you. So now it says, if I check for dict1, it says dict1 is not defined because dict1 doesn't exist anymore. Right? So that is basically what your dict1.clear is essentially going to be all about. Okay. This empties the this deletes the dictionary. Next. The other thing about dict1 again is that dictionary also has certain objects, like for example, you have a method called as keys. So if you simply say dot keys, you get all the keys of that particular dictionary. Right? What are the keys in this dictionary? The keys of this particular dictionary are just 101 and 102. These are not the keys. This is a nested dictionary. So don't worry about the keys inside this. The keys of this dictionary are 101 and 102. Okay. Similarly, if you want the keys and values both, you can simply say items. So the moment you say dict1.items, it gives you a tuple of your key and the value. Yeah, this is a list of tuples if you think of this. So if you see dict1.items returns a list of tuples of key and value. So how do you search for a specific key? What do you mean by how do you search for a specific key? What you can do for a specific key is you can simply use that name. So dict1 of, let's say 101. You'll get the values of that particular key, or 102 directly. Open square parentheses. That's how you get the values of that particular key. Then again, your dictionary also has certain other methods. It has a method called as pop, right? And when you do a pop, a pop essentially expects you to pass a particular key. So for example, I'm asking it to pop out the funded or the value inside that particular key, or the complete values of this particular key. So when I say 101, the value of that key is popped out. That means now if you look at dict1, it will not have the 101st key anymore, right? It is to remove a particular key value pair by a key. So by a key, you can just pass a key and then you can get rid of the complete key value pair. So it returns that value for you, and then it gets rid of that particular key from your dictionary. So if you now look at the dictionary just has this in it. Okay, let me just recreate this dictionary. Okay, that's as far as pop is concerned. Next, dict1 has a method called as update. Now the update is a very useful method. So what update basically does is updates a particular value of a key. So I can simply say, when you use the update method, you can simply pass a new key value pair. So this is your dictionary now. So what I can do is I can pass a new key value pair. So this is my new key value pair. I've updated the existing dictionary now. Or I can also update, let's say, an existing key in itself. So now if you look at dict1, so if you see the value against this particular key 101 has now been updated. So now the question is, are dictionaries mutable or immutable? Mutable completely, because by simply an update statement, I'm able to change all the values inside the dictionary comfortably. So dictionaries are mutable objects. Unlike tuples, dictionaries are completely mutable objects. Yeah. Somebody had a question here. In case of dictionaries, pop and remove both are same. Yeah, exactly. Pop and remove is the same. You don't have anything called as remove here. Pop is what remove is all about here. Yeah. The other point that you also will have to understand, guys, is that you might see when you print the dictionary, you might see that the values are in an ordered fashion. You might see that this is 101, 102, 103. But technically, dictionaries are unordered collection of objects. They are not ordered. That means I simply cannot say I want the first value of this particular dictionary or a first key value pair of this particular index of this particular dictionary. You cannot index by position here. You can only extract a value by a key. You cannot index by position. There is no concept of a position here. Right? There is no position-based extracting or indexing of a particular dictionary. The reason for that being dictionaries are unordered. Because we just have 3 values over here, it looks as if it's ordered, but you have, let's say, 100 or 1000 or 10,000 different objects, 10,000 different key value pairs. The order is not maintained. So that's a key point that you have to understand. So whenever you create a dictionary, it might seem as if it is ordered, but technically it is not ordered. It is unordered collection of values. Okay, that's the other one. I think that more or less covers. There is one more method called as pop item. So when you do a pop item, it randomly picks up any key value pair and it kicks it out. It randomly kicks out any key value pair. So currently what you will have is, if when you see dict1, your any random key value pair is basically kicked out. And I can do the same again. Oh, sorry. So if you see, this is my dict1 now. So that is what a pop item is all about. Okay.
Also guys, if you're looking for an end-to-end training in Python for data science, Intellipaat provides a Python data science course and training which covers all of the concepts which you need to learn and also will help in getting you a job. So for more information, check out the description box below or visit intellipaat.com.
Just a quick info guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So to more formally describe data science and the field of data science is a process of finding hidden patterns from raw or unstructured data. Now let's try and understand this statement a little better. So when we say extracting patterns from hidden data, what we are saying here, firstly, the field of data science is not new to us, right? The field of data science has been there almost a century old. It all started with statistics, right? Long ago, once upon a time, there lived a man called P.C. Malnobis, a very popular Indian statistician, mathematician, who believed that statistics could actually be made use in the field of in the industry. Basically, applied mathematics or applied statistics could actually be made use in industry to actually benefit the industry in doing a lot of complex analysis. How do they make use of how does the industry want to make use of something like this? So think of it this way: if a milk supplement brand, let's take the example, right? If a milk supplement brand claimed that if you drink our let's take the example of, let's say, Horlicks, or Horlicks is a popular Indian milk supplement brand, milk powder, basically, milk supplement powder that is generally given to kids. Horlicks claims that every time you drink Horlicks, or basically GlaxoSmithKline, that's the company that owns Horlicks. GSK claims that you drink Horlicks, you get sharper, taller, whatever, and you grow taller. That's what they claim. But they just cannot make these statements right out of the blue, right? They just cannot randomly say, if you drink Horlicks, you're going to get taller. Then I'm going to say that if you talk to me, you're going to get smarter, right? Companies, especially with that reputation, cannot make such claims just out of the blue, right? There has to be some analysis that goes into it. There has to be some kind of numbers that back this whole thing. So what do they do? So what they do is, and this is what is actually happening over a period of time. So let me quickly show you what they actually do. Let's do some quick whiteboarding on this, right? So what these companies basically do is they basically identify a group of 5 to 10 people. Just give me a second. They basically identify a group of 20 people, 10 people here and another 10 people, or let's take this as 100 students, 100 kids, right? 2 groups, group 1 and group 2. This group is simply given milk, and this group is given, let's say, milk plus, let's say, Horlicks. And these 2 groups basically do exactly what each other do. I mean, if the group 1 does cycling, group 2 also does cycling. If group 1 eats certain kind of diet, group 2 also eats certain kind of diet. Everything is basically the same between group 1 and group 2. It's just that the only difference between these 2 groups, to the extent possible, of course, it's not possible to control everything, but the only major difference between group 1 and group 2 is, of course, the fact that they drink Horlicks. Group 2 drinks Horlicks, group 1 doesn't drink Horlicks. They only have milk, plain milk. So now what you do is, now you go ahead and you conduct a simple experiment. So you monitor these groups for, let's say, a span of, let's say, 6 months. You monitor the groups for 6 months. And after a period of time, let's say you then again capture the growth rates of group A and group B, or group 1 and group 2. You capture the growth rates. When I say growth rates, capture how many centimeters has each kid in group 1 and group 2 has grown. And after that, let's say you compute some kind of an average. Let's say the average growth of group 1 is, let's say, 2.5 centimeters, while group 2 people, is, let's say, 2.7 centimeters. Right? Group 1, the average growth in height is 2.5 centimeters, and group 2, who is having milk and Horlicks, the average height is, let's say, 2.7 centimeters. Now, just because you see 2.5 and 2.7, and because this number is larger, can we simply go ahead and claim that group 2 has a higher growth rate than group 1? Absolutely no. Just if tests were conducted like that, trust me, we would probably have been taking a lot of unnecessary drugs today, and a lot of false drugs would be available outside in the market, which probably are not really that effective. To really identify if your Horlicks is good or not, right, there has to be something more than just that. I'll tell you why. Right, though the growth rate in group B is actually higher than 2.5 centimeters, is actually more than group A, it could have so happened that there was some guy in group B who was probably a close relative of Usain Bolt, or let's say a close relative of the world's tallest person, and that guy just grew tall. I mean, that's a genetic thing. Or maybe there was two people in group B, or maybe there were two people in group A who actually did not do any kind of physical activity throughout the whole thing. The point that I'm trying to drive is that difference from 2.5 to 2.7 could be out of absolute randomness, right? So to perform a more complete analysis on if group B is actually better than group A or not, we basically make use of a field called as statistics to identify if group A is better than group B or group B is better than group A, essentially saying is Horlicks better than, let's say, plain milk or not. So that's where statistics comes into picture, right? Statistics has been like the most important pillar of how people have been analyzing data. Remember, we haven't done anything out of the world over here. We've just collected some data. We've observed something happen. We've collected that data, and then we've simply analyzed that data, right? And that is exactly what statistics is all about. Statistics is a field where you aggregate numbers, you try to draw inferences out of numbers, right? You look at some numbers and you try to draw inferences out of it. You perform some analysis on a small sample, and then you try and identify if this is actually correct or not. Extrapolate this to larger problems, like let's say there is a beer manufacturing company, right? A beer brewing company. You don't call it manufacturing, call it beer brewing company. And the beer brewing company wants to identify if a particular batch of beer if it's of the highest quality or not. Or take, for example, a pharmaceutical company which wants to identify if a particular vaccine. Take the example of coronavirus, right? It's all over the place today, right? Especially in our side of the world. So what you do is you simply try and identify if that particular vaccine, if it is actually better than the existing vaccines or not. So you do some kind of trials and you collect data and you try and identify if the vaccine is actually helping out or not. All of that analysis is fueled and powered by a very, very, very important field of mathematics called as statistics. That's the core and the fundamental pillar of any kind of analysis that people have been doing. And remember, statistics has been there for a few hundred years now. It's more than a century old, if we were to say, right? So the fact is that the stepping stone of data science, which is statistics, which is basically the art of analyzing historical data, has been, or this seed has been sown almost a century ago, right? And people have been practicing that field over and over, right? What people have realized is, as time progressed, in the mid 1950s, 1960s, when computers started to come in, right? People started to realize there were computers, and people started to build these abacuses, and computer algorithms started to come in. Computers did not become a household thing only until, let's say, 1980s, so to say, but computers did exist in the mid 1950s and 1960s. A man by name Samuel Arthur, he came up with an interesting concept. He said, while statistics is a field where there was a lot of analysis that was being done by pen and paper, but why don't we actually make computers do it? Why don't we make computer algorithms which would automatically extract hidden patterns from data? Instead of actually us doing this analysis manually, Why can we not write simple computer programs that can automatically extract patterns? So that is where the field of mathematics, that is statistics, and computer science started to amalgamate. They started to come together. And that field where computer science and statistics came together, right, was basically referred to as machine learning. A new field took birth, right? Machine learning it sounds cool. Basically, the concept is the term basically says you're building a machine that can automatically learn or that can automatically extract patterns, right? That is what machine learning was all about. Time progressed, machine learning evolved. In 1980s, as as people started to realize, people started to collect more and more volume of data, problems also started to become more and more complex. 1980s, a man by the name Geoffrey Hinton uh, then realized that while machine learning is a computer algorithm that automatically tries to extract hidden patterns, this man, Geoffrey Hinton was one of the many scientists. He's not the only father, but of course he's one of the popular ones. He was intrigued by how human brain worked. This man was intrigued by how intelligent human brain was. Of course, there's a lot of analysis that was going into the neurological space, neurosciences. But this man was intrigued by computers and human brain. So he wanted to build systems. He wanted to build computer science algorithms that would ape how a human brain was. That basically was the stepping stone. So he wanted to build systems that would act like the human brains, or that could basically try to ape like human brains, right? So for example, when you see a particular object, imagine how your eye captures information and how your brain processes that information. When you look at a human being for the first time, your eye captures. There is a sensor, basically your eyes are sensors that capture this information, and there's a part of the brain that stores that information. And there's another part, the next time you see that particular person, the same person, probably he might be wearing a completely different dress, but you still remember that same person because there are certain key elements of that particular person's face that your mind is capturing. And the point is, uh, and the point, of course, is that this particular man believed that we could build systems that could automatically that could act like human brains, and that system was called as basically neural networks. Right. This is basically a sub part of machine learning. If I were to say, machine learning is like the larger is like the larger piece. They wanted to build computer algorithms that would act like neural networks. This is in 1980s. 1990s and 1920s, people became more and more intrigued by this idea of neural networks, and they started to build more and more complex algorithms, more and more interesting algorithms that could identify faces, that could identify text, that could do some really cool stuff with text, and that could, today modern day systems have the ability to write text by themselves, right? Or you pass a color photograph, to pass a black and white photograph to a particular algorithm, and it would basically do all the color corrections and add color to that particular photograph as well automatically. Now, the point is that this is basically the evolution of the field, and one of the latest inclusions in this is called as deep learning. When I say latest, I'm talking about 15 years old, right? Deep learning is one of the latest inclusions in this particular field, and the cool thing is there are more and more complex algorithms coming in this field almost on a daily basis. There's so much that's happening, right? So the point is that data science is, now if I were to point a finger and say this is data science, all that you see on your screen is data science, right? There's so much that actually goes into data science, right? So there is statistics, there's machine learning, there's neural networks, and there is a completely different side of it where you have to learn computer programming. And if I were to kind of put this in a simple representation, this is what data science is all about, right? What you have here is, just a second, what you have here is the most important piece, which is statistics. The other side, which is the algorithms and machine learning, You have statistics and you have machine learning on one side. And along with these two together, you have one more very, very important aspect, which is, let's say, your data analysis, which is the ability to perform some quick data processing and do some kind of quick data manipulations. So you've got to understand how to work with this data as well. All of this put together is what data science is. So the point is that data science is not just about learning one side of the whole story. So if by now you would have understood that data science is not a tool, data science is not a programming language. There's a reason it's called science. It's a field of science. It's a field of science that basically performs that is tied very, very closely to pattern extraction. And if you're someone who really likes pattern extraction, if you're somebody who really likes extracting very, very interesting patterns for businesses, like for example, people who use 1 GB of data and let's say belong to a particular locality are most likely to churn out from a particular telecom company. Extracting these patterns and then building complex algorithms that can automatically make these decisions on the fly is what data science is all about, right? So the other cool thing why data science really shot to fame over the last 10 years is because less 10, 15 years is because of the presence of data. Hardware became cheaper. Our company started to store large volumes of data. I still remember my first and I'm a millennial, but imagine if and I remember my first let's say my first computer actually having 256 MB RAM, and people would be laughing at me if somebody who's probably born before me, right? They would probably even remember systems that had let's say 256 KB of RAM and things like that, right? So they were dealing with KBs long ago. But then the point is that storage became cheaper, hardware became cheaper. People started to store more and more data, and machines became cheaper, which meant that we were now able to afford machines with larger amount of RAMs, which means that I can actually crunch all of that data and generate and process all of that data and extract patterns from it. Of course, you cannot do it with pen and paper. Of course, you cannot do it with Excel. You need more complex tools. That's exactly where the tools come into picture. And the tools are like, let's say, your Python, your R, and a lot of other tools come into picture. And those tools really help us in performing complex data analysis, right? So if somebody asks me what is data science is the field of pattern extraction. How do you perform data science? Well, there are numerous ways of performing data science. One of the most popular ways of performing data science or performing data science analysis is via, let's say, tools like Python, via R, or there are a ton of other Spark, right? TensorFlow, and so on and so forth. So there are a ton of other tools that are available outside in the market today, which have grown in popularity over a period of time. And I'll talk about that also in a few minutes. But net, this is what data science is. Let's move on a little further, right? This is the point that I just mentioned about why do we need data science, right? The primary reason why we need data science is, of course, because almost since the year 1990, what we've seen is there's been a sudden spike in the volume of data that is being generated. Year over year, we see that the data growth is simply exponential. A lot of internet-based companies are coming, a lot of e-commerce companies are coming in, a lot of small and medium businesses are completely switching digital. Everybody has a mobile phone, everybody uses social media, everybody uses WhatsApp, and everybody now performs transactions with digital wallets. Nobody actually uses actual money anymore. Everybody uses credit cards and all of those transactions, which means that imagine the volume of data that's getting generated throughout the globe. Every time I move from one place to another, data gets generated. How? Because I have a watch on my phone, on my wrist, which captures the number of steps that I move. Right? I move, this data getting generated. I sit and I work, there's a volume, ton of data that, let's say, my Windows system is generating. So the point is data is everywhere. Their data is getting generated everywhere, and every company wants to analyze that data and then identify some interesting patterns of how people are how actually they're using their product, which means that every company wants data science. And if every company wants data science, every company wants data scientists. And if every company wants data scientists, you got to take this course. Just kidding. But then the point is, it's a good time for you to actually move into this field, more so because we've never seen, and data science as a field is here to stay, right? It'll evolve over a period of time. Um, it'll become more and more smarter, more and more complex problems will be solved, because the ones who are going to come in later are only going to be left with complex problems, because all the easy ones we've already solved them for them. So the point is, the field will evolve over a period of time. You would suddenly realize that your 9th standard or your 10th standard kid is already learning data science probably in their school. It's already happening, right? Kids are learning data science and engineering already, and then it's a matter of time before they start learning data science in their school, in some form or the other. This would more or less become an essential skill, and this is not a hype that would die off after a few days, right? The other interesting thing is also about, take the example of credit card fraud. I'll tell you a classic example of how fraud detection systems really work, and not credit card fraud, but let's talk about a different kind of fraud. Let's talk about the fraud that happens in, let's say, an e-commerce industry. We can also talk about credit card fraud. That doesn't matter. Something more relevant is the e-commerce industry. So let's say you as a user, right? You are a user. You're using, let's say, your e-commerce platform, Amazon.com, Flipkart.com, whatever.com, some e-commerce platform.com, and you've performed a particular transaction on this. Right? When you perform a transaction, what happens is, this is basically you and your house. The moment a transaction is performed, of course, an order is placed at the background, right? There is an order that is placed at the background. But at times, if you've observed, what happens is Amazon doesn't directly approve your order. You don't get an order confirmation right away. But Amazon takes a few minutes before they confirm your order. But what happens during that time? There are multiple things that happens during that time. The first thing that happens is they go back and they check if the product is available or not. They identify which seller to pick up, and they identify all the logistics behind that. That's one side of the story. The other thing that also happens is they validate if the transaction that you've performed, if it is a valid transaction or not. They identify if the transaction that you've done is, if it's a valid or a fraudulent transaction or not. So what happens at the background? I'll tell you what happens. So the moment you perform this transaction, there is a bunch of information that is sent, like your name, location, time of transaction, the amount, the product, right, and so on and so forth. A ton of information is sent to, if I were to say, an intelligent system at the background. Let's call it a data science predictive model. We call it predictive models. Predictive models are simply nothing but these are a bunch of simple mathematical equations that are learned from historical data. So there is some kind of a model that is sitting at the background, right? So some information is sent to this, your name, address, location, whatever, all your information is sent to that particular, the amount of money that you've paid for that product and the mode that you made that payment from, and so on. It's sent to this, and this spits out if your transaction, if it is a fraudulent transaction or a genuine transaction. Now, the moment it predicts, so it gives some level of probability. It says that this product is, this transaction is an 80% fraudulent transaction, and this transaction is, it's only 20% genuine. So if it identifies that it is 80%, what happens after this is, then it is likely.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
That you could get a phone call from Amazon verifying if you have actually performed this particular transaction or not. So you are likely to get a phone call from Amazon, or let's say from your bank as well, verifying if that particular transaction that you've done. And there's a whole system, the whole set of a team that sits at the background, which makes these phone calls, right? There's support center people, customer service people, fraud detection, customer support division from Amazon, or let's say from Flipkart or any of these companies. They automatically pick up the phone call, and they dial you up and they verify if you've performed, if you've done the actual transaction or not. They verify if the transaction is fraudulent or not. Then what happens after that is quite interesting. If they realize that it's a fraudulent transaction, it is a +1 for your model. Your model is happy that you basically, because your model has predicted something and your model has actually learned something. If your model is predicted that this is incorrect, it predicted that it is fraud, but then in reality it is not fraud. You called the customer service guy called up the customer and he said that the transaction is a genuine transaction, then it's a -1 for the model. So figuratively speaking, what we do over here is we retrain, or we remake this particular data science model relearn from the new data, right? So what now happens is, now this fellow is fed this information back, and we ask him, or this data science model is retrained on the latest data, so that now it starts to recognize more and more interesting patterns from the latest data that has been sent to it. Okay, but the question is, how was it trained in the first place? How was it trained in the first place? The way it was trained in the first place is, what Amazon would have done is Amazon would have collected a large list of information, starting from the name, address, blah, 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 transaction amount, so on and so forth. And they would have also identified if the transaction was a genuine or not. So they have a flag which says fraud, no fraud, fraud, no fraud, fraud, and no fraud. They pass this information into a predictive model. And when I say predictive model, these are the models that you typically hear names like decision trees, random forests, regressions, and so on and so forth. Those are the terminologies that basically come in here. So we pass this to that, and this particular model automatically, this model, what it then does is you pass this particular data into a model, and this gets trained on this data, and this fellow becomes now smarter. This fellow is now very, very smart, because now it has learned all of this data. So this fellow is now ready for performing predictions. So now what I can do is I can pass a new record to it, something that looks similar to this. I can pass it to it, and this fellow will identify if it is fraudulent or not fraudulent transaction. It'll make those predictions. The moment I'm happy about the performance of this fellow, I take this fellow and I put him into production. I take him and I put him into production. And then we continuously, and this fellow is like now in the war zone. Every time a transaction comes in, this fellow predicts if it is good or not, if the transaction is valid or not. Now, this system is now become an intelligent system. Earlier, how was Amazon doing it? There were people who were manually trying to identify if the transaction was genuine or not, because there was manual verification that was happening at the background. Now what they've done is they've replaced that manual verification with an intelligent system. So when you place a transaction and when the order doesn't get confirmed automatically, what's happening at the background slowly is that it would take a few minutes. The Amazon machine or any e-commerce platform, what they do is they go back and check if your transaction is valid or not. Now this is valid even for, let's say, a credit card company. If you make a transaction on, let's say, your credit card, and let's say this credit card transaction suddenly comes from Vegas. I don't know how many of you have actually realized this. If you make a sudden transaction against a company where you've suddenly traveled out of the country and then you've performed a transaction, the very next moment you get a phone call from the company, basically asking if that particular transaction is valid or not. It's the same concept there as well. Think of it this way: every time a mail comes into your inbox, what your email does, your email server, your Gmail, or let's say your Outlook, what they do is they predict if this particular email, if the content in that particular email, if it points it towards a junk email, or if it is, let's say, if it is a genuine email. Based on that, it would drop it into one of these two places. So there is a lot of intelligence that goes into that as well. So based on how where you use this kind of a concept, there are numerous applications of this particular system that we've just learned, and there are so many ways that you could that you could actually implement these, in so many industries that you could actually implement this particular thing, right? Let's go back. That is basically what we mean by credit card fraud detection, credit card fraud, or any fraud detection. There's so many things that go into predicting fraud, right? I see some question from Kodishwaran. There are so many parameters that go into it. It could be the location from where you're performing the transaction, all the financial details of your mode of payment, from which bank it's getting routed, from which country it's getting routed, who is the issuing company or the issuing bank, and from which country is it based out of, and there's a ton of other, and what product have you purchased, what's the price of the product, and so on and so forth. There's a ton of information that goes into it, and it's not a manually crafted pattern, right? These patterns are learned over a period of time. Cool. So where can you implement data science? Data science basically can be implemented in a ton of places. These are just a few of the many that can possibly that where you can actually implement this. You name an industry and I'll give you 100 use cases of 100 use cases of, if not I, at least there are people where data science is currently being implemented. It's just that we don't actually have to see it, because systems are becoming intelligent by the day, which means the moment you don't realize something dumb happening, that means there's a lot of data science that's going on in the background. Swiggy or your Zomato, or let's say your DoorDash, all your popular food delivery apps that you have in here in your own respective countries, there's so much intelligence that goes into it. What dish do you want to eat, and what kind of what restaurant do you want to order this from, and so on and so forth. So much intelligence that goes into it. Predicting the ETA of your delivery, 20 minutes, 30 minutes, identifying how long would the delivery person actually take to deliver the product to your house. There's so much that goes into that as well. Right? Now the thing is, there are these popular names. I actually don't want to confuse you all with all these names. These are those popular names and popular terminologies that you would see outside. When you see these names, now this is not to either show off or b to tell you all these complex jargon and frighten people. This is basically to simply tell you that when somebody talks about data science, these are common terminologies that people often use, the common jargons that they use. These are not really that complex, to be honest, right? So these are all those cool techniques which is basically helping this algorithm to learn, right? All those are those cool techniques that is helping that algorithm to learn if a transaction is fraudulent or not, if the car should take a left or a right, or predicting if a customer would quit or not, would churn out or not. Imagine your company is doing some kind of analysis on you guys, on predicting if you would quit your current job or not. It's scary, right? But then it actually happens. A lot of companies spend a lot of time in predicting if you guys continue to work, if you will continue to work, or basically predicting employee attrition. A lot of companies do this analysis. What goes into it? Think about it. Think of what kind of digital trails you're leaving to your own company. So your browsing patterns, your leave patterns, your work style, your performance, all of that is a nice indication of your interest towards quitting the company. How often do you visit the careers portal in your own company? How often do you visit LinkedIn? I don't know. I'm just saying. I mean, they could do it if they want to, but then we don't really know how many companies actually do it. But then, yeah, these are interesting scenarios to predict if you're going to quit the company or not, right? So all these are those algorithms that are going to help us build intelligence in extract patterns from your data and then build these cool models, so to say, right? I'm going to talk about this a little, and I'm going to talk about this a little about what data science processes really are. The first and foremost is about how do you solve a data science problem. Now remember, data science is all about if you want to extract pattern from your data, you've got to pass the right data into it. So Zafar has come back with a question saying, why are algorithmic traders not rich? Well, the algorithmic traders are not rich because data science is not magic. It's not sorcery. that is automatically going to extract patterns for you. When I say extract patterns, there's a lot of work that goes into training these algorithms, right? There's a lot of work that goes into passing the right kind of data, extracting the right kind of data. If I ask you what impact, let's say, the stock price of Amazon, right? There are a million things that impact the stock price of Amazon, right? So then how do you, if you can pass all of that information to the algorithm will do well. Now tell me one such scenario where all such information is readily available for you. Not just for you, even the algorithmic traders are not going to get all of that information. If you have that information, then you're rich. So that's the reason data is like gold mine today, is more costlier than gold mine today. So you have all of that data with you, then you can mine, or then you can build these complex algorithms. If you don't have that data, there's nothing that you can do about it. So data is the next most important natural resource. If I have the data, I can do wonders with it, right? So that's the reason why not all algorithmic traders are rich. A lot of algorithmic traders are rich, by the way. Not all of them are rich, at least. Okay. A typical data science solution goes through a certain set of phases, steps, if I were to say. The first one, let's say, for example, take that example of fraud detection algorithm that we just spoke about a while earlier. The most important piece of data science is to understand what business problem to solve, right? Technology is readily available for us. There is technology that is there. You could make use of tools to solve a problem, but then you need to know what you want to solve, right? So it's like having a calculator with you. A calculator is only as efficient as the user, right? So if you don't know what to punch into the calculator, and if you just learn how to add two numbers in the calculator, you'll only be adding two numbers in the calculator. Similarly, data science is a long list of techniques that are available with you, but you need to know where to apply these. Right? To know where you want to apply these, you need to understand what business problems are available outside. So if you're working in, let's say, a telecom industry, or if you're working in an insurance industry, or let's say you're working for a stock brokerage company, you need to know what is the most important business problem that you'd want to solve. So understanding the business problem is super critical. When I say a business problem, take for example, my most important issue today as a telecom company is that a lot of customers are quitting my service and joining someone else. So can I build an intelligent system that can automatically predict who are likely to quit and then give them a relevant offer so that they stay back? So now what you've done is you've basically converted a business problem into a data science problem, right? So converting such business problems into data science problems is super critical, and that's what the first step is going to be all about. Once you identify a particular problem and then you try and you decide to solve that particular problem, then you move to the most important phase, which is the data gathering phase. And the point that I just mentioned to Zafar a while ago is the data gathering phase, where you try to gather as much data as you can about that particular business problem. So think of, in a telecom company, what are those factors that really cause a particular person to quit, right? Bill shock is what we call it. Bill is a primary reason why people quit. People quit also because of bad service, call drops, right, is one of the biggest issues. Bad internet issues, network availability is a big issue. Value added services, you don't have enough value added services. All of these are major reasons why people typically quit. So what you're essentially going to do is you're going to move from the field of you're essentially going to capture all of that, all of those features, and then pass that into, and then do some kind of quick data analysis and data processing. So you capture all of that data, but all of that data is not going to be in the best format for you. So what you do is you identify if the data is of good quality or not. And then what you do is you go ahead and you join different data sets from different data sources.
Also guys, if you're looking for an end-to-end training in Python for data science, Intellipaat provides a Python data science course and training which covers all of the concepts which you need to learn and also will help in getting you a job. So for more information, check out the description box below or visit intellipaat.com.
I get data from, let's say, the billing system. I get data from the network system. In a telecom company, each system is separate. So I collect all of this data, I bring all of that data together. Once I get that data together, I do some basic analysis about how good my data is. I do some quick visualizations, just to understand my data a little better, right? Picture speaks 1,000 words, right? You don't really have to spend a lot of time in actually analyzing the data. Visualize it, and then you'll start to see interesting patterns come out of charts. You create those interesting charts and visuals. Becomes very easy for you to digest your data. Then what you finally do is you then prepare your data, and then you go ahead and build your model. Building the model, all of this has building the model is basically using the techniques that we saw in the previous slide. A few, there are more than these techniques, to be honest. These are just an example, commonly used techniques, but they're more than these techniques. If I were to list them out, it would probably take me the next half an hour to list all of them out. There's so many techniques are available out there, but basically the point is we use those techniques to solve these problems, right? Creating and testing a model. Once you're comfortable, the next step, of course, is to go ahead and deploy it. That's basically the life cycle of your data science problem. Now, I've oversimplified the whole process, but at a 10,000 feet level, if I were to explain you what is data science and how data science problems are typically solved, this is a nice representation of how your data science problems are generally solved. Okay, there are more layers to this, and there's a lot of layers on how on what kind of people are involved in this whole exercise. One of the things that I'd like to talk about in this particular slide is that as a data, see, if you imagine until your last step, 6 out of the 7 steps have got to do simply with data cleansing, data extraction, data analysis, and this and that and this and that. Everything has got to do with data. So remember, garbage in, garbage out. All right. So if your data is not of a great quality, then your system is not going to learn any patterns out of it. If you don't have any patterns in the data, then you cannot extract those patterns. So don't blame the algorithm for it, blame the data for it, right? So you've got to make sure that your data is of a great quality. If the quality of the data is good, then automatically your patterns are going to get extracted very well. Okay. So because a lot of our work has got to do so much to do with data and so much to do with data extraction and so on, what we have seen is that there are a certain set of roles that most frequently operate with data scientists, and I'll tell you what they are. Right. So there is a data scientist, of course. The prime responsibility and the prime expertise of this data scientist is to apply these complex algorithms and perform pattern extraction and so on and so forth, do visualizations and do some pattern extraction and so on. But what we've also seen is that certain aspects, you cannot expect the data scientist to do data gathering and also to do deployments and everything, right? So there are people around the data scientists who help data scientists, right? There are other roles around data scientists who help data scientists quite a bit. Typical terminologies are, you have a data analyst or a data engineer. Let's call him a data engineer. A data engineer is someone who is responsible for doing the data gathering, right? So data engineer, what they do is they build data pipelines, they collect data, and then they put it in a particular location for us to use it from there on. That's what a data engineer is all about. Then you have, let's say, then you basically have somebody from, let's say, your deployment teams. We call them, you can also call them as, let's simply for the current sake, let's call them as deployment specialists or deployment teams. They are responsible for deploying the models that you've built. So you've built a model, and then they often take the model from you, and then they go ahead and they deploy it in the production systems. They are the ones responsible for scaling out your problems. We call them ML engineers, big data engineers, and so on and so forth. But essentially, these are the ones who are responsible for your deployments. And then on the other side, you also have some business specialists, business experts, who specialize in the business side, business stakeholders. They are the ones who understand the business. They are the ones who evaluate if the models that you've actually built is of real business value or not. But in a lot of ways, a data scientist is also expected to bits and pieces of each of these. It depends on the size of your organization, size of the company that you're working in. Certain companies, you have these teams well demarcated. In certain companies, you might not. As a data scientist, you're expected to do all of it by yourself. So it depends on how big your organization is. It depends on how well structured the data science teams are there in your organization. But remember, your core skill as a data scientist and your core skill out of this course that you're going to learn is going to be data science, which means it's the art of pattern extraction. Don't expect yourself to learn data deployment at the end of this course. That's not what we are headed towards. Don't expect yourself to perform to build data platforms at the end of the course. That's not where we are headed. What we are headed in this particular course is to equip you all with all the necessary skills as a data scientist. Right? What do you mean by data scientist? Somebody who can explore data and understand and build these intelligent systems, understand the data, visualize data. Somebody asked me, why do you need to visualize data and why do you need to clean data? Imagine a lot of companies, what happens is when you fill your data set, when you fill an application form, how many of us have filled the application form with utmost with utmost commitment? Half of us don't even care about the fields that are there in certain application forms, and we choose not to write them. So there's a lot of data cleansing that needs to happen. So when you're manually typing in forms, manually entered data requires a lot of data cleansing, right? Because I might write, let's say, I might be very bad at my spellings and I might write the term Philadelphia incorrectly because I did not learn the spelling of Philadelphia correctly. But you might require some kind of data cleansing to clean these incorrectly written data out. You might also have to write, so somebody might write their PIN code as 00000, just so that people don't get to know what their PIN codes are. So there is some kind of data cleansing required to get rid of such data set, such records. Hence, data cleansing becomes really important. And why do we need data visualization? The reason why we require data visualization is because you might be doing a ton of analysis, something that only you understand. But then how are you going to convey the story to, let's say, how are you going to convey this story to somebody who does not understand data science? The best way to do that is by putting in charts together. You perform some kind of simple visualization, and that visualizations are going to help us in conveying the data story to somebody who's not from the data world, so to say. That's where visualizations become super critical. They are a very, very strong form of communication to a community that does not understand data at all, right? Hope that makes sense as well. So the point is that there is a ton of roles that are available outside today, but remember what we are targeting is a data scientist. That's what we, I mean, there are different names that people are called at, of course. You also have a term called as big data, right? All of this is great, but what is big data then? So big data is where things become very interesting. Big data is basically that particular field, which has got to do with the data engineering side of the world. Right? Big data is a field got to do with the data engineering side of the world. I mean, partially with data engineering and partially with data science. There's an overlap between the data science and data engineering world. So if, for example, if you were to deal with large volumes of data, right? Take, for example, the amount of data that an aircraft engine generates. An aircraft engine has got a few hundred sensors on it, and every second ton of information is generated from one single engine. And there are so many engines, there's so many flights that are in flight, and across the year there's some millions of terabytes of data is generated in a given year by, let's say, a simple aircraft carrier. Your cars generate so much data, right? When such large volumes of data come in, the first question is, where do I store it? Like, forget about analyzing it. Firstly, where do I store it? Right? So then you require complex data platforms to be built, interesting data platforms to be built, so that you can store that data, and not only store the data, also retrieve that data. So big data analyst, or when you say big data and big data analyst and Hadoop and things like these, are basically technologies that help us in building these complex data platforms. Let the data flow in. But then what is big data analytics? Why does the term analytics come in there? The reason why analytics and big data and data science are often very well spoken together is because at the end, the largest consumer of this data is a data scientist. So what does a data scientist do? A data scientist then takes that large volumes of data and then builds complex algorithms. What that means is that we should, as a data scientist, I should also be well equipped to not only work with small volumes of data, but also work with large volumes of data. Right? That's one of the reasons why a data scientist is also expected to have some knowledge about big data. So remember, a big data analyst is somebody who is or big data engineer is somebody whose primary responsibility is to move large volumes of data from one place to another place, store them, do ETL, do some transformations on data, do some loading of that data, and that's where they are. That's their space. Our space is to make use of that data and build complex algorithms. And there's an overlap between these two. That's basically where big data and data science sort of have a slight overlap. But remember, it's not our responsibility. And a lot of companies have this very well demarcated. Even the small companies have a data engineer and a data scientist well demarcated. Generally, there's a decent demarcation even in small companies. But again, it depends on the role that you're picking up and things like that. The tools that we will generally be learning that you as a data scientist, I'm not talking about it from a simply the course standpoint. I'm talking about in general data science as a field. What has happened is Python has more or less become the ruler of the industry today, right? Python is the most popular data science most popular tool preferred by data scientists. Second comes R. There has been a very tough competition between Python and R for a very long time, but slowly what has happened is Python has taken over. Python has become more and more popular. The reason, of course, there being the fact that Python has more capability. It's much easier to build Python models for production. R is great for experimentation, but Python is really great to build production grade systems. So that's the reason people have moved away from R towards Python, and that's the reason that's one of the cool things about how Python has become really very popular. So Python and R are of course the two most popular tools for doing data science. Python is of course meant to do a ton of other things as well. You can build websites using Python, you can build games using Python, you can build web apps using Python. There's so many things that you can do using Python. You can do data engineering using Python. There's so much that you can do. The only point is that Python as a tool, one of the key things that you could also do with Python is data science, right? So we're going to use Python for data science, and whenever you attend a data science session, the kind of Python that you're going to learn is, of course, you're going to learn the basics of Python, but of course, you will learn Python from a data science lens. So you're going to learn all those libraries and all those tools and packages that will help us in performing data science analysis, right? So that's basically tool number one. In parallel, while these are tools that are really cool for performing analysis, what has also happened is...
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
To be a really useful data scientist, the other thing that you are also expected to learn is some SQL, right? Why do you need to learn SQL? Remember, I mentioned to you that our responsibility is not just about building models. Our responsibility is also to take that data and build models. Take a data that is available somewhere and then build models. Nobody's going to feed things into our mouth. So, which means that a data engineer is going to do his part of moving the data and then putting it in a particular location. But from there, moving that data from the databases and doing some quick analysis on the database side and then moving it into your own Python environment means that you will need to learn some SQL as well, some basics of SQL as well. While these are great, the other, if you move from, let's say, basic and intermediate courses to advanced courses, what you will also learn is Python also has got more complex variants in it called as, let's say, PyTorch. For example, if you're moving from traditional machine learning to, let's say, deep learning courses, so then you will have to learn other packages of Python. When I say packages, other modules of Python, which are called as PyTorch or, let's say, TensorFlow or Keras. These are the ones that are going to help us in performing big data. So these are the ones that are going to help us perform deep learning. So this will help us in deep learning and let's say neural networks. So this is basically regular machine learning, but if you want to move from regular machine learning to advanced concepts like deep learning, this is basically where the play is going to be. You'll have to learn these tools like PyTorch and Keras and TensorFlow and things like that. That's where don't think of these as different tools. They're just different modules of Python. That's about it. It's still Python as a programming language only. Okay. On the data science, on the data engineering side, what you will need to learn, while SQL is good enough for regular machine learning and simple data, when you're working with complex data, large volumes of data, that's where you might have to learn a tool called a Spark. Why? Because the moment the volumes of data become larger, you cannot fit a 1 terabyte of data in your machine, right? You'll not be able to open it. Forget about doing analysis. You will not be able to even be able to view that data. So to actually perform such large volumes of, to perform analysis on such large volumes of data, that's where Spark becomes very, very useful, right? So that's where we'll have to learn Spark as well. And that is basically what you see on your screen is the landscape that is currently available today. Python, R, SQL, and of course you have Spark and other tools as well that are available outside today. Okay, so that's the landscape. In most of the courses that you're going to see, even in the Intellipaat course, and let's say most of the courses that you will typically see, this is, if you, I mean, being a good Samaritan, you got to make sure that the tools that you're seeing outside are covered. Wherever you pick up, whatever course you pick up, got to make sure that the tools that you see outside here on your screen are covered. At least one of these two, this, and this, basically is what you should ideally be looking at based on again the complexity of the course. If it's a small course, just a short course, then Python, SQL are good enough. But if you're taking a longer course, then expect yourself to learn all the other tools as well. Deep learning is the next big thing of big data. Deep learning is the next big thing in data science. Big data and Spark are basically for, are on the data engineering side. Think of it this way. Spark, big data are on one side of the spectrum. Deep learning is basically the next big thing in the data science industry. It's not the next big thing, it's already the big thing. For a typical data scientist, right, what happens is a data scientist can actually join in as an apprentice, a junior data scientist, and can become a senior data scientist, can actually become a lead data scientist, a data science manager, and then you can have a VP data science and CEO data and analytics and so on. A CIO data, or a VP data and analytics, and so on and so forth. So you have roles starting from as low as, let's say, an apprentice entry level data scientist, all the way till the end, right? All the way till a CXO level, so to say. So there is, in a lot of large organizations, these roles are very well defined, and there's a nice career path, so to say. But in general, if you want to be a data scientist, expect yourself to be a hands-on data scientist, at least for the first few years. Don't expect yourself to straight away enter as a manager, or let's say as a lead straight away. Expect yourself to do some kind of hands-on initially as an individual contributor, and then you can move into other larger roles. There are two kinds of data. The first one is structured and the unstructured. I'm going to repeat this point for you all once again. Structured and unstructured data. I think the structured data that we're talking about is data that can fit in a table, right? In an Excel sheet like a format, right? You have rows and you have columns. So you can basically enter data in a row and column format, right? So think of it that way. So you have customer ID, and then you have, let's say, information about all that particular customer, and all of this information is nicely stored in, let's say, a tabular format. Unstructured data is data that does not fit in a tabular format. Take the example of an image, photograph, right? When you want to do some kind of analysis on a photograph, or you want to do some kind of data analysis on, let's say, videos and audio and so on, that does not fit in a Excel sheet, or that does not fit in a simple that you cannot store that information in a tabular format. Hence, such data is referred to as unstructured data, because there's no structure to that data, right? That is what we mean by structured and unstructured data. As data scientists, we work both on structured and as well as unstructured data. Okay, that is what we mean by structured and unstructured data. Data scientists work on large volumes of data. Data scientists work on big data sets, so to say. Yeah, that's basically the relationship between these two.
Why do we require Python for data science? What makes Python the gold standard when someone thinks about data science in today's world? Well, of course, let me tell you this by starting out saying that Python is the #1 programming language in today's world. I still remember the days when Java was still the king of the programming languages, and then Python came out of nowhere with this popularity, with this huge, powerful community. Of course, open source community. Python is a free language, and these guys started developing the language in such a beautiful way. It has beautiful syntax, it's very easy to use, and it scales across multiple domains, be it artificial intelligence, be it natural language processing, be it handling and designing web pages, whatever it is. Python is there, and it's expanding rapidly across various regimes in today's world. With respect to data science now, in fact, let's dial it down one more notch before we talk about the specifics of Python for data science. Let's talk about how simple and readable Python actually is. Now check this out. I have a Java code in front of you guys, which basically prints one output on the screen which says hello world. Do you see the amount of characters, the amount of complexity that goes beyond the understanding of the common man to basically get at this output? Well, all we're trying to say is, hey computer, can you please print hello world to me? And look at how we can do it in Python. if you were a programmer and you understand that data science is a very complex arena with lots of statistics, lots of mathematics, and lots to do with artificial intelligence, data handling, data pre-processing, data analysis, and whatnot, I think this would give you a lot of clarity on what would be your best choice to pick up a language, right? Well, I've just given you a very clear examples on the basic statement of how to print something. Well, I can tell you and I can assure you that with respect to all of the other syntaxes in Python as well, this is exactly the same case. Even if you do not understand the syntax, when you're using Python, the advantage it gives to the readers is that you can actually look at the syntax and figure out most of what it says, and you do not even have to know what it means to sort of, guess what it's doing. With respect to other programming languages, I believe this is not true, because I was there a couple of years ago, in fact, when I was trying to figure out syntaxes of languages that I did not know, and it was really tough for me at that point of time. So what do you guys think about Java and Python? These two are the top programming languages. Of course, we have other languages in the world of data science as well, but then to understand that in the complex world of data science, keeping it simple is everything, and I would emphasize more on that. And again, here in my opinion, Python wins for just being simple and having the high readability. Now let's talk about a little bit in terms of what it offers when you're working with big data. In the world of data science, as you might know it, there is tons and tons, gigabytes and petabytes of data, which is basically, generated on a daily basis. When that is the case, you need to have the statistics, you need to have the tools, you need to have the techniques to handle all of this very easily. Well, again, with Python talks amazingly well to all of the big data frameworks out there, be it Apache Spark, be it Dask, be it PyDoop, or any other framework which basically handles all the big data in today's world. With Python and with all of these tools, we can bring the power of parallel computing to today's world. You might be wondering what parallel computing means. Well, let me tell you that basically, if you have a task which needs a lot of computing power, instead of making it run on one single computer, you can actually assign it to multiple machines in a network and use the computation power and leverage that extra power to get it done. So now, instead of stressing one single machine out, you can spread this task across and get the same job done easily, quicker, and in a more efficient way with respect to multiple computers. Now, I just made it very simple for you guys to understand, and there is a lot more complexity of where this comes from. And even in that case, referring back to my first point with respect to Python, it makes it really easy to work with the first step of data science, which is basically to handle the data, bring in the data, and even perform some pre-processing with the data. Now, artificial intelligence is something most of you would have in your mind as soon as you clicked on this live session, right? Well, I've got you covered. Well, whenever we talk about artificial intelligence, you need to understand that AI has been the paradigm shift that the world was looking for, because now we have numbers saying that, we can prove artificial intelligence is an entity which is helping humanity to its maximum. There is a 44% increase in basically enhancing the products we use by using artificial intelligence. We can optimize all of the operations within our organizations, within our companies and firms by up to 42% by making use of AI and its related concepts. And believe this, we thought humans were the best when it comes to decision making, right? Well, of course, I would agree on that point, but then to add on to that, well, with respect to that, we can make better decisions with over 35% of guarantee when we use artificial intelligence. How cool is that? And of course, we can optimize external operations by up to 31%, and we can free workers to be creative. We can make sure that they're not doing the mundane tasks which can be done by computers in today's world by over 31%. Well, you might think, okay, these are just percentage numbers which might not mean a lot to me. Now think about the billions of people, if not the millions, who are actually in the world of IT and who are actually waiting to revolutionize the world, who are waiting to jump on this trend. Now, all of these numbers will be extremely beneficial to the people, will be extremely beneficial to the employers as well. Let's come back to the specifics of Python. The first thing is that when you're working with Python provides a very efficient way to help you process all of the data. When you're working with artificial intelligence, you need to understand that having more data equally relates to getting your model trained better and helping it become more let's say intelligent. Now when that's the case, you might be wondering, okay, so how big is the data? Well, this depends on each of the scenarios, but then with the general understanding that we need more data to train the models better, you need ways where you can efficiently process this data, right? With more data, you will be inviting more complexity. With more complexity, you will be inviting more problems. And of course, we don't want that, right? That is exactly what I'm talking about. When you're working with Python, it gives you very elegant ways on how you can handle data, which of course we'll just check out in the upcoming slide. And then coming to the vast library ecosystem of Python, of course, as I told you, Python is one of the biggest growing programming languages in today's world. When it gets that kind of a tag, when it gets that kind of an attention, there's a reason for that. And I believe this is the reason for that, because it provides thousands and thousands of libraries for people to work with anything that they have in mind. So let's say you're trying to solve a problem now and you're stuck at any point. Well, basically all you have to do is, the first thing if you're working with Python is just Google it out, find out if there's a package in Python which will basically help you for that. And if by chance you're in luck, let me tell you, 99% of the time there is a package, there is a library in Python that will basically help you with exactly what you want. And this is amazing because we're catering to millions of people here with probably hundreds and hundreds of thousands of problems, right? When that is the case, all of these libraries which are present in Python will be the guiding force to solve these problems quicker. Coming to visualization tools, again a little more on this in the next slide, but then you need to understand that with Python, with all of the frameworks and the library extensions of Python, it becomes a very, very powerful tool when you're working with data science. And of course, community support is everything. If you're stuck with a problem, you have a community which is open source, which is widespread across the world, where you can dive right in, ask your question, and even solve the problem probably in under 24 hours, no matter where you're in the world. So this is the kind of community support that we have with respect to Python. And this is the reason thousands of companies around the globe have invested in Python, have invested in Python developers as well. Now, coming to the specifics of a couple of libraries that Python provides for the data scientists out there, we have two main concepts, and the first of it is numerical computation. Working with numbers, making sure that your mathematical game is up to the picture, ensuring that you can perform these computations and operations in arrays, be it in the form of matrices or whatever it is. Pandas and Numpy are the library in Python to be made use of just for this purpose. Coming to data visualization, you can create beautiful looking plots by making use of two very good data visualization libraries, which is Seaborn and Matplotlib. Of course, these are just like one or two tools in a whole pool of tools, and of course we're going to be looking at this a little more here as well. And this brings us to the Python developers trends of today's world. You might be asking, okay, so if it's the top job in today's world, if there is a huge requirement for Python developers, what do the trends look like? Well, you will be astonished that there are over 2 million jobs in 2020 and beyond. It is told that every year there is almost an addition of 500,000 jobs for Python developers. Yes, 500,000 every year, and in the year 2020 we have 2 million job openings for Python. So this is amazing. When you even look at the Google Analytics chart, you can see on the above. So this Google trend picture is trying to show you the interests of people over time, when all the way from 2015 and coming to 2019, and even showing a bit about 2020. At the end of it, you can see steep rises, steep curves everywhere, and there is a reason for this, and people understand that this is adding a lot of value to their organizations, and this is adding a lot of value to themselves as Python developers as well. Hence Python is this amazingly easy to use, friendly and trendy language out there now. If you're wondering what is the average salary that a data scientist gets in today's world, well, these numbers are amazing. So the average data scientist salary really does not care for inflation around it. And this sounds funny and humorous, but then it's amazing to see that right from 2014, which is now 6 years before today, the data scientist salary has always been above 120,000 American dollars. $120,000. This has been increasing, by the way. I have friends who are data scientists who make well around $190,000 to $200,000 per year as well. So when this is the situation, so you need to understand the importance of the salaries, because again, at the end of the day, we might be looking to make a career out of it for our lives. We might be just people who are interested in Python or anything. Knowing that there is a lot of potential here is very important. The average salaries in the United States of America is over $90,000 and all the way up till $140,000 and up. Be it recession, be it any sort of downs in the world of IT, a Python developer, a data scientist who can work with Python will get paid and compensated in a really nice way regardless of all of that. When we talk about India again, everything from 8 lakhs per annum all the way to 24 lakhs per annum. So basically what I'm trying to tell you guys here is that regardless of your experience, you might have questions asking, saying you might not be from a computer science background, but you want to jump on the train now. Well, let me tell you that, there is no strong requirement and prerequisite when it comes to becoming a data scientist. Of course, if you pick up a structured program where you're taught all of this from scratch, at the end of it, you can become proficient in data science without having to have any prerequisites of any sort. Coming from that kind of a thing to understanding that there is huge salary on the other side and it's trending and there's millions of jobs out there for Python, for data science out there, I don't see any disadvantages here at all. Now, if you're wondering what is the demands for data scientists in today's world, well, let the screen load right now for you guys. I have filled the screen end to end with people who are hiring constantly for data scientists, for people who know how to work with Python when it comes to data science. All of the social media that you can think of will make use of data science and Python in one way or the other. Be it Instagram, LinkedIn, Pinterest, Viber, WhatsApp, I can name everything on your screen right now. Amazon, YouTube, Unisys, Fractal Intelligence, again, basically Mu Sigma, IBM, Ernst & Young, Edgeworth, Ola, Siemens, Oracle, and everyone else, even Adobe and Apple. So basically everyone on your screen right now is hiring. So, you need to put yourself out there and you need to have a data science oriented profile to basically, land a good job at all of these people who are hiring. You might be asking, well, how can I do that? Well, in my opinion, as I just mentioned, a lot of project works and a lot of industry level experience where you have a good amount of hands-on, where you have a good amount of teaching and structured learning will basically help you get there. You might have 10 certifications in hand right now, but then what if you do not have the ability to clear that interview, right? So that's what I'm basically talking about. A good certification program will ensure that you have the right experience. It will ensure that, so you can crack interviews at all of these companies is what I'm saying. Now, if you're talking about job satisfaction, again, in the world of IT, there were multiple surveys conducted from 2010 and above, and people say that if they're a Python developer, they are about 80% satisfied with their job. You might be wondering, well, it's only 80%, it's not 100%, right? Well, no, 80%, trust me, is a lot when you're talking about an IT job, when you're talking about a job which requires you to program, which probably requires you to perform data pre-processing, data analysis, probably pushing you to achieve some sort of artificial intelligence, use deep learning, use machine learning, use data visualization, create dashboards. Well, that was a mouthful. You get the point. If 80% of these people, if 8 people out of 10 people are, immensely satisfied with their job, I believe that Python is adding a lot of value to the world of data science. Now, on that note, you might be asking the question saying, what are the packages that are available when you're working with data science? We already covered 2 or 3 packages in a very gist before, right? Now let's take a look at Pandas, for example. Pandas is a beautiful library in Python which will help you with all of the data structures that you need. And you can work with data wrangling concepts, data cleaning, data hunting, and in fact, even data manipulation and data visualization. So basically, if I have to order up everything that I've mentioned on the screen, from data cleaning, from, adding data structures to whatever raw entity you have, to manipulating that information and to visualize all of that, well, one library can do it all for you with respect to Pandas. And this, in my opinion, is again a beautiful thing in a programming language. And Python is all about these these kind of libraries and packages out there, and Pandas is surely living up to the name to be one of the best libraries out there for that. And of course Numpy, when we talk about Numpy, numerical computation, array processing, array operations, even linear algebra concepts, guys. So basically for all of these needs, Numpy really stands strong, and it makes your life a lot easier with very good syntax, high readability, and at the same time ensuring that you can put in the required time to solve the actual problem at hand rather than worrying on the syntax. That is what Python is about. Then if we talk about more packages, we have SciPy. So SciPy is of course a beautiful library when you have to work with all of the statistical concepts out there, and we need a lot of statistics when you're working with Python as well. Linear algebra, calculus, integration, all of these mathematical concepts follow slightly behind in the world of statistics, and these form to be the foundation in my opinion. Making sure that as a developer you can work with these easily, well, that is all the goal about SciPy, to basically help you on your data science career. Now, if you're being worried about data visualizations or how we can create, beautiful looking graphs, well, let me tell you this, Matplotlib is a beautiful library to do that. In a recent survey conducted, it is noted that humans can perceive images 3000 times faster than numerical data. If that is the case, would you like to see an Excel sheet filled with thousands of rows and columns of data, or would you like to see one or two beautiful looking graphs summarizing all of this information? I am sure you guys will say the graph, right? Of course, with this you can plot amazing 2D figures, you can work with it as an object-oriented API, you can perform very good data visualization, and at the end of it, if you have to compare it to any other tool out there, it is very similar to the working of MATLAB as well, in case if you have used MATLAB. So on that note, again, to come into the side of machine learning, to come into the side of artificial intelligence, we have scikit-learn. Scikit-learn is a beautiful library which will help you by providing all of the machine learning algorithms out there. Be it supervised learning, unsupervised learning, reinforcement learning. You have everything from classification and regression for supervised learning, clustering for unsupervised learning, and of course, it will help you tune your model, work with model selection, and much more. Scikit-learn is again an amazing library to work with, and I'm sure if you guys have had experience and exposure to machine learning, so you would have used scikit-learn on a minimum of once or twice while learning on that. Coming to TensorFlow is the gold standard for being the deep learning library, for being the library for neural networks when you're working with Python, and this forms a very important role of data science, because one of the majority goals of data science, as I've been repeating, is to ensure that you can achieve artificial intelligence. With TensorFlow, you can perform analytics on steroids. Yes, I just said that. Why do I say this? Because you can perform everything from sentiment analysis, voice recognition, face recognition, even TSA. TSA is basically time series analysis, and these are just the 4 things that I have put out here. When you're working with neural networks, such a complex procedure that you might think, we are trying to imitate how a human mind would think, and we're teaching a computer using those techniques, right? Now, you might think this is very complex. Well, let me tell you, it is complex if you probably work with any other programming languages. When you're working with Python, TensorFlow, and even there's PyTorch as well. PyTorch is basically another package for data science. So when you're working with libraries like TensorFlow and when you're working with libraries like PyTorch, it makes it so much easier to work with these. And I've been using TensorFlow and PyTorch for years together now, and I have fallen in love with it, guys. So again, if you've ever used TensorFlow or any of these packages, again, head to the comment section and let us know what your views on this is. And on that case, we've come to the section where we'll quickly check out a use case in Python to show you how easily you can handle data in Python. Just before that, let's talk about the use case. You might be wondering, so let's just say you're in the market for a new house now, and you might be wondering what concepts, what is the basic factor, what is the basic foundation of where the house pricing lies. So how will you understand how much price to pay for a house? What are the factors that is involved in knowing that one house is very expensive compared to the other? Is it because your house has a lawn that it is expensive? Is it because it has a swimming pool? Is it because there is a car parking available, a basement available, a lot of square footage of living space and whatnot? Well, let me tell you that there is a lot more depending on this when you're considering about, putting the most value to a house. What adds most value to a house is exactly what we're going to check out in our demo today. Let us see what are the factors which will play a very, very important role in assessing the price of a house and in validating on how people would like this based on those factors. Now, let me quickly jump to Google Colab. So Google Colab is basically a Python Jupyter notebook hosted on the Google platform. With this, we can basically write Python code online. It will be stored always, and it makes it very simple and nice to work with as well. So on that note, let us quickly jump into the code. The first thing you need to do when you're working with any sort of Python project or any programming project, in my opinion, is that you need to begin by loading all the files that's required, loading all the libraries that is basically required. Here, we're going to import all the libraries which is spoke about. We spoke about Pandas, we spoke about Seaborn and Matplotlib, which will basically create beautiful looking visualization for us. And of course, in some cases, data visualizations will not work, and this is just for the cases where it might not work. And we're going to be using a plot style called as BMH. BMH is basically Bayesian method for hackers, and it's a beautiful visualization way as well. So let me click this play button, and it is as easy as this. Now, as soon as that's executed, basically what it's trying to tell you is that it's done. Now, we need to load our data set. So how do we load our data set? And as soon as I run this without the data set loaded, it's going to throw an error now saying, hey, you know what? I cannot access the file that's present. So where is this file called training.csv? Well, let me quickly click on the tab on the left side, click on files, let me upload it. And as soon as I click OK, it'll start uploading. You can see here on the bottom left. And as soon as that's uploaded, it basically is in the current runtime now. It will basically expire as soon as the runtime is restarted. But until then, we will have our data set loaded and ready. And as you can see here as well, we have the ID for the houses and we have a lot of information here. Everything from the lot frontage, basically telling you the square footing of the front lawn or the porch area. We have the total lot area, is the street which is paved, does the house have an alley. You can check out a lot of configurations as well. So is it inside a neighborhood, is it in the corner, what kind of a neighborhood is it in a college area and whatnot, what is the condition of it, what is the building style, what is the house style, is it a 2 BHK, is it a 3 BHK and whatnot, the overall quality based on a rating of 1 to 10, the overall condition right now, what is the year that the house was built in. This is of course a very important criteria to consider. When was it remodeled, if it was ever remodeled, what is the style of the roof, and what is basically all of the area which is available as well. You can find out even the type of concrete which has gone into building this house, and this data set is beautiful. The type of central air conditioning available, does the house have heating, does the house have a basement, if it has a basement, what is the square footing of the basement, what is the first floor square footing, second floor square footing and whatnot, total living area in the ground floor, how many bathrooms, how many full baths, half baths, and you can see that this is just a pool of data, right? And of course at the end of it you have the sale price at which the house is sold at. Now when we have to analyze what we're trying to do here, what we're trying to basically achieve here is to ensure that we can find a way where we can say, hey, these are the features, these are the factors which determine the price of that house. And as I just showed you, there is a lot of objects here to be considered. See, some places, some factors might mean a lot as well. In most of the cases, some houses might not have any of the miscellaneous features which is required. Some houses might not have fencing around it and whatnot. So when you have a lot of data like this, analyzing it, wrangling around with it and playing around with it is really fun in Python. But to do that, we need to perform some sort of cleaning, some sort of basic pre-processing. So what we're trying to do is, on an average, we can see that there's 1460 values for each of the features that we saw. If that is the case, then there is a good chance that if there are features which are very less in numbers, that they won't add any value to our analysis. For example, pool QC has only 7 non-null values. How will this stand a chance when you're performing analysis on an average of 1640 objects, right? So what we can do as a basic cleaning measure is to ensure that we can remove all of these values which are basically less than 30%. Or, so basically you can see Ali is not a number, as you can see NaN denotes that it's not a number. So these will not add any value to our numerical computation, and we can drop all of these columns as well. And you can see that ID, Ali, pool QC, fence and miscellaneous features got dropped. ID got dropped. Ali got dropped because, again, when you think about it, Ali is not a number, and much more. And just like that, you will understand that pool QC was less than 30% of the values. Fencing wouldn't add a lot of value as well, and miscellaneous features are less here as well. So on that note, you need to check out how we can, analyze the data by actually taking a look at what it means. What does the data mean when you basically look at it?
Also guys, if you're looking for an end-to-end training in Python for data science, Intellipaat provides a Python data science course and training which covers all of the concepts which you need to learn and also will help in getting you a job. So for more information, check out the description box below or visit intellipaat.com.
Just a quick info guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
So since we're trying to figure out and map the way the sales price is actually given, you can see that the mean sales price of a house which is being sold in all of the data that we have is $180,000. So for around $181,000, this forms to be our basic mean, saying that this is where all the house prices might have clubbed on, and this is where they are structured about. So on an average, if you're thinking about all of these thousands of houses, this is where the house price is being sold at. And when you're working with numerical computations, as I just showed you, you can find out a lot about data frames when you're working with Pandas as well. And this is one of the biggest advantages. You can find the mean of it. You can find how many counts of data it's present, what is the standard deviation, what is the minimum value at which a house was sold, and what is the maximum price at which a house was sold as well. So all of this data is giving you a beautiful standard deviation curve, which will give you the mean, which will give you the 25%, 50%, 70%, 75% deviations, and much more as well. Now if that is the case, the next step is to understand that what is the type of data that we are trying to pick up from the data set and what is the data that we will not require. As I previously mentioned, since it's a numerical computation based demo, we will not require any of the categorical data, right? So if that is the case, let us quickly print out all the types of data that is present. We have integer, we have floating, and so we have integer and floating as well. Now when that is the case, we need to pick up only the numerical data. Now here, if you see, we have dumped all of the categorical data which is not an integer, which is not a floating value. If I quickly scroll up to the data before performing pre-processing, you could see all these categorical data which are present here, which will not make any sense for the numerical computation that we're doing. See, for example, all pub or LVL or inside or FR2 will not add any value to the computation we're doing, right? So now after removing all of that, we have a very clean, elegant looking data set through which we can work with that. Now, before we begin any work on it, we need to understand that we have to take a quick look at the data to figure out all of these values that we have filtered. We have to figure out all of this. So we have to figure out all of this in a simple way. How do we do that? In my opinion, the most simplest way you can do is you can start plotting all of these curves and then taking a look at each one of these. So there's a lot of houses with a good amount of first floor square footing. So you can check out the average ground floor living area, the year on which the garage was built in the house, what is the square footing of that, and much more. So all of this data that you see on your screen right now in a very methodical way shown here will ensure that you can take a look at it and immediately grasp an idea saying that, hey, so this is basically what's happening. So for example, a lot of average garage area so is basically somewhere around 0 to 1000 square foot. So this is somewhere around 500 square foot of average garage area, and I didn't need to perform any sort of analysis to tell you that. All I had to do was take a look at the graph, understand that this is a standard distribution, and all I had to do was trace the center and probably guess a value around that. So this makes it very simple to work with it at the same time. Now, on that note, let us start working with our data and let us hunt for things which will help us understand the sales price. So basically, we need to find out all of the features which will have the most impact with respect to sales price. In data science term, we call this as correlation. Correlation is simply the attachment that it has to one particular feature where it depends on it a lot. When that is the case, let us create a list, and this list will basically tell us that these are the values which have a strong correlation with respect to the sales price. See, 79% of the time, the overall quality of the area matters a lot. 70% of the time, the living area matters a lot. The number of cars you can park in your garage has a 64% impact. And even the basement footing, square footing of your basement adds a lot of value. And people say even the year it has been rebuilt was basically adding this much of correlation when we're thinking about sales price. Now on that note, we need to hunt for linear relationships where we're trying to functionate and we're trying to understand everything, saying this is the reason that the price is increased, right? So that is exactly what we're going to do here. Again, basically we are printing out all of these linear relationships out here, and you can, just by looking at it, you can understand that there's a lot of outliers in the data which might not have and add any sort of linearity to us. Well, as I told you, to keep it very simple, let us not be concerned with a lot of data cleaning, but understand how the data operations are actually performed. Well, after creating our list and after understanding that we need to find some sort of linear relationships where we'll be tracking that feature with respect to our sales price, then we need to understand there is one important thing. There is a lot of cases where there is a lot of zeros, right? So let me give you an example that the garage area is 0 in a couple of houses. So what this means is that there is no garages in that house at all. And how many cars can you park in that garage? If it is 0, it obviously means that you cannot park any car in the garage, right? And this is mapped against the sales price of the house as well. So if this is the case, if the number of cars you can park in that garage is 0, if the garage area is 0, if the swimming pools is 0, full baths is 0, then you need to understand that if it's 0, it will really not add any value to the computation. So basically, if that is not present in the house, if there is no garage in the house, if there is no swimming pool in the house, we need to remove that feature. And when we have to find out how many features we have to remove, and to understand that after removing all of these values which will not add any value to our sales price, let us see if we can find out any more correlated values out there. And after doing just that, you can see a lot of data printed on your screen. Whenever you see a 0 point number, understand that this is the probability and there is that percentage of chance. If it's 0.19, it means that there is 19% chance that this is adding a value to that. So after removing all the features which do not add value to our houses, after doing a little bit of cleaning, after finding out linear relationships, at the end of it, we can print out what we call as our golden features list that we just created a couple of steps back. And this here will ensure that these are the values which have a lot of these are the values that have a lot of say in correlating with that particular price. If the price is very high of that house, people are considering the year that is remodeled, the year that is built, the presence of a full bathroom, the first floor square footing, the garage area, the total basement square footing, all the way until the overall quality of the house. So these are the factors which are playing a very vital role in the price that's being quoted for those houses. And then now that we have our result, if we take a quick throwback to seeing this data, would we understand just by looking at this, saying, hey, this is exactly what is adding value to the house? Well, no, you have 81 columns and you have 5 rows of data here. So basically looking at this, you will get a clear understanding of what we are trying to do, but you will not get a clear understanding of what the result is. And now with the power of Python, with the power of simple programming concepts that's shown here at the end of it, you can confidently say these are the values and this is the list containing all of the features that is basically ensuring that it has strong correlation, and this is the reason the house is priced the way that is. How cool is this and how powerful this is, right? Well, exactly my point. This is again another reason why you should be considering Python for data science. So when we talk about data extraction, what is it exactly that we're going to discuss? The first thing you need to understand about data extraction, as the name suggests, is basically that it is a technique which will go on to, pull data from places such as websites, social media sites, or whatever it is in general. And this information can be used by you and can be leveraged in such a way that you can go on to probably use this information effectively. See, for example, there are multiple things when you can consider some simple entity such as a tweet on Twitter. So people go on to post things of whatever comes to their mind on Twitter, right? So there's something called a sentiment analysis which has been coping up and which has been upcoming for the last couple of years basically. So when you think about Twitter sentiment analysis, you can understand if people are happy about something, if they're sad about something, or if their viewpoint is even neutral. So who knew a couple of years ago that your post on Twitter will actually help people analyze something? So why would somebody even want to analyze something on Twitter, you might be asking? Well, basically at the end of the day, you're converting this raw data, which basically is the Twitter responses in our case, into information. So you might be wondering if your brand is performing very well, if your product is selling well, and how happy are people when they're dealing with your businesses and much more. So I just gave you an example which came on the top of my head right now, but again, I can give you a million examples of how and where data extraction is being used very effectively. And in fact, make sure you stick till the end, because in our demo we're going to be considering something from the present situation right now, and it's going to be really nice to understand the real-time use and help of data extraction techniques as well. So again, coming back to the definition, basically what we're talking about is a technique, is a methodology which will help us gather the data, and it does it in an automatic way so that we don't have to manually gather the data. So this part where it's automated is all about what we're going to discuss, because at the end of the day, if it's going to be a manual task, you wouldn't need a procedure to do that. You wouldn't need a technique to do that, right? So all you have to do is see something from a website and start typing it out probably. So this automation part plays a huge role. So when we're talking about extracting data from websites, when we're talking about extracting data from anywhere, you need to understand that there's two types of data present in today's world. One is structured data and the second one is unstructured data. If we're talking about structured data, structured data will have something to adhere to. It'll have some rule, it'll have some policies, or it'll have basically a guiding principle behind it. For example, when you look at the data present in databases, it'll either be of the same type, or it will adhere to all the rules of the data that is present in the database probably. Or when you're thinking even of structured data in general, it can be just a very good, very well organized calendar or a timetable basically in your calendars. So, something from that simple entity to all the way till, for example, images, it can be audio, it can be video data, and it can be anything text as well. So when you're mixing up all of these concepts, your data becomes unstructured. There is no one set governing policy over the data which says, yes, I can use this one rule to basically assess and control all the data. So this is a very important difference that one must understand when you're working with structured data and when you're analyzing unstructured data as well. So I hope I was clear in helping you understand structured and unstructured data. Anyway, on that note, guys, let's keep the session very interactive. Make sure you head to the comment section and leave us all your comments. So we have our team members waiting for you guys to hit the comment section, and they'll help you out as soon as they can. So make sure you hit that comment section and leave us with any questions you have, suggestions, or anything you'd want from this session as well. So let's keep it interactive. Head to the comment section. Alright guys, so on that note, we need to check one more important thing, is how one can go on to do this. There is one term when it comes to data extraction, especially from websites. The term is scraping. See, so when you go on to check any website for that matter, right? So all these websites, they contain images, they contain text of some sort, or they might contain if it's a website such as Amazon, for example, or any e-commerce site, you'll have products, you'll have pricing, you'll have situations where the product is deliverable to one place and not the other, for example, as well. So when you're working with all of these concepts, there are a million ways and there are a ton of data that you can actually gather from these websites. So basically what one can do is, if you guys are into sports, you will know that the players for the teams are usually auctioned off when you're working with Premier Leagues. So when you're talking about all these Premier Leagues, what usually happens is each player has a value and they're bid on and they're won. So you can actually go on to websites to find what the price of the player was when they were bought into the league, and you can create a very nice looking Excel sheet, and you can organize to see what player was worth what, and eventually at the end of the Premier League they usually put out tables and charts with the number of goals. So you can create this very fun project where you're trying to find out the return on investment as well. So again, just another example here. But then if to give you another example, you can go on to e-commerce sites like Amazon, again Flipkart. There are many other places there. You can find out all the prices that each of these guys are offering for the same product, and you can find out who is providing it for cheaper. Is it Amazon, is it Flipkart, or any other case for that example as well. So all this information is gathered in the websites, and we use a term called as scraping to basically pull all of these information out. Scraping literally means hunting for the information that you need, filtering for the information you need, and basically bringing it on to your machine, or basically to bringing it on to your native base, where you'll be converting it into files that you can use. So CSV is a very structured form of storing the data. For example, let's go back to the e-commerce example we went. So you can have name of the product, the vendor 1 and vendor 2, for example, Flipkart or Amazon, and you can get the price of both of them, and you can compare and check who's giving it for a better price and whatnot. So this forms the basic outlay of how one can go on to perform data extraction. Data is present in the websites. We'll be cleaning the data and pulling whatever data we require, and after that we'll see if there is any processing to be needed, and if processing is needed, it is done, and at the end of it we will save all of these files in a format which is basically structured and which we can use further down the line. Alright, so on that note, you need to understand why we need to perform data extraction. Guys, again, if you know why data extraction is important in today's world, head to the comments and let me know. So coming to the answer to why one should scrape data, here is a very good first example for you. When you go on to the top job hunting sites, be it Naukri.com, be it Indeed, or be it LinkedIn Jobs or whatever, so in this situation, when you have to find out about all of the top jobs that are present around the world, well, it would be really nice to have all these jobs that you're looking for at one particular website, right? So consider the situation where, let's say, you want to become an artificial intelligence developer. Artificial intelligence is on the rise in today's world, as you might know it, and you're looking for a job. So in this situation, you would want to check out all the jobs that are available in your vicinity, in your area, or in your area of interest as well, right? So if all of these job listings were probably put in a very structured Excel sheet, or if these were put in a very nice place all in one. So if all of these were put in a very nice single place where you can look at, analyze, assess, and basically apply, that would be really nice as well, right? So basically, to perform this, you will require data scraping, and this is actually a very good example of projects in case you guys want to consider doing your own projects with respect to job listings as well. Find a keyword, find a career, and basically scrape data of various websites where you can create your own list of these jobs available as well. Anyway, coming to the second reason of why one must scrape data, think about social media analysis. See, all of us pretty much use a minimum of, well, let's say 4 out of 6 social media that you see on your screen, right? Everything from Facebook, Instagram, Snapchat, Twitter, WhatsApp, LinkedIn, and more. if you are a business person, or if you are a marketing enthusiast, come programmer, or whatever it is, if you're looking to scale your brand, if you're looking to sell your products more and ensure how your outreach is, as we discussed previously, you will need social media. At the end of the day, social media is something we all go back to on our couch at the end of the day to scroll through to see what's happening in our friend's life. Well, let me tell you, it is way more than that, because with the help of social media, brands are being established, they are taking off. So in this competitive world, it is enough that, people have to start using these tools to help market their brand, to make sure that, more customers are coming in and whatnot. This is one aspect of it. The second aspect of it is that, you need to understand what your customers feel about your product. You need to understand what your customers, have the opinion about your product, because, what 3 people might be really happy about your product while 10 people might be showing disinterest or saying that your product might be bad. Knowing this can help you with your brand and much more, right? So scraping data with respect to social media is very important, not only in terms of businesses, but in general as well. Now, coming to the third reason of why one must perform data scraping is understanding market value comparison. So this is exactly what I was talking about when I gave you the Amazon Flipkart example. So it's not just e-commerce websites, it can be the comparison between any 2 products. If you're looking for a product, you can bet on it that there are multiple vendors for the same product. So, it is very, very rare cases, it is 0.001% of cases where there is only one vendor for your product across the entire world. Well, let's talk about the other 99.99 cases, right? So there, you have more than one provider who's giving you the product that you're looking for. So in that case, you need to understand, you need to perform analysis to see who's giving it for a lower price, because if it works out for you at a lower price, you're at an advantage, right? So probably this wouldn't matter if you have a low investment of say $1, $10, or maybe $100, depending on how much you can digest. But then if you're looking to purchase something in the thousands of dollars range, probably in the millions of dollars range, then of course this is going to add a lot of value, because again your savings are in the thousands as well, right? So scraping data for market value comparison is very important. And of course, research and development. When you're understanding that, let's say you can provide scientists, physiologists, and everyone in the field of science more data where, that can be helped for them to perform analysis and give them a look at the data that pretty much that they've never taken a look at from the angle that you can provide with the use of web scraping, is something which is very vital as well. Because, they can be working with a lot of data, but then once you step in with web scraping, once you give them data, it might provide them the angle, it might provide them some clarity, it might provide them basically what I'm trying to tell you is that, it will provide them with a view that they have not thought of looking at as well. And of course, all of these data can be further put into use by making use of artificial intelligence, machine learning, or whatever it is. But then to get to that, you need to give them the data, right? And this is exactly what and why it's important to scrape data for the world of research and development as well. So on that note, you might have a question saying, is it legal to start pulling data from everywhere around the world? Well, to answer this is a bit tricky, I'll tell you why. The answer is yes and no. So you can legally extract some information from websites, and you can of course, illegally do it as well. So to understand how you can, abide by the laws to make sure what's legal to be pulled, what's not legal to be used, the websites will actually tell the users about it. So, the websites will tell the users saying, hey, this is legal to do, this is not legal to do. So how? You might be asking, how are the websites telling the users? Because you don't see it anywhere on the websites, right? So every website has a file called as robots.txt, and this robots.txt will basically tell all these crawler robots, all these spider robots, which basically go on to, pick the actual data from the websites, saying, hey, you are allowed to do this, you are not allowed for this particular information. So when these websites say, and these robots basically, when they, they can have all the access they want to everything that they're allowed to. And once if someone with a very bad intent tries to, pick up information from a website which is not allowed to access, then, their intentions are not good, and, they might be doing something with your data which they're not supposed to. So, let you access is basically amazon.com/robots.txt. And as soon as you hit enter, it will take you to their file, where they will tell you what you can allow and what you cannot allow. So you can see disallow / wish list. So all of these pages which start with disallow means that you cannot legally access all of these as well. You can see allow as well. So basically allow will tell you, hey, you know what, you can have legal access to all of these as well. So this is exactly what I was talking about. But then to give you more clarity on what this means, it's not just Amazon. You can visit any of the websites and just type in /robots.txt, and this will give you an understanding to see if you can actually, scrape their data or not legally. So in fact, to add value to my point, here is what it would look like. So basically, as I mentioned, any website will have this file, and this is what it basically means as soon as we saw user agent start disallow. If disallow is not followed by anything, it basically means that, the user or the crawler robot or the spider robot basically, which is going to pick the information for us, it has full access to their website. And if we have a disallow and if we put in a / there, it means that it will block all access and, no data can be scraped from there. But then you can actually prevent access to particular folders, you can prevent access to particular files and much more. So you can see disallow / folder /. This means that this one particular folder has blocked access, and you cannot access this when you're pretty much trying to scrape the data. And then there is disallow / file.html, and this ensures that there is one particular file which is basically blocked for access by all of these crawler robots as well. So this is very important for you to understand even before you begin scraping data off the internet. And now the question comes, Python for data extraction, what makes Python the tool that one must go on to use? The first thing when we talk about Python is ease of use. So Python has been this amazing language, and personally, been a fan of it, been using it for multiple years now, seeing it take over the top position when you're comparing it with Java or whatever it is. Python is amazingly easy to work with. So there are multiple reasons. One, it's very readable for people who have never used Python before. Two, the syntax is again very easily understandable, and you do not need a lot of training when you're working with Python. Of course, structured training is very important to understand the core values of Python and how you can go on to use it effectively as well. But the point here is that there is no semicolons, there is no complex syntax, and everything at the end of the day is a breeze when you're working with Python. So of course, I think many people in the comment section can agree to this point on how easy Python is to use when you compare it with all the other programming languages out there. So point number 2 is something very important. Point number 2 is what makes Python what it is. It is the number of libraries that Python supports. See, for example, in the world of data extraction, we will perform computations, we will perform data storage methodologies, and we will go on to visualize this data at the end as well. So for numerical computations, you have libraries such as Pandas and Numpy, which will perform any computation on the data that you have extracted. And for data visualization, we have tools such as Seaborn, Matplotlib, and much more, which will basically help you even after you have achieved the results of data extraction as well. And these are just 4 libraries among hundreds and hundreds of libraries that are present, which are being used around the world as we speak. Basically, which makes Python what it is, because at the end of the day, with getting access to so many open source libraries, you're part of a huge community, and you're using tools which will make your job a lot easier, be it data extraction, be it machine learning, be it neural networks, whatever it is. With respect to Python, it just makes it easier, and this adds value to my last point as well. So coming to the next point, it's small code. You might be wondering what I say by small code. With respect to Python, as I mentioned, the syntax is not complex. One more thing is that the syntax is not long. For small amounts of code, you can basically get big results. In Java, if you have to compare to, pretty much go on to print hello world, you have to write 4 or 5 lines of code.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
those are complex syntaxes as well. So for a beginner who has never seen programming before, that will be overwhelming. With Python, it is pretty simple. It says print, open your braces, put your message inside and hit enter, and your results are printed. So I just gave you a simple example again. Even with respect to data extraction, you need to understand that there is a small amount of code, but at the end of the day, the results that you get for typing the small amount of code is huge. And this, in my opinion, is one of the most important aspect of using Python for data extraction as well. So coming to the next point, it's again a very nice point here, is that it's the community. When you're working with data extraction or any other concepts with respect to Python, we have an amazing open source community where everyone is friendly, everyone wants to help each other out and pretty much develop products, establish brands, whatever it is. Everyone is very friendly, and this entire community is filled with people who are enthusiasts, who are willing to help each other out, and who are basically willing to see that all of them grow together in the world of programming as well. So this is why personally I love Python too, and again I am sure our viewers can agree to this point as well. So you might be wondering, what are the Python libraries available for data extraction? Well, there are many libraries, but then here are the top 3 most used libraries. The first thing is Beautiful Soup. So Beautiful Soup is again another open source library which basically parses your HTML and XML documents and makes sure that you can extract all of these information very easily. So you might be wondering what parse basically means. So parsing is an operation of performing syntactical analysis where you're trying to make sense of symbols, where you're trying to make sense of the text which is given, the strings or whatever it is, and then bringing you that information. So Beautiful Soup again is a very widely used Python library for data extraction alongside a Selenium. So Selenium is basically used for automating your browser activities as well. So when you perform web testing, when you perform activities where you're pulling the data continuously, you have to go on to test to see if your data is being pulled right, to analyze your data, to automate this process of verification and validation. So Selenium is used right after Beautiful Soup for that. And then there's AnyTree. AnyTree is basically helping you create a tree data structure which is used for data extraction. So a tree data structure at the end of the day will basically make sure that your data is organized and it can be pulled in a structured way, and this will help in further analysis, in further storage, and much more. See, there are many other tools you can use as well. There is requests which you can use, there is LXML, and there is many other tools as well, but these 3 are mostly the top use tree, because one, we are talking about converting your data into something useful. The second one, we are basically pulling the data for AnyTree to use, and after that we'll be using Selenium to basically test and automate the process as well. So as I just mentioned, there are multiple libraries which one can go on to use for data extraction. And this quickly brings us to the demo where we'll actually get to see this hands-on. And just before we jump to the demo, we need to understand the problem statement at hand. So what is the problem that we are facing in today's world with respect to data? In my opinion, it is data requirement, because see, when you're basically trying to solve a problem which needs a lot of data, first thing, you need all these data to work with, right? So here is where data extraction is a king. When you're working with data extraction, you can have the ability to basically provide all the data that's required, for example, for the creation of data sets. And these created data sets will help solve the world's problems, right? So let me give you an example. When you're working with artificial intelligence, machine learning, neural networks, or whatever it is, more the data you provide, there is a good chance that your machines and your neural nets or whatever it is, it will learn better and understand quicker. So it's not only about artificial intelligence that, more the data, better the learning. But when you talk about any other situation as well, if you were given price comparison of products from just 2 places, would it make more sense? Or if I could give you a price comparison of 10 places, the 10 places would basically be a better, point of reference for a business decision, right? Exactly my point here. So more the data, better the learning, better business decisions, better key performance indications, and much more. So let's consider one of the things that's happening right now. So for example, we have the COVID-19 outbreak across the world right now, and it is something very grievous as well. When you look at the numbers on your screen, basically we had total infections of 2.4 million, and 170,000 deaths at the time of the creation of this video as well. And pretty much this number is going on and on every single second, and it's very scary to see. And at this point of time, again, I would like to enforce everyone to take all the precautions, that is, stay safe, stay in quarantine, and we can fight COVID-19. So basically, humanity has fought multiple viruses across the history of the last 100 years and more. So pretty much, this is an easy task at hand if everyone does their job, and let the doctors work their thing. And let's see, as IT people, let's see, as the people who are computer science enthusiasts, IT field enthusiasts, let's see how we can help them out better to achieve this, right? And that's exactly my point here as well. So again, when we're talking about how important is a data set to solve a problem, let's see if we can bring machine learning together and medicine together. So we have a comprehensive video on the channel which will guide you on how machine learning is basically used to fight against COVID-19 as well. So make sure you check that out after this video. So coming back to how important the data set is, the first thing your data set can help in this particular case is it'll tell you where you can trace the outbreak from, where it originated, how it started out, where is it spreading, how quick it's spreading, and much more. Diagnosing patients is something very important. Again, it will help you tell what patients have been diagnosed at what time for what particular disease or whatever conditions they have as well. Disinfecting areas, you can find out by making use of machine learning models saying where the contamination is highest and help disinfect those areas as well. And then when you're looking at finding a cure, probably this is the most important thing. This is the most widely asked thing right now, to see if computers can help fight against a virus. And of course, computers are doing everything they can. There are experts out there who are bringing together the world of IT and medicine just for this cause. So if computers can help scientists find a cure for this particular disease, it would help. And again, if we take a quick backtrack, of course, medicine in all of its glory will be the one finding the cure. But then the field of computer science, if it can speed up something in the field of medicine, that is what we're basically achieving. To speed up something, we need more data again, and more data is obtained by making use of data extraction, right? So you see where we're going here. So just before we dive into the world of showing you how data extraction works with respect to the demo, here is a sample fact about how machine learning came into picture. So basically, Blue Dot is an artificial intelligence platform which basically tracks all the infectious diseases that happen, right? So this actually found out that there was a lot of pneumonia cases happening around one particular market in Wuhan, China. And just 9 days later, after the Blue Dot platform found out this unusual rise in cases, World Health Organization stated that they have found a new virus out there, and there are a lot of people hospitalized with respect to pneumonia as well. And this was at the end of 2019, and now we know that in the April of 2020, we know where we are. We know the 100,000 deaths which has happened, 2.4 million cases and whatnot, right? So this again was one of the places where IT helped, and it could only do this where if it had all the data from around this market in Wuhan or whatever it is, right? So again, they and the people at Blue Dot basically again made use of data extraction to get all of these data and create artificial intelligence models around it, and then put out a conclusion saying there are a lot of pneumonia cases here as well. So this is exactly one case. So I picked up a medical case study to show you guys, because again, I believe that artificial intelligence, I believe that you can make use of machines with medicine together to help speed up today's world of medical research and whatever it is in general as well. So I'm a huge fan of that, and I hope you guys could see the connection as well. So coming to where you can pick up the data, in our case, let's say COVID-19 dataset creation, you can have data picked up from the satellites, you can have data picked up from the news, you can see who all flew around the world at what time to trace and understand where there could be an outbreak by taking all the data from the flights across the world, and of course all the health organizations, hospitals, your local governing bodies which is taking care of the local areas as well. So there are multiple places where you can find a lot of data. For example, every day you can check out, there are news about where hotspots are, where there is a lockdown, where there is a complete shutdown, where people cannot step out of the houses as well. So when you look at the data, there is plethora of data, there is a lot of data. To go on to use this effectively, you need to create that structured aspect that I spoke about in the starting of the session, right? So just onto that, here is what the solution would look like to perform data extraction on a data set such as the COVID-19 data set by making use of web scraping, by making use of data extraction. So as mentioned, we'll be making use of Python in this particular cases, and we'll create a data set for various reasons, and all the various reasons we just discussed in the problem statement, right? So quickly coming on to how it works, it is pretty simple. So it's about 10 or 11 steps, and it's really simple to follow as well. So follow along with me. The first step to perform data extraction is to make sure you set up everything you require in your Python runtime environment. For example, here we're making use of Google Colab. Basically, it's a free Jupyter notebook where you can run Python commands online, and everything is, stored on the Google's ecosystem, and they provide you storage and computation power as well. But then, I'm aware that most of you might not be using Google Colab. So, if you're using your local machine, if you're using any other environment to run your Python code, just make sure you install a couple of libraries before we begin with. As discussed, Beautiful Soup 4 again is a very important library for web scraping. We have requests as well. So requests will basically help you pull and parse data from the HTML sources we'll be looking at as well. So in this case, we'll be pulling data from a very famous website called as worldometers.info. So these guys have been putting out very structured information when it comes to how the outbreak is being handled and all. So to do that, to pull the data, to pull all the HTML data and to analyze and understand it, we require requests. And we have a library called as LXML as well. So LXML again will help you parse your XML data and pretty much make it understandable and make it usable for further down the line. So you can execute these code statements that are in the comments in case if you're using any other environment as well. So coming to Google Colab, basically Google Colab has all of it covered for us. So all I need to do is run it, and basically it is imported because it's already installed in the backend. Step 1 is very simple. Step 1 is to get your runtime set up. Now step 2. So what we're trying to do in step number 2 is we're creating a beautiful soup object. All you're trying to do is making use of the website's HTML, and here is where the LXML parser will come into the picture, and we're trying to create this object where we're getting all of the source from the website URL as well. So you can see the URL is given on your screen. It's worldometers.info/coronavirus. So this is where all our data is, and all we're trying to use is make use of the get operation in HTML request to basically pull all of this data. So by running step 2, you would have created an object. Step number 3 is something simple as well. So what we're trying to do here is we're trying to create tables with all of the data surrounding COVID-19, right? So when we're trying to do this, you need to understand that there are multiple tables which will be available in that Worldometers website. So we need to perform some analysis in the backend to find out what table ID is given. So we can pull all these data from that particular table as well. So here the ID attribute which I found out to be the table there was given as main table countries today, and running this will basically create a table. It will find us the ID attribute, and at the end of the day, so our beautiful soup basically understands that this is the table, this is the ID where I can pull all the data from. So step number 4 is basically where we go on to extract the headings that we require for the data chart that we're going to use. So to do all of this, you might be wondering, is the data already clean where we can directly grab the data and start using it? Well, the answer is no, because with respect to most of the cases, the data that we see and use will basically be some sort of it'll have some sort of an anomaly, or it'll have some sort of characters that we would not want to use, or let's say it's of no use to us. In that case, what we basically do is we replace all of these unwanted characters with something else, and we make sure that we actually go on to keep the data as clean as possible for further use as well. So you can, for example, see every new line character here is basically replaced by a blank space when you're working with heading, and you're working with a non-breaking space as well. So /xa0 deals with non-breaking spaces, and again we are replacing those non-breaking spaces with an empty string as well. So all we're trying to do in step number 4 is clean the data and get all of the headings so that we can have headings for our columns and use it further as well. And after step number 4, step number 5 is to find the data for all the continents across the globe. So for example, in the data that we have analyzed, there is the data continent aspect where, data can be pulled for each continent. So in our case, we want the data across the world, right? So we're not looking for data only from, say, Africa, Australia, only from Asia or whatever it is. We want the details from across the world. So all we're trying to do is to ensure that we find the table where, all of the rows which do not have a data continent attribute. So if it does not have a data continent attribute, it means that, so we're trying to pick up the data from all the countries and not just any one continent, right? So we want the data from around the world. To do that, we need to recursively go on to check if these particular aspects have the country's attribute, and to find out if these attributes are present or not. If they're not performed, then we're going to pick that, because that indicates, we're looking at all the countries and not just one single continent as well. So basically, after performing analysis and after setting our scope to the data across the world and not just one particular country, we need to remove the first row. So basically, all we're trying to do is we're removing the first row in the heading, because we already extracted it before, right? So if you remember, we already pulled out headings in step number 4. So basically, performing this operation will remove the first row, since you already have it to repeat it again. Now, coming to step 7. Step 7 is basically the creation of the result list. So all we're trying to do here is we're creating a list and we're calling it result. And this list will basically hold all of the data temporarily until it can be written into a CSV file, which will be our final output. So let me repeat. We're going to create a list called as a result, and this result will be a temporary point of storage for all of our data, which will later be written in a CSV file, and this CSV file will be our output. So basically, running step number 7 will create the list. So basically, at the end of the day, we need to append all of these headings. We need to add all of these headings to the list, right? So result.append of headings will do just that. It will make sure to add all of the heading to the results that we actually want. And step number 9 until step number 8, we have cleaned the data. We have pulled all the data that's required. We have created headings, and we have basically removed all the unwanted spaces. We have created a result list, and we have added the headings there. Now step number 9 deals with adding all the data with respect to the each rows and each columns as well. So until now, we already picked up the headings. With respect to step number 9, we are going to basically find all the data that needs to be extracted, to find all the data, to scrape all the data, and we're going to add it to a list called as row. After we are adding it to a list called row, we're going to check if it's present already. If not present, we're going to keep adding it. And after that, we're going to have to add all the data that we found in the row list into the result list, right? So basically, the row list will have all the data that we have pulled through all the different rows in the data. So it will not have headings at this point of time. To make sure that the data is collaborating with the headings, which is basically present in our result list, we actually append the rows to the results as well. So performing step number 9 will add all the data of each particular row and eventually append all of this to our result list. And then step number 10 is the most simple step probably, because here is where we are, preparing for storage. So whenever you create any file in Python, basically be it CSV file or anything, we need to create a file and we need to open it as well. So basically, using the open command, we're creating a file called as data.csv, and we are opening it in the write mode, and we're starting it with a blank line as well. So when you go on to run this particular command in step number 10, it will create an empty file. It will create a file called as data.csv. It will open that file for further working, because we need to write the data, right? So the file writer needs to have access to all of these files that it can write to. So that is why we open it, prior to writing. And again, the second part of step 10 is to actually write these files that we actually obtained it into this file called as CSV file, and then we can actually push all of this results. Step number 10 was basically preparing it for storage, creating it, opening it, and make sure that there is a file writer which can write. Step number 11 is where we actually write the result into the CSV file. So writer.write rows of result will write the actual results to our CSV file. This will be pushing all of the data that we have from our result list into the CSV file, and at the end of it, it is always a good practice to close the file basically, which will make sure that the data is saved. So you might be wondering now, okay, step number 11 is done, we've written everything to the CSV file and it is stored, but where is the file? Well, in your case, you will have the file present in the Python interpreters folders. In our case, it will be created basically in the Google ecosystems files, and let me double click on the data.csv that we just created here. And as you can see on the right hand side of your screen, you can choose to pick up how many ever details that you have to show on your screen as well. So here as well, all the countries, all the total cases, the new cases from yesterday, the total number of deaths in that country, new deaths, total recovered, and much more. So this detail we've picked up from the Worldometer side. What are the active cases? How many of these active cases where people are serious? What are the total cases for 1 million of population, deaths per 1 million population, and much more. So Worldometer is a comprehensive website, and this at the end of the day, this will create a very nice data set, and this data set at the end of the day can be used to perform analysis. Again, to find out how that is done, make sure to check out our machine learning video, which is basically performed using a data set similar to this as well. So this creation of data set, not just in the case of COVID-19, it can be anything across the world. Once you have structured data and once you've created structured files like this, you can understand that you can leverage this and make full use out of it down the ladder. It's basically performing analysis. It can be working with deep learning, working with machine learning, whatever it is. Step one is very much essential in all of these fields of processes, and step one is creation of data. And we have created a structured pipeline to access our data as well. And this again, in my opinion, is one of the most important use cases or uses of data extraction when you're working with Python as well.
Also guys, if you're looking for an end-to-end training in Python for data science, Intellipaat provides a Python data science course and training which covers all of the concepts which you need to learn and also will help in getting you a job. So for more information, check out the description box below or visit intellipaat.com.
How to import a dataset using Pandas, and how to analyze various attributes of the data. How we can import a dataset using Pandas. So for importing the dataset, the very first thing that you will be doing is importing the Pandas library. So I'm importing Pandas as PD. So next we are going to read the dataset and store it in a data frame. So I'm defining a data frame named cars, and inside this I'm passing the path of my CSV file, which is emptycars2.csv. At this point you can specify the path to your CSV file. Okay, and finally we are printing it. Let's see the output. So this is my entire data. So let's move ahead and see what are the various analysis we are going to perform on it. So first is type cars. So this type car is used to check the type or check the data type of the car. So it's a data frame, right? So as a part of output, we got pandas.co.frame.dataframe. Okay, so the type of cars is, it's a data frame. Next is cars.head. Well, this is used to view only the first 5 records of your data frame, which in our case is this. Okay. Next is, if you want to view first 10 records from your dataset, you can pass the attribute over here as 10. And so as an output, you'll get first 10 dataset from the data frame. Okay. Next is, what if you want to view last 5 records, then you can use the parameter dataframe.tail, which in our case is cars.tail. Okay. So this will give you the last 5 record of your data frame. Okay. Similarly, if you want last 10 records from your dataset, you can specify a value over here. So dataframe.tail, inside this I pass 10. So this is giving me last 10 records from my dataset of cars. Okay. Next is cars.shape. Now if you want to view the total number of rows and columns in your data frame, for that you have dataframe.shape. So cars.shape gave me the output as 32 and 13, which means I have 32 rows and 13 columns in our dataset. Now if I want to concise the summary of the column of my data frame, for that I have dataframe.info. And inside info, I'm passing null underscore counts equal true. So what it is exactly giving me, it is giving how many non-null values are up here. So as you can see in QSEC, we have 29 null values. So from here you can say that we have 3 null values in our column QSEC. Okay. This is the data type of each column. The first serial number is of integer data type, next is object, MPG is object, cylinder is integer, and so on. So in total we have 4 columns which consist of floating data type, 7 columns which consist of integer data, and 2 columns which consist of data of object data type. Okay, and the total memory usage is 3.3 plus KB. Fine, let's move ahead. Now if I want to calculate the mean of my data frame, I can just write dataframe.mean, which in our case is cars.mean. So as a part of output, it gave me the mean of each column. Okay. Next, if I want to calculate the median, similarly dataframe.median, cars.median, it gave me the median of each individual column. Okay.
Next is standard deviation. Well, for standard deviation, we have dataframe.std. So if you see the output over here, you are getting the standard deviation of each column. Fine. Next, similarly, you can calculate the maximum value of each attribute by using dataframe.max. So we have cars.max, for which we are getting maximum of each attribute. So in serial number, we have 35 unnamed maximum value. This MPG, it's 33.9 and so on. Okay. Similarly, you can calculate the minimum value for each attributes using dataframe.min, and you'll get minimum value for all these different attributes. Fine. Next is dataframe.count. So if you want to count the total number of non-null record in each column, then you can use dataframe.count. So which in our case is cars.count. So here as output, we are getting how many non-null values are in each column. So here in QSEC, you can see that we have 29, which suggests that we have only 29 non-null records and there are 3 null values in it. Okay. Next is the dataframe.describe function. Well, it is used to print the descriptive statistic summary. If you don't want to calculate each of the feature individually, you can just write dataframe.describe, and this will give you the output of count, mean, standard deviation, minimum, maximum, 25 percentile, 50 percentile and 75 percentile values of all the different columns. Okay. So these were the various attributes you can use it for analyzing your data set. Okay. So without delaying any further, let's see what exactly is data cleaning. So data cleaning or data cleansing is a process of detecting, correcting or removing corrupt or inaccurate records from a dataset, table or any database. It also refers to identifying complete, incorrect, inaccurate or irrelevant parts of our data and then replacing it or modifying it. This is what a data cleaning is. So let's see how we can clean our data. So the first thing that we can do to clean our data is we can rename the column. Okay, so in our dataset, we had a column as unnamed. Right. So instead of using the column name as unnamed, we can replace it by name of the model, which represents the exact name of the column, as the column contained different model of the car. Right. So here what we are doing, we are renaming the column unnamed to model. So as you can see here, as an output, we got model up here. Okay. So this is the very first thing that you can do while cleaning your data. You can rename the attributes. Next is, what if you have some null values in your data? So for treating null values, what you can do, you can fill the null values with the mean of the column. And this is how we do it. So cards.qsec. So as we have analyzed in our previous session that qsec had 29 non-null records, right? So which it meant that it had 3 null values in it. So we replaced all those null values with the mean of the qsec column. So what we did, we took the mean of the entire 29 and whatever value we got for the mean, we replaced all the null values with that particular value. Okay. So replacing the missing data with the mean value will help analyzing the data in a better way. Okay. So this is how we can replace the null values with the mean of the column. Next is drop the unwanted column. So here we can drop all those unwanted columns which do not add any value in analyzing the data. For example, we had serial number previously, right? But the serial number was not adding any value to our analysis part. So for the further processing of the data, we can avoid or we can drop the column of serial number. Okay. So how we can drop any column? So for dropping any column, what we have to do is dataframe.drop, and inside that we have to mention the name of our column, just like this. Cars equal cars.drop, and inside this columns equal, we are mentioning the name of the column as serial number, and it got dropped. So as you can see here in the output, we don't have the column as we used to have it previously. So here a serial number column is dropped. Well, next is finding correlation matrix. Well, this correlation matrix will help you to find how a variable is correlated to other variable. So if the value of correlation is high, so that means the two variables are highly correlated to each other. That is, changing one variable by a factor of x changes other variable by a factor of y. Okay, so here as an output, we got a correlation matrix, right? So from here you can see that cylinder to cylinder, it's highly correlated. That is one, obviously. Cylinder to displacement, it is 0.9. So it means that cylinder equals 0.9 times of displacement.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. Width. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So it's like if you increase cylinder by 1 unit, your displacement would increase by 0.9 unit. Okay. So similarly for DRAT, you can see that cylinder equal minus of 0.69 times of DRAT, which means if cylinder increases by 1 unit, it means the value of DRAT would decrease by 0.69 units. Okay. So if while finding a correlation matrix, you get a very small value of the correlation. For example, let's consider this. So here correlation between carburetor and DRAT is minus of 0.09. So it means they are very weakly related to each other. So it's like if the carburetor is increased by 1 unit, so it means that if the carburetor is increased by 1 unit, then DRAT would decrease by 0.9 unit, which is almost very less, right? So by finding correlation matrix, you can define the correlation between the variable, and from here you can decide which attribute to choose and what not to choose while working on the problem. Okay, fine. Let's move ahead. Next is changing the data type. Well, initially MPG was of data type string, right? Well, MPG had some float or numerical values into it, right? But with the string, we cannot manipulate it, or we cannot perform any calculation on the string data, right? So MPG has to be converted to float in order to perform some data manipulation on it. So here we are converting MPG from string to float. So how we can do that? So it's dataframe.mpg equal dataframe.mpg as type, and inside that we are mentioning the data type which we want to convert to, and here in this case is float. Well, now if you want to see the change, you have to see cast.info null underscore counts equal true. So from here you can see that my MPG has been changed to floating data type, right? And even for the QSEC attribute, we have replaced all the null values from its mean, right? So here it's giving me 32 null values. That is, now it is not having any null values in it. Okay, let's move ahead. So again we are finding the correlation. This time the MPG part is included as it has become of a floating type. Remember, while calculating the correlation between two attributes, both the attributes should be numerical in nature. No correlation can be found between attributes of string data type. Okay, if you compare it with our previous correlation, you can see that there was no MPG value, right? As initially the data type of MPG was string, right? Now since we have changed the data type of MPG to float over here, so next while finding the correlation, we are getting MPG value. Okay, now Python is treating it as a numerical attribute and it is using it to find the correlation. Okay, so this was all about how you can clean your data set. Okay, so in this session you will learn about how to perform indexing on the data set, how to set a value for a column, how to manipulate the data using lambda function, how to sort a column, and finally you will see how to filter your records. So without delaying any further, let's start with our first topic, manipulating data set, indexing by position. Well, what if you want to view a single column? So how will you do that? Well, Panda gives you a functionality of iloc function in which you can specify the parameters to view a single column. So for example, I want to view HP column only. So my HP column belongs to 4th row, right? So I mentioned the iloc colon, which means row. So entire row, comma, 4th column. Okay. So what it will give me? The 4th column of the data set, which is nothing but the HP column. Okay. Let's move ahead. Next is, what if I want to view first 5 record of the HP column? So in it, I'll mention this is the number of row. So iloc row starting from 0 till 5. Okay, actually 0 till 4, just before 5, and the column 4th. So it will give me the first 5 result from the column HP. Okay, next is, what if I want to view all the rows and all the columns? So all you have to do is iloc colon comma colon. Okay, first colon means all the rows, second column means all the column. So it will give you the entire data set. Next is, let's see, I want to see all the column from HP to cow and see all the record from index number 6. So how will I do that? So for that I have row start from 6 till the end and column start from 4th till the end. So 4th column till the end and row from 6th column till the end. Okay, let's move ahead. So now we want to look at all the rows from the first column. So again, so here inside iloc I have mentioned colon. So this represents the row. So we need all the rows. So for representing all the rows, we have colon. Okay. And the next parameter is the column number. So our column number is 1. So as you can see in the output, we got all the rows from our first column. Okay. Let's move ahead. Well, you can even view your record on the base of the name of the attribute. Okay. So for example, I want to see all the record of MPG column. So how will I do that? So instead of iloc, first of all, I'll be using loc over here. That is location. Okay. Then inside that, the row and the column. So colon includes all the rows and the column is MPG. So what it will give? It will give me all the rows from the MPG column. Okay. Next is display the record from index number 0 to index 6 from MPG column. So similarly, so loc starting from 0 until 6 and from which column? In MPG column. So it gave me records from index number 0 to index number 6 from MPG column. Okay. Next is to see first 7 record from MPG to QSEC column. So here what I'll do, so inside location, what I have mentioned, the row. So starting from 0 till 6. So how many records are over there? It's like 0, 1, 2, 3, 4, 5 and 6. So in total there are 7 records. And from which column? So a column should start from MPG and it should end till QSEC. So from MPG to QSEC, I need 7 rows over here. Fine. So this was all about how you can play with index values while manipulating your data set. Okay. Next is setting the value. Well, if you want to set a specific value to the entire column, so you can do that easily using Panda. So here cars is our data frame. So what we are mentioning, cars of AM. So AM is what? It's a column name. Okay. So data frame of AM equal 1. So what it will do, so it will assign value 1 to the entire column of AM. So even in the output, you can see that AM has all the values of 1. Okay, let's move ahead. Next is applying function. Well, now what if I want to double my record? Well, for that, I can use lambda function over here such that x is x multiplied by 2. So whatever value would be there, it will just double it up. So cars of AM equal cars of AM dot apply f. Okay, f is our function, this. So as you can see in the output, we got all the double records in AM. Okay. Next is sorting the data. So what if I want to sort a column in ascending order? So for that I have data frame dot sort underscore values, and inside this I'll mention the name of the column. Okay. So for example here my data frame is cars and the name of my column is cylinder. So I'm mentioning cars dot sort underscore values by cylinder. So as you can see here, my cylinder column has been sorted in ascending order. Okay. Next is descending order. Well, all you have to do is add one more parameter over here, that is ascending equal false. And as you can see here, my column has been sorted in descending order. Okay. Next comes filtering the data. Well, what if I want to view the record which are having more than 6 cylinder? So how will I do that? So for that I have cars of cylinder is greater than 6. So wherever the value of cylinder is greater than 6, so we are getting a true value over there, and apart from that all are false. Okay. Now what if I want to filter my records and see only the data or only the model which are having more than 6 cylinders? So how will I do that? So for that I'm storing the value into filter 1, and next I'll apply a filter to my entire data frame. So filtered new equal cars of filter 1. So what it will give me? It will give me all the true parameters from my data frame or from my filtered cars of cylinder greater than 6. Okay, so when you view the output of filtered new, you can see that we got all the values in which the value of cylinder is greater than 6. Okay. Next, what if I want to filter my record and check for the model which are having 6 cylinder and horsepower more than 300? So for that we added this condition over here, that's it. That is cars of cylinder is greater than 6 and cars of HP, that is horsepower, is greater than 300. So we are using AND operator over here. Okay. So this will give me a true result only if both the parameters are true. And again, same, we are filtering the data frame and displaying the filtered data. So as you can see here, we have only one model, Maserati Bora, which is having a horsepower of 35, which is greater than 300, and number of cylinders as 8, which is again greater than 6. So both our conditions are true. So there's a filtered data over here.
Yeah, so this is our first task, data manipulation, and to do this, let's go ahead and actually import all of our libraries. So I'll just type in import pandas as pd, and then I'll also load the numpy library. So I'll type in import numpy as np. I'd also need the matplotlib library. So I'll type in from matplotlib import pyplot as plt. So these are all of my required libraries. I'll just wait till these libraries are loaded. Right, this is done. Now I'll also go ahead and load up my customer churn data frame, and I'll store it into an object and name that object to be equal to customer churn. I'll just use pd.read_csv, and inside this I will give in the name of the data frame, which is customer churn.csv. Right, so I have successfully loaded the file and I've stored it into a new object, and also I've named that new object to be equal to customer churn. Now I'll go ahead and have a glance at the head of this. So customer churn dot head, and this is the data set on which we'll be implementing all of the operations. So this is just the unique customer ID. This column gender tells us about the gender of the customer, whether the customer is male or female. The senior citizen column tells us whether the customer is a senior citizen or not. So if it's 0, then the customer is not a senior citizen. If it's 1, then the customer is a senior citizen. And then this tells us if the customer has a partner or not. This tells us if the customer has dependents or not. This is the tenure of the customer in months, right? So 1 month, 34 months, 2 months, and so on. This tells us if the customer has phone service or not. Does the customer have multiple lines? And this is the type of internet service used, and then whether the customer has online security, whether he has device protection, tech support, streaming TV, streaming movies, and so on. And then this column is for contract. So this just tells you the contract type of the customer. So the contract type of the customer could either be month to month, 1 year, or 2 year, and there's a type of billing, whether it is paperless or not. After this, we have the type of payment method. So the type of payment method could be these: electronic check, mail check, bank transfer, and so on. And then these are the monthly charges and total charges incurred by the customer. Right. So now let's start off with our data manipulation tasks. So this is our very simple task. We just have to extract some individual columns from the entire data frame. We'll have to extract the 5th column and store it in customer 5. So let me do that. I'll type in the name of the data frame first, which is customer churn, and I would use .ilog. I would need all of the rows, and I would need the 5th column since the indexing starts from 0. So 0, 1, 2, 3, and 4, right? So this would be my 5th column over here, and I will store this in, let's say, C_5. And I'll have a glance at the head of this, C_5.head. Right, so we have successfully extracted the 5th column from this entire data frame, and this is the head of it. Similarly, we'll have to extract the 15th column and store it in customer 15. Right, so if it's the 15th column, then the index number would be 14, because again, the indexing starts from 0. Right, I'll store this in C_15, and I'll also make this to be C_15. I'll click on run. Right, so this is the streaming movies column, and I get the same thing over here. This is column number 15, and I've extracted only this particular column from the entire data frame. Right, this was basic extraction of columns from the entire data frame. After that, we'd have to do data extraction on the basis of a condition. We'll have to extract all the male senior citizens whose payment method is electronic check. Right, so there are 3 conditions over here. The first condition is the gender of the customer needs to be male. Second condition is senior citizen, the value of senior citizen needs to be equal to 1. And the third condition is the payment method needs to be equal to electronic check. So I'll give in all of these 3 conditions over here. I'll start off by giving the first condition, customer churn. I'll type in gender, and the gender needs to be equal to male. Right, I'll cut this and paste this inside this. Of this, I'll use the AND operator and then give in the second condition. So the second condition would go something like this: customer churn, After this, we'd have to set the senior citizen value. Right, so senior citizen, this needs to be equal to 1. And then I'll go ahead and give in the third condition. So over here, the third condition, this is for the payment method column. So the payment method needs to be equal to electronic check. Right. So I have all of my 3 conditions over here. I'll just paste a cell below. Now, what I'll do is I will copy all of these 3 conditions and I will paste them inside this, and I will store it into a new object and name that object to be crandom. Right? Now I will print the head of this, crandom.head. So we see that this, so if you have a glance at this gender column, then you'll notice that all of the values are male. Similarly, if you have a glance at the senior citizen column, then all of these values are 1. Similarly, I'll go to the payment method column, then you'll notice that all of these values are electronic check. So I've given 3 conditions over here, and all of these conditions have been satisfied. So next up, we'd have to extract all of those customers whose tenure is greater than 70 or their monthly charges is greater than $100. Okay, again, we'll do the same thing. Customer churn, tenure needs to be greater than 70. I'll put this up inside this. Now, what you need to notice over here is we are using the OR operator. So it's either the first condition or the second condition, right? So if one of these conditions is true, then we'll get that particular record. So again, customer churn, and this time it's the monthly charges. So the monthly charges have to be greater than 100. These are the 2 conditions. So either the tenure of the customer needs to be greater than 70 months or the monthly charges of the customer needs to be greater than $100. Again, I'll insert a cell below, and all I'll do is cut this and paste it inside this. Right. And I will store this in, again, crandom. Now let me again print the head of this, crandom.head. Right, now I'll head on to the tenure column. Now you see that none of the tenure or none of the values of the tenure over here is greater than 70. But if I go to the monthly charges column, then you'll notice that the monthly charges are greater than 100. So it's either or. So one of these conditions has to be true. And in this case, we see that the second condition is true over here, right? So if either of the condition is true, then we'll get that entire record. After this, we'd have to extract all those customers whose contract is of 2 years, payment method is mail check, and value of churn is ES. Right. I'll again copy this, paste this over here. Let me delete this from this. Right, so we have these conditions over here. So we'll have to extract those customers where contract is of 2 years, payment method is mail check, and churn is equal to yes. So let me put in all of these conditions over here. First is contract, and this needs to be equal to 2 years. So let me just check, how is it? Contract is of 2 year, right? 2 space year. After that, it's the second condition, and over here the payment method needs to be equal to mailed check. Again, I'll put in the double equal to operator, and I'll give in the value, and the value is equal to mail check, and then I'll give in the final condition over here. So customer churn, and this time the churn needs to be equal to yes. right? So I've given all of these three conditions and I've separated them using the AND operator. Again, I will store this in C underscore random. Let me print this out, C underscore random. So we see that there are just three records, or there are just three customers who satisfy all of these three conditions. So let me have a look at the contract of this, right? So contract is of 2 years for all of these three customers. Next is the payment method, and again payment method is mail check and churn. All of these values are yes, right? So out of all of those 7,000 rows, only there are 3 rows which satisfy these three conditions. Next, this is a question on random sampling. So we just have to extract 333 random records from the entire data frame. And to do this, we'll be using the sample function. So I'll type in customer churn and I'll use the sample method over here. And inside this, what I'll do is I'll give the value of the number of records which I want to sample. So I want 333 records. I'll store this in C underscore 333. Let me print out the head of it. Right, so now what I'll do is, so whenever I run this, every time I'll get a different sample of 333 records. I'll run this again, right? So if you have a glance over here, so all of these values would be changing, the customer IDs would be changing, the indexes would be changing, right? So keep a glance or have a glance at these row IDs indexes over here, right? So again, if you have a glance at this, the row IDs are changing. So this is random sampling. I'm randomly sampling 333 records from this entire data frame over here. And I'm doing that with the help of the sample method. Right, and then this is the final operation when it comes to data manipulation. So I'd have to get the count of different levels from the churn column. So if I want to get the count of the different levels present in a categorical column, I have the value counts method. So first I'll give in the name of the data frame, which is customer churn. After that, I'll give in the name of the column, which is churn, and then I'll just type in value counts, right? So this is it. So let me just wait till I get the result, right? So we see that no, so the number of customers will not be churning out is 5,174, and the number of customers who will be churning out is 1,869. So you can do the same thing for other categorical columns as well. So let's say if I want to get the count values or the number of counts of different levels for, let's say, the contract column, I'll just change the name of the column over here. So I'll put it to be equal to contract, right? So there are 3,875 customers whose contract type is of month to month. There are 1,695 customers whose contract is of 2 years, and there are 1,473 customers whose contract is of 1 year. Right, so these were some basic data manipulation operations. After that, we'll head on to data visualization. All right. So here we'd have to create a simple bar plot for the internet service column. And yeah, we'd have to set the x-axis label to categories of internet service, y-axis label to count of categories, the title of the plot, distribution of internet service, and the color of the bars need to be equal to orange. Right. So I'll just type in plt.bar over here. Now I'll insert another cell over here. Now what I'll actually do is, so this basically takes in 2 parameters first. So the first parameter is the names of all of the bars, and the second parameter is the values for those bars, right? So the names of the bars would be coming from the internet service column. So internet service, and I actually want the value counts of this. Value counts, and from this I don't want the values, I just need the keys. And again I'd have to convert them into a list. So I'll use toList over here. Now I'll click on run. Let's see what do we get, right? So these are the three levels present in the internet service column. So from this internet service column, what I've done is I've used the value counts method. So this value counts method has two things, keys and values. Now I don't want the values as such, I just want the keys, and I'll take these keys and I'll convert these keys into a list, right? So this is the list of the names present in this internet service column. Now I'll cut this and paste it over here, and this would be my first parameter, and my second parameter would be all of the values. And if I want all of the values, I'll just remove the method keys from there, right? So this over here would give me all of the values present with respect to this internet service column, right? So fiber optic, or in other words, the number of customers whose internet service is fiber optic is 3096. Number of customers whose internet service is DSL is 2421, and number of customers who don't avail the internet service are 1526. Right now, again, I'll cut this and I'll paste it over here. Now let me print this out. So this is my basic bar plot over here, right? So this is my bar plot. On the x-axis, I have the names representing these bars over here, right? So this bar is for all of the customers whose internet service is fiber optic. This is for those customers whose internet service is DSL, and this is for those customers who are not availing the internet service. And these are their counts over here, present on the y-axis. Now, I had to do some other things over here. I had to change the color of the bars. So the color of the bars was supposed to be set to orange. And for this, I have the color parameter, and I'll just set it to be equal to orange. I'll run this again, right? So we have successfully changed the color of these bars over here. Now I'd have to set the x-axis label and the y-axis label. So I'll just type in plt.xlabel, and the x label needs to be equal to categories of internet service. Let me type that down. Categories of internet service. After that, I would need to put in the label for the y-axis. So this would be plt.ylabel, and I'll just put it to be equal to count. And then finally, I'd have to give in the title. So plt.title, and I'll set the title over here. And the title needs to be equal to distribution of internet service. Let me type that out. Distribution of internet service. I'll click on run, right? So this is our final bar plot, which gives us the distribution of internet service, and the x-axis label is categories of internet service, and the y-axis label is count, right? So this is how we can create a simple bar plot, and all of this. So these are the basic steps behind before you go ahead and build all of your machine learning algorithms. So the pre-processing, the data pre-processing part is always the main part of your data science life cycle. So this is where you properly comprehend your data set. This is where you understand the structure of the data set. You understand the correlation between all of the columns, the correlation between the dependent variable and the independent variable. So by manipulating the data set and visualizing the structure of the data set, this is where you understand all of the patterns in the data set and you get insights from the data set. Right, so next up, we'll have to build a histogram for the tenure column. So again, it'll be a similar operation, plt.hist, and I'd have to build a histogram for the tenure column. So it'll be customer churn tenure, and I'd have to set the number of bins to be equal to 30, and I'd have to set the color to be equal to green. So I'll just type in color equals green over here. So this is our histogram, and this gives us the distribution of the tenure of the customers. So so if you look at it closely, so this is basically the count over here, right? So there are around 800 odd customers whose tenure is not even 1 month. So they are churning out before they even complete 1 month. And again, there's a huge peak over here. So there are around more than 600 customers whose tenure is 70 months or more than 70 months. and then rest is pretty much the same, right? So the average customer, so this is the normal range of the customer, so it's between 200 to 400, and the average tenure of the customer, you can say, would be somewhere between 20 months to 50 months or 60 months, right? And this is where you have the peak. So you have the peak at the starting and you have the peak at the ending. Again, let's go ahead and add the title. So it'll be just plt dot title over here, and the title of the plot needs to be equal to distribution of tenure. I'll do that. All right, so I have created this plot, and this is the title of the plot, which is distribution of tenure. So we've made a bar plot, we've made a histogram. Now you guys also need to understand the difference between a bar plot and a histogram. So a bar plot is normally used for all of the categorical columns. So whenever you want to understand the distribution of categorical columns, that is when you'll go with a bar plot. And when you want to understand the distribution of a continuous numerical column, that is when you'll go with a histogram. Right, so next up, we'd have to create a scatter plot between monthly charges and tenure. So tenure is on x-axis and the monthly charges is on y-axis. So plt dot scatter, x-axis would be tenure, so customer churn, tenure, and then I'll set in the column for the y-axis. This will be customer churn, and this will be equal to monthly charges. Let me just run this, right? So this is what we get over here. Now let me also set in the labels for this. So plt dot x label, and this would be equal to tenure. Let me type in tenure over here. Similarly, I'll also set the y label over here. So this will be plt dot y label, and this would be equal to monthly charges. Right, so now we also get the corresponding x and y axis labels. After this, I'll also go ahead and set the title. So it'll be plt dot title, and this would be monthly charges versus tenure. Monthly charges versus tenure. Right, so this is our final scatter plot where we have the x-axis and y-axis labels, and this is the title, which is monthly charges versus tenure. Right, and finally we'd have to also build a box plot between the tenure column and the contract column. So tenure needs to be on the y-axis and contract needs to be on the x-axis. For this, I'll just type in customer churn dot box plot, and so now I'll set in this to be equal to customer churn contract, and after this I have the column to be equal to customer churn, and this needs to be equal to tenure. Let's see what is the error over here. Columns not found. So let me actually remove this from over here and let's see what happens. Alright, so now we get the result. So we had actually given the name of the data frame initially itself, so it was customer churn dot box plot. And now all we have to do is assign the contract onto the x-axis. So now when I said by equals to contract, what is happening is I'll have one box plot each for the different levels of the contract column. So I have one box plot for the month to month level. I have another box plot for the 1 year level and another box plot for the 2 year level. And over here, the y-axis, this is being determined by the tenure column, right? So this over here, 0 to 70, this is the tenure of the customer. And what we understand from this box plot over here is, so if the contract of the customer is of 2 years, then most probably the median tenure of the customer is very high. So if the contract of the customer is of 2 years, then his tenure or median tenure would be around 65 months. Similarly, if the contract of the customer is 1 year, then the median tenure of the customer would be around 45 months. And then if the contract of the customer is month to month, then the median tenure of the customer would be around 15 odd months. Right, so these were all of the examples of visualization. Now it's finally time to head on to machine learning. Right, so this was your data pre-processing part, where you had understood the structure of the data. You had learned how to extract individual columns, and after that you learned how to visualize the data and get some interesting insights from the structure of the data.
Also guys, if you're looking for an end-to-end training in Python for data science, Intellipaat provides a Python data science course and training which covers all of the concepts which you need to learn and also will help in getting you a job. So for more information, check out the description box below or visit intellipaat.com.
Just a quick info guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
We'll start off with our first machine learning algorithm, which would be linear regression over here. And linear regression, as you already know, so over here, the dependent variable would be a numerical column. And you're basically trying to understand how does one variable change with respect to another variable. And over here, we'd have to build a simple linear model where our dependent variable is monthly charges and the independent variable is equal to tenure, right? So, or in other words, we are basically trying to understand how does monthly charges vary with respect to tenure. So monthly charges, dependent variable, tenure is the independent variable. And these are all of the subsets when it comes to this linear model. So we'll start off by dividing the data set into 70-30 split, and then we'll build the model on the train set, pick the values on the test set. After that, we'd have to find out the root mean square error, and we'd have to print out that root mean square error. So let me go ahead and import the linear regression model from sklearn. So I'll type in from sklearn import linear model. After this, I'll type in from sklearn dot linear model import I need linear regression. Right. So these are my two basic libraries. So I needed linear model, I needed linear regression. Now I would also require the train test split. So I'll type in from sklearn dot model selection import train test split. Right, so this train test split method would help me to divide my dataset into training and testing sets. So now it's time to divide my data into training and testing sets. So before that, I'd have to get my target and the features, or in other words, I'll have to separate my dependent variable and the independent variable. So monthly charges is the dependent variable. So what I'll do is y equals, and I'll extract only the monthly charges column, and I will store it in a new variable and name that variable to be equal to y. Similarly, I'll only extract the tenure column. Right, so I'm extracting the monthly charges column and I'm storing it into a new object, naming that object to be equal to y. Similarly, I'm extracting only the tenure column and I'm storing that column into x. Run columns, customer churn. What seems to be the problem over here? Monthly charges. Let me put it to be capital C over here. Right. Now let me print out the head of these two, y dot head and x dot head. Right. So these are the values from monthly charges column and these are the values from the tenure column. Now let me go ahead and divide these two into training and testing sets. So I'll use in train test split. I'll pass in X as the first parameter. So all of the features would be which are stored in X go as the first parameter. After that, I'd have to give in the target labels, and the target labels are which are basically my monthly charges, which are stored in Y. And then finally, I'd have to give in the test size. So let me check what was the test size. So the test size was supposed to be 0.70. And then I'll also set a random state. So if I want to use these values again, I can just set the random state to be equal to the same value which I'm giving over here. This is smallest over here, right? So this test size 0.70 basically means that 30% of the records would go into the testing set. Oh, this has to be 0.30. Sorry for that. Yeah. So 30% of the records would go into the test set, and 70%, the rest 70% of the records would go into the training set. Now I'll be getting 4 results over here, and those 4 results are X-train, X-train, Y-train, X-test, and Y-test. These are actually the labels which we conventionally use. I'll explain what these are exactly. X-train, Y-train, and then we have so this would actually be X-test first, X-train, X-test, Y-train, and Y-test. So over here, X-train represents all of all of those values of your features which are present in the training set. X-test represents all of the features which are present in the test set. Y-train represents all of the dependent values which are present in the train set, and Y-test represents all of the dependent values which are present in the test set. And whenever we are building a model, we'll build that model on top of the train set, right? So we'll build the model on top of X-train and Y-train. Let me also show you the shape of all of these. So X-train dot shape. Let me do the same for the rest. X-train dot shape. I'll make this to be Y-train. I'll make this to be X-test. And I'll make this to be Y-test. Right. So X-train, Y-train. So the training set has these many records, and the testing set has these many records over here, right? So these are all of the features which are present in the training set, and these are all of the features which are present in the, sorry, these are all the features of your dependent variables, and these are all of the features of the independent variables, and these are all of the target values when it comes to the test set, and these are all of the target values when it comes to the your dependent variables. All right. So now that we have X-train, Y-train, X-test, and Y-test, let's go ahead and build the model on top of the training data. Now I will go ahead and create an. So normally your training data would be bigger because so let's say your splits are either 70-30, 65-30, or 80-20. Because the more data you give for training, that is better. But then again, you can't give out your entire data for the training set, right? So the purpose of training your model is to make sure that your model learns the underlying patterns of that data. And once the learning is done, you'd have to also test how well the learning is done, right? And to test, you'd also need a sample space for that test set. So consider this simple case. So let's say you're giving an exam, but for that exam, let's say if you got 100 exercises. So your syllabus comprises of all of the 100 exercises, and you'd have to learn all of those 100 exercises. But when it comes to your test, it will have only 10 exercises from all of those 100 exercises, right? So the training needs to be done, But then again, the test space, it needs to be completely new, which is not learned by the model, during the training phase, right? That is why the training set has to be completely different and the test set has to be completely different. And the division of training and testing set is done to make sure that overfitting doesn't happen. And when overfitting happens, the problem is this model will perform well on this particular data set, but when a new data set comes in, it'll miserably fail. Right? So this is the reason why we divide the data into training and testing set. Right. So now let me go ahead and create an instance of the linear regression model, and I'll name that to be regressor. So I've created an instance of linear regression over here, and I'll go ahead and fit the model on top of the training set. So it'll be X train and Y train. Right, so I fit the model on top of the training set. Now it's time to predict the values. So it'll be regressor dot predict, and I'll be predicting the values on top of the X test. And I will store this in, let's say, ypred. Now I've fit the model on top of the training set, and I've also predicted the values on top of the test set. Now I'd have to know how well the prediction has been done. And for this, when it comes to linear regression, we have something known as the root mean square error. So the lower the value of root mean square error, the better your model. And again, we have an inbuilt method to calculate the root mean square error. So I just have to import sklearn.metrics, and from sklearn.metrics, I'd be importing mean square error. Now after this, so mean squared error, what we actually want is root mean squared error. So I would need the np dot square root, and let me use the mean squared error, and this takes in two parameters. First parameter comprised of the actual values which are present in y test, and second parameter are the predicted values which are present in ypred. So I will cut this and let me ease this to be in this over here. Right, so we get a root mean squared error value of 29.39. Right, so now let's say if you build some other model with some other independent variables. Now we'll go ahead and build the model, and we'll also predict the values. Now after predicting the values, we'll also have to calculate the root mean square error. So this root mean square error is actually relative. So let's say if there is some other model, let's say model 2, and if the root mean square error of that model 2 is, let's say, 39, then this model would be better than the second model. Similarly, if there's, let's say, model 3 whose root mean square error is 19, then that model 3 would be better than this model which you built over here. So here we are predicting the monthly charges values. That is exactly right. So let me actually show you that. So let's see, I'll put in ypred, and let's say I'll have a glance at the first 5 values, right? So these are the monthly charges predicted. Let me also show you y test, then 5, right? So these are the actual values and these are the predicted values over here. Right. So this is not exactly dependent on the churn of the customer. So what we are doing is we are building an entire data science lifecycle process. So over here we are trying to understand the relationship between the tenure of the customer and the monthly charges of the customer, right? So over here what we are basically trying to understand is, let's say if the tenure of the customer is at around 10 months, what would be his monthly charges? Again, if the tenure of the customer is 30 months, what would be his monthly charges? Similarly, if the tenure of the customer is 70 months, then what would be his monthly charges? So this is what we are trying to understand over here, right? So this time we'd have to build a logistic regression model where dependent variable is churn and independent variables are tenure and monthly charges. Again, I do the same thing. Let me actually copy these two So this is what we did over here, Aditya, right? So this is where we went ahead and predicted the values, didn't we? Right? So I have divided my data set into training and testing set. And over here, I am fitting the model only on the train set, right? So training is happening on the training set, or the model is learning from the train set. And we are predicting the values on the test set. So this model, this linear regression model, has not yet seen all of the records present in the test set. It has only learned from the values which are present in the training set. So we'll go ahead and build the linear regression model now. Customer churn. Let me also put in Y. I'll do the same thing. So in the logistic regression model, our independent variable is monthly charges. Let me put monthly charges over here, and the logistic regression, the dependent variable is churn. So I have extracted or I have got my features and my target over here. So features are basically my monthly charges, and my target is present in the churn column. And I'd want to understand if the customer would churn or not on the basis of the monthly charges of the customer, right? So I've done this, and the rest of the process would be the same over here. I'll go ahead and divide this data frame into train and test. Right, so this is 65-35 ratio this time. So I'll set it to be 35. So this time 35% of the records would be present in the test set, and the rest 65% of the records would be present in the train set. And I'm storing all of those into xtrain, xtest, ytrain, and ytest. Right. After this, I'd have to import the logistic regression model. So from sklearn.linear model, I'd have to import the logistic regression model, and I'd have to create an instance of this. So I'll name this to be equal to log model. Alright, so I have created an instance of this, and I'll go ahead and fit the model on top of the training set. Right, the entire process when it comes to implementing this is pretty much the same, right? So Python makes it extremely easy. The sklearn library makes it extremely easy. All you have to do is take in the data, find out your independent variables and your dependent variable, and then go ahead and divide those target and features into training and testing set, build the model on top of the train set, and then break the values on top of the test set. And then you will find out the metrics. So for classification, it's confusion metrics and your normal accuracy score, and for linear regression, it could be either root mean square error, mean square error, or moving averages error. So log model dot fit, and I will fit this model on top of the training set again. So xtrain and ytrain, right? So I have fit the model. Yes, we can also have multiple independent variables, Sharadata. So again, so if we have a single independent variable, then that's that's a simple model. So when it comes to simple linear regression, we have a single independent variable. When it comes to multiple linear regression, you'll have multiple independent variables. Right. So this basically means that we are trying to understand how does our dependent variable change with respect to multiple independent variables over there. And so again, consider this equation. So linear regression equation is based on this. Let me actually open Notepad over here, right? So y equals, let's say, x1 plus x2 plus x3 plus x4. So what happens in a simple linear regression is you just have one independent variable, which would be x1. What happens in multiple linear regression is you have multiple independent variables, which are x2, x3, x4, and so on. Right? And you're trying to understand how does y vary with respect to all of these independent variables. That's pretty much it. Right, so let's proceed with this. We have built the model on top of the training set. Now let's go ahead and predict the values on top of the test set. So it'll be log model dot predict. So here we change the value of x, and no, we are not changing the value of x. We have multiple x values over here, right? So this becomes mx1 plus m2x2 plus m3x3 plus m4x4 and so on. We have multiple independent variables, and you are trying to understand how does y vary with those multiple independent variables, right? So we have predicted the values now, right? So when it comes to a classification model, we can use the confusion matrix, right? So let me import the confusion matrix. So from sklearn.matrix, I will import the confusion matrix, also the accuracy score. Now let me find out both of this. I'll pass in the actual values and the predicted values. Actual values are present in y-test and predicted values are present in y-pred. Similarly, accuracy score, I'll do the same thing. Y-test and y-pred. Right, so this is our confusion matrix and this is the accuracy, right? So to get the accuracy, what you'll basically do is you'll divide the left diagonal with all of the values. So left diagonal represents all of your correctly predicted classifications. So this comprises of all of your true positives, right? So this part over here, this is all of your true positives and this is all of your true negatives, right? So when you divide this with the entire sample space, that is when you will get the accuracy. So let me do that. So that'll be 1815 divided by 1815 plus 651. And I get the same accuracy, which is 73.60, right? So I get an accuracy of 73% for the model which I've built. Now I'd have to build a multiple logistic regression model. For the dependent variable is the same and the independent variables are tenure and monthly charges. So now we have two independent variables, so I'll make the changes here itself, right? So Charu, the question which you're asking, what if we had multiple independent variables, right? So over here we have two independent variables. So this time the independent variables are monthly charges and tenure, and I'm trying to understand whether the customer would churn or not on the basis of these two columns, which are monthly charges and tenure, right? So X now would comprise of these features and Y is the same, and the ratio is 80-20. So I'll change the test size to be equal to 20 over here. I'll go ahead and fit the model. It's the same. Again, I'll predict the values is the same, right? So I build the model. I predicted the values. The only difference which I made over here is I have two independent variables this time instead of a single independent variable, right? Predicting the values. After that, I'll import confusion matrix and accuracy score, right? Now over here, again, I'm calculating the confusion matrix and this time I get an accuracy of 77.50, right? So this time it'll be, so this was logistic regression, and then we've got two more machine learning algorithms left, which are decision tree and random forest. So let's build these two. Right, so for decision tree, dependent variable is the same, which is churn, and independent variable is tenure. Right, so let me manually do this. X is customer churn, and the independent variable is tenure. Let me also extract the dependent variable. So the dependent variable would be churn. You have to make sure that you put in the spellings correct, and also you have to take care of the small caps and the capital letters over here. Right, now I will go ahead and also import the decision tree classifier. So from sklearn.tree, I'll be importing the decision tree classifier. Now I'll go ahead and divide this data frame into train and test. So it'll be the same process. Let me copy this Let me paste it over here. So the split is 80-20, which is what we are doing over here, right? So this is our feature, this is our target labels, and we have divided the dataset into training and testing set. Now let me go ahead and create an instance of this decision tree classifier. I'll name this instance to be, let's say, my tree, right? And I'll go ahead and fit the model on top of the training set. So my tree.fit, this takes in two parameters, which are xtrain and ytrain. I fit the model. Now it's time to predict the values. My tree.predict, and I'll be predicting on top of the X test. Now I'll import the metrics, right? So let me calculate the confusion metrics and also the accuracy score. Confusion metrics. So I'll actually have to store this in a object first. Again, I'll be storing this into ypred. Let me run the cell again. And this again takes in two parameters. First parameter is all of the actual values which are present in ytest, and all of the predicted values which are present in ypred. So this is our confusion metrics now. Let me calculate the accuracy, which would be 965 plus 87 divided by 965 plus 87 plus 281 plus 76. Right, so for this decision tree model, we get an accuracy of 74%. Right, so the process is entirely the same, guys, right? What we are doing is, again, at the risk of being redundant, so what we are basically doing is finding out our features and target variable. After that, we are dividing the features and target into training and testing split, and then we'll go ahead and build the model on top of the trained data, and then we'll predict the values on top of the test data. Once the prediction is done, we'll calculate the accuracy to find out how well our model has learned. Right, so in the entire data science life cycle, our most important part is the data processing part here. So this is your entire end-to-end project on the customer churn data set, which comprises of data manipulation, data visualization, and implementing all of the machine learning algorithms.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
2D graphs and plots can be created easily using Python script. It can produce the output in a various hardcopy format. That means whatever graph you see here, you can save it to a PNG file, JPEG file, or whatever. So that's where this comes really handy. Okay, that's where it really comes handy. Okay, next is why to choose Matplotlib, because it has a, first of all, it is a OOP based API. Okay, the library is almost based on OOP settings, so that means it will have the same kind of structure as classes and objects when you try and refer the Matplotlib module. So that's why you must have seen we have used matplotlib.pyplot, right? So matplotlib is the basic class and pyplot is a function of it. So that's why class name dot object name, object name dot function name. That's how we use it, right? That's the OP basic. So that's how we do it. Okay. Next is very wide variety of graphs. We will see that next, like what all types of graphs we have in Matplotlib and how that can be used and what are the usage of those graphs and where do we use it, like that. We have simple functions used for visualization. So if you go ahead and see here, forget about the first example, see this basic. What we have done, we have taken a np.arange. Okay, we have taken a x variable np.arange, and we have the values from 0 to 10 with 0.1 separated. Okay, then we have taken a y value which is
2x plus 5, so that is an x and y linear equation. Okay, and we have plotted the xy points, and this is how it looks like. So this is how you plot a line plot in Matplotlib. Okay, next what we have done, plt.show to show this plot. Okay, to show this plot to you. So that's how easy is I mean that's how easily you can visualize a function in Matplotlib. Okay, so with this plt.show function, you can see the graph in here, and plt.plot will show you the plt.plot will plot you this line. Okay, so that's how easy it gets when you use Matplotlib functions for data visualization. Okay, so that's how it is. And always remember one thing, the behind the scene, the main module that is responsible for this data visualization is called pyplot. Okay, so that's why if I go back to the code, you will always see we have imported the module matplotlib.pyplot. Okay, we always have used it, right? And we have used alias just to have a ease of reference, right? So that we no need to write the entire thing in there. So that's how it is. Okay, so that's where this matplotlib is. That's how easy matplotlib is. Next, what we are gonna see is what are the different types of plot that we have. Before that, let me come to this inline thing. So this inline function, if you don't have it, it will still work. Okay, this percentage matplotlib inline, you won't see a difference in Jupyter Notebook. Okay, because this Jupyter Notebook is anyways browser based, right? So this won't give you any difference when you use Matplotlib from any web based or any kind of notebook kind of scenario. Okay, but if we have a different set of, I mean, if you are running Python separately, right? If you are running Python separately, correct, using Spider, it can be Spider, it can be a simple command prompt of Python, anything can be there. So if you are running it from those, IntelliJ idea means PyCharm. Okay, for Python the ID name is PyCharm. So if you are running using those IDs, or if you are running using like what, let's say if you are running it from the command prompt, then this will create a separate window. So that's where it gets difficult. Okay, so that's where it is, I mean, it is advisable to use this like Numpy, I mean, sorry, this Matplotlib inline command for having the graphs inlined to the screen that you are currently using. Okay, otherwise what it will do, it will create you a whole separate thing. Okay, so it will give you a different set of, I mean, a different window where you will see the plot. So that's why we use this Matplotlib inline. So that's the basic standard, to have it displayed in the same window. Okay, so that is why we use Matplotlib inline. But if you don't want it, if you want the separate window to pop up, it will also work. Okay, that will also work. So that's no need to be worried. Okay, before that, let me show you what are the different types of plot that we are having in Matplotlib, and what are their uses. Okay, then we will go to each of the examples one by one. So if the what you need to remember from this whole lecture will be 2-3 things. Okay, first of all, why and what plot need to be used, where it need to be used, and how you can write those. Okay, customization, even if you learn it slowly by playing with it, it's perfectly fine. I don't That's not a matter. Okay, the customization thing, coloring thing, changing the access labels, adding legends, changing the colors, there can be thousands kind of customization in Matplotlib. Okay, so do I have that mail with me? No, I will have it my official email ID. Okay, so what I did, for some requirement I created, there is some kind of graphs and charts that goes to higher management. Okay, for reporting purpose, that goes every day. Okay, so I created something using Python, no data science is involved, that's a straightforward thing, much easier. So I created a simple script or simple job using Python. What it does, it takes in data from a RDBMS, it plots the data nicely in a Matplotlib plot, and it sends it to you, sends it to the upper management. So when I am telling upper management, that is D plus. Okay, so that's where this comes handy. So and there you understand, right? When we are going to show this to upper managements, we need to have the graphs beautiful. We need to have all the specifications. We need to have pointers. We need to place them in the right position so that they don't find any errors and they won't accept anything so easily, right? So that's how powerful Matplotlib library is. So otherwise I would have shown you. So that's how you can do it. So the graph, what I can do, like the simple graphs that you are seeing in here, you can change the background color of the graph. Okay, so the background will be of some different color and the foreground will be of some different color. As you are seeing there in the right hand side, we have a bar plot, right? In the bar you can choose each and every bar color one by one. Okay, that can also be done. All these bar objects can be accessed individually. Okay, once you plot these bars in Matplotlib, right, all these individual bars can be accessed one by one. You can change their width, you can change their height, you can change their color, you can set text to them, you can write text in between them. So whatever you can do in Excel with all these graphs, the same things can be done in Matplotlib. But again, those things are not required for your day-to-day work. It will require very rarely. So even if you don't understand those, even if you like the NSCOM quartet I have shown you, if I start explaining the whole graph, it will take the entire class because it has too much customization in it. Okay, so just to keep it short and just to give you the proper idea so that you can start experimenting or playing with it, the basics I will tell you. Okay, and on the basic you can build up. Okay, you can build up on the basic. If you do understand the core concept, you can easily build up. Okay, so that's how powerful Matplotlib is. And let's see what kind of graphs we use. We have line plots. So line plots, what we use just to plot 2D equations, right, with x and y. There we will use line plots. Okay, so line plot will give you a trend line in an equation. Okay, so when we see linear regression, we will see its use pretty heavily. Okay, for machine learning, and also for observing a data set how it is distributed. This is really needed. Okay, next is bar plot. This is the same as line plot. The difference between these two is you can add a trend line in bar plot also, so that way it will become this, but this denotes the area covered by the point. Okay, so the bar will start from x-axis and it will go, the height of the bar will equal to its y value, and the shaded area will be showing the area covered by that point. Okay, so that's where bar plot is needed. Bar plot is basically this, it is required in the same way we have line plots. So what is different in here? In line plots you might not be able to tell what is the value of x for the value of y at x equals 17.5. You need to go there, you need to see, it will be difficult for you. But in bar plot you can see it there directly, right, because the bar will do that. Significance of width, there is not much. It is just to illustrate. Okay, illustrate this bar one. Okay, this is that is how this bar is designed. So bar means it will show you some area covered by the curve. So if you calculate this rectangle, so what it has, this rectangle is same, this rectangle has this width of some x value, height of this y value, right? So if you calculate a rectangle covering that area, so this will denote the area covered by that point. Okay, by that x and y point, from the ending to beginning, this area will be covered. So area is shown here. Next is scatter plot. So scatter plot and line plot again are same, but only difference, the points are not joined. So you need to understand when we use these two. When we have a continuous set of data, we know that it might fit a linear equation, right? Yes, Azam, I just explained it. What is the significance of the area, right? So in the line plot, if you have like if you have a like continuous set of data, then in that case this line plot will be visible. But if you don't have a continuous set, if you have some chunk of data, clusters of data, then you will use scatter plot. This is to see the data distribution, how they are distributed, and this is the trend line of the data. This example of scatter plot you will see when we are covering clustering. You can understand, right? We have seen some clustering algorithms. So if you plot the data in this plane, then from that you can easily understand how many clusters will be formed from that k-means, right? The k value you can find it from your you can find it by checking that manually only, right? If you plot the data, it will be clear to you. After clearing the data, if you are able to plot that data in this plot, you can find the value of k without any hack, right? And you can pass it to the algorithm to give you those many clusters and their centroids and all. But what you not need to do is you no need to check the data points and decide which point will be belonging to which cluster. Those things you no need to calculate. Okay, next is this histogram. Histogram is basically used for image processing purpose. This histogram shows you basically. Okay, so this histogram is basically used for like image processing purposes. And what this bins are denoting, this bins denotes the number of times the values, the frequency of the values, the frequency of each point occurring in the data set. Okay, so that's what this bins are denoting. So this is not really used in data science, somewhat used, but it won't fit our purpose always. So maximum for image processing, this is used to see how the data is spread and what are the frequency of the data point that we have, what are the frequency of pixels that we have, those kind of cases, and histograms comes handy. I will show you all these examples, but again this is not really required. Image plot, again this can yeah, CPU processing is also histogram, right? So that's what. So wherever the scenario fits in, to show you some frequency kind of thing, wherever it fits in, then you can use histogram. Okay, wherever you need to find out some frequency of some point in dataset. Let's say for CPU processing, if you see the graph how it will look, it will give you how much CPU is used in what point of time and what is the frequency of high CPU uses. In that case, they will use histogram because it will give you the frequency related data. Okay, difference between bar and histogram is bar plot won't give you this frequency, it will just plot the x and y points. It is almost similar to the trend line, except it will show you the area, it won't show you the frequency. But from histogram you can find out the frequency. When we go to example, let's see how we can do that. Okay, okay, next is image plot, right? Image plot is to plot some image. Okay, again you won't need that. So image plot will fit in a existing image to this to the 2D plot, and it will show you the height and width and all those things you can see visually. Okay, next two plots are really important for us. Those are box plots and violin plots. Okay, so let's do one thing. Let's see the examples of all the 5 plots that we discussed, then we will discuss the rest 5. Okay, rest 5 or 6 whatever we have, we will discuss those after that. Okay, let's see these examples first. So this line example I have already shown you. Now the next one is how to customize these lines. So basically these are the basic customization technique I will show you. So see here what we have done. We have taken the same example as the earlier one, just we have reduced the number of points. We have used this fig equals plt.figure, fig size equals 10,5. So this one, this plt.figure object, what it does, so if you don't use it, that also work, but how it works is this plane is a single plot. Within the plot you can create multiple figures. So let's say you want to create 2 charts side by side. In that case you will use this figure. Okay, you will create a figure size, I mean you will create this 2D plane first. Okay, then you will plot this line. That is the best standard practice, so you should follow that. Okay, you will create a figure object, then you will plot the data points. Okay, that is the standard that we do. So how do we do that? What we do, we use plt.plot function as shown before. We are having x and y, 2 values for x and y data points. Next we are passing is this line width parameter, right? So this is to provide that line width, what it will be. Next is line style. It has many different line styles also. It has dash, you can give 0, you can give O, any character you can give. Let's say I am giving I, and if I run it, it won't run because I is not a supported character. What was that supported one? I don't remember. I think dash was supported. Yeah, so this line style, you can provide anything. Okay, sorry, not line style. Line style will be dot dash, these two things only, or a continuous line. I was talking about this marker. Marker, you can put anything. Okay, so marker, you can put something like this also. Unrecognized marker. Marker, except to what we had cross, I believe. We had cross, yeah, we have plus, those kind of markers are there. So this marker object is to show you this points, okay, show you this data points, how you want to see those, but O gives you the best visualization among all. Okay, so that's how you can use it. Okay, next is this line style is for styling this lines, this intermediate lines. If you provide colon, then it will be like this dashed line. If you provide a dash, dashes will join, right? So dashes will join, and you will see a straight line. So that's how this works. Next is color. You can provide any color. You can write the full name also. You can use the short name also. You can provide here the RGB values. You can provide. Let me show you. You can provide this hex values also. You can do anything. Okay, let me take the default color that is coming. So I will show you this to example. Come on. Okay, if I tell it take it this, and if I put it here, this will also work. Okay, see the lines have changed to blue, right? If I provide this, that will also work. I don't remember the syntax for RGB. RGB is not much used, but still, okay, sorry. But still you can provide like this, I believe.
Also guys, if you're looking for an end-to-end training in Python for data science, Intellipaat provides a Python data science course and training which covers all of the concepts which you need to learn and also will help in getting you a job. So for more information, check out the description box below or visit intellipaat.com.
RGB anyways, we don't use it much. We use the simple names or hex codes, because hex codes you can find in many places, like in net you can have it easily available. You can create your own colors, but RGB we really don't use in plot. Yeah, so that's how. So I will still show you because it can be done. So I believe we can only mention the tuple. We no need to write anything in behind. Let's see. Still it doesn't work. Why? How to give it? Just the tuple without this single quotes? I believe yes. Let's see how it works. Still not working. So you can provide the hex value, or you can provide the mnemonics also. You can type in any color in full also. If I type it yellow, it will also work. Okay, so that's how you can use this color attribute for all the graphs. For all the graphs you can use it. Okay, so you can type in any color, or you can provide the hex codes also. Okay, so let me give some good color here. So that's how it works. Okay, that's how this color attribute works. Next is for alpha. Okay, alpha is for reducing the brightness. Okay, reducing the I mean the transparency of it. Let me give it blue. That would look the best. So that's how. So alpha is the transparency. Okay, okay, next is alpha is for reducing the brightness. So let's say you will understand on your own only. I don't need to explain. If I run it to 1, see this is much vivid, but if I do it 0.1, you will see this is way too dim. It will be way too dim, right? So that is what is alpha. Alpha is for reducing the brightness. So alpha is the transparency factor. So if you reduce the alpha, then what it will do, it will make the line or plot, whatever you are doing, transparent to the plane. So it will match the background color of it. Almost it will match the background color of it. It will be a very fade color. But if you pick a high alpha value, it will give you somewhat deep lines. Okay, you will see the dark lines, dark colors over there. Okay, so that's what is alpha used. Marker, as I have shown, these points are called markers. So that's how we plot a line. Next is this title object, right? This title function. So what we do with this title, we plot this title like line plot demo. This we put it using this plt.title, and it will automatically be placed here. Okay, it will automatically be placed at the top. You can change it to bottom also. You have options for that, but the basic that we follow, the standard, that is to put it in top always. And x level, y level, x axis, y axis, you can type it, so the labels, x's will be labels. Okay, x's will are labels. It is not for the value, it is for the labels only. Okay, that's how it is. And for the limit of it, the graph will take on its own. It is best to leave it on its own, because it will be helpful. Because if you are trying to manipulate the graph, because see, you will always not know this, right, that how much data you are covering, how much data you are taking, like that. So that's why this is best to leave it on the graph itself. So it will decide the best min x min y, min x min y, and max x max y, and it will plot it. Okay, so that's how it works. Okay, next is for plotting legends. Legends means this small markers. So to show someone which one line denotes what, right? That is what is legend. So for plotting legend, what we do, we use this legend function. Okay, we use this legend function, then within bracket we line the marker name. It can be a list also. Okay, it can be a list. If we had 2 lines here, let me show you. That will also work. Let's say I have an orange object now with marker as cross. Okay, and it is darker. Let's make it darker. And if I run now, you see we have 2 lines now in the same plot, right? So how you can have here, you can write like this, and see, everything will be taken care automatically. Okay, see here in legend it's already added, the my line thing is already added, and LOC equals base means the graph will on its own calculate the best position for the legend, and it will put it. So it will always put in the best position. It can be down, it can be up, it can be anywhere. Okay, plt.grid true, that is to show these grid lines. If you don't want it, just don't mention this function, it won't show you these grids. Okay, so that's up to you. If you like the grids, you can keep it. If you don't, you cannot. So there is no really no real thing in that, in showing or not showing the grids. Okay, somewhere if you fill it, you can provide you can have those displayed. Okay, so that's how this grid works. And plt.show, as you know, to show the plot, to show the I mean to display the plot in front. So that's how this thing works, this line plot works. Okay, so that is what is about line plot. And you have seen only single line plot in a picture, right? So I have shown you 2 line plots in the same graph, right? Let's say we have 2 different plots in the same we have 2 different subplots in the same plot object. How do we do it? Okay, so that is where this subplot function comes into picture. That is where this subplot function comes into picture. So if you see carefully, what we have done here, we have taken the same thing, the same functions that we used in the earlier example, and we have shown you this. We have shown here the 2 different plots in the same thing. Okay, we have shown 2 different plots in the same figure. So that's how. Okay, so the next thing is the parameters that we have passed, and how do we create this subplot. Okay, so how do we do is, firstly what we did, we used plt.subplot function. Okay, so subplot function, we have, there are many parameters that can be passed on to it. Okay, there can be many parameters. So we have provided only 3 parameters here. This is just to have it in a standard one. Okay,
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So how does it work? Okay, that means the first one, 1, 2, right? These are for number of rows and number of columns. Okay, so we have created one number of row and two number of columns. Why one number of row? Because we want this to have in a single subplot, right? We want this to have in a single plot. So see, when I change it in 2 rows, so this first one gets smaller, right? Because it has created 2 rows. First one contains the first graph, second one contains the extra portion of the second graph. So always try to have n rows as 1 if you don't want to create more rows. Okay, so sorry, for the first subplot, for this first subplot, if you create 2 rows, then the same area will be divided into 2 parts. So the graph became smaller in and got fit into 1 row, and the next row is left around. Okay, so that's how it is created 2 rows here. So here, so the idea is, if you want to fit 2 graphs in the same subplot, then only go for this 2 1. Okay, but standard is to use 1, because we generally, when we subplot it, we want the subplots to contain 1 graph. If you want to fit in 2 graphs like this, you can create a separate subplot here and you can plot the graphs. Okay, so that's how this plt.subplot is used. See here we have passed in number of rows and number of where we have passed in only plt.subplot, we have passed in some integer numbers. plt.subplot 221, 222, so these are just integer numbers, right? So this is 221, this is 222, the starting point of the subplot, and the plot will adjust on its own. This is also an expression that we use, but this is not standard. Okay, this is not standard. This is just to have 4 plots, 4 plots arranged in a rectangular way. The standard is always this one. So we pass the number of rows, number of columns that we want, and this 1 is for number. So that means how many figures are there. Okay, how many figures are there. So this thing, the pyplot.figure function that I have shown you in the earlier part, that will be called, and the figure number will be attached to it. That means this is figure number 1 and this is figure number 2. Okay, so if you want to customize it using this figure object, then you will see how you can use it, but that is not really required. Okay, for now, just know that this is a number parameter that is being passed into this function, and that denotes how many number of what is the figure number that is there in the graph. Okay, so for the next one, if you see, we have created the same subplot size 1 2, and we have provided number equals 2. So that means this is a figure 2. So this is figure 1, this is figure 2. Okay, the rest function the same as what we had in this. So plt.title, it has plotted these titles of graph 1 and graph 2. plt.show showed you the graph, and plt.plot plotted this x and y1 and x and y2, these 2 things. Okay, so that's how now line plots can be created and customized, and also multiple line plots can be created in the same subplot. So this applies to all the other graphs that we are going to see. So we won't show you those in that much detail, but you can always create a subplot. You can fit in 2 bar plots, 2 line plots, 2 scatter plots, anything you want in there. Okay, so that's how you can create this subplots. So is this clear? Then we can move on to this bar plot. Okay, so bar plot is basically to show you some counts, to show you some this is basically used to show you counts. Okay, so see here what we have done. We have created a data set with 3 this is a dictionary, right? So we have count for apple, mangoes, lemons and oranges. Okay, for x-axis we have taken the dictionary, the list of keys from the dictionary, and for the y-axis we have taken the list of values, that is the count for those. Again, we have created a figure size. How do we plot a bar chart? We plot a bar chart using plt.bar. We passed in x and y. This kind of nice little rectangles are shown over here. So this is 15 and this is the area behind this curve. So next we will see how can we change the width and all of this curve. Okay, so let's go to this one. See here, this is actually this like horizontal bar graph. Okay, so here for horizontal bar graph we have taken the same data set, we have used bar each function, right? So bar each and bar both will have the same kind of customization. This width will be decided on its own, you no need to specify that. Again, as I told, you can change it, height and width you can change, but that is way too advanced. Okay, so this can be done. Just you, if someone asks in the interview, just tell them yes, we can customize those. It is not by default. But how that is a really advanced topic. I don't think interviewers will know also. Okay, next is data. How do we create horizontal bar chart? This is a reverse bar chart. So here we can have bar each function to be called for the plot, and similarly we pass in the arguments. Now the next thing to be covered is like bar and bar chart customization will be same as both will be same. So here beside this I can provide the colors also. Okay, so colors, let me put, say what should I put? Let's say I put maroon. So next one I will make it green. So that's how it looks. Okay, so you can pass in the color object, color parameter to it, and these bars will be colored according to that. Okay, so similarly for bar and bar each, same things will be applied. And this plt dot title, x level, y level, we have already seen, right, when we covered this line plot. So similarly those can be plotted. So see here, bar graph demo, quantity, fruits. Here also you can put it in the similar way. You can put it in this way. Let me show you. Copy is not enabled, fine. So the similarly you can do for bar and bar each. So remember, bar is for plotting bar, bar each for plotting horizontal bars. Okay, so that's how bar plot looks like. Okay, so that's how bar plot looks like. Now next, any doubts in this, or scatter plot is fine now? So now we will go to the scatter plot. Okay, scatter plot, see, scatter plot is a bit different. It is not like x and y equation. So we have three data sets, a, b and x. So this is x and y equation actually. So for this x value, this is y value for one. So let's consider this as x and y, and consider this x and y1. Okay, so no equation we need to do. What we can do, we can just generally point these things. Okay, we can just distribute the points over the plot. Okay, so that's how we did. Okay, and this points will be taken automatically. Okay, the colors will be taken automatically. So next we will see how can we customize it. Okay, these are the basic customization techniques, not advanced. Many things can be done with it, just remember that. Okay, so again I will change it to maroon. Okay, so here, okay, next thing to be show you is for line plot we use plt.plot, right? For scatter plot we use plt.scatter. We pass the x and y arguments inside this scatter, and then we get this nice looking output. Okay, next is customizing scatter plot. Same equations we have taken. So this C, either you can write C or you can write color, any way it fits you. Okay, S is for size, that means size of these things. If you make it, let me add another 0 and run it. So it will bigger the size of the data points that you have. So size, that is really size, you can write a whole or you can mention the short name, anyways it will work. Okay, edge colors means if you see these lines carefully, the edge is colored as yellow. Okay, because so edge is colored as yellow. So for, if I do it black, you will see that, I believe it is really hard to see here. If I make it 1, I think you can see. Yeah, now see the green round objects are covered by a black border, right? So that is the edge colors to differentiate between 1 and 2. Marker, it can be different kind of things. So marker have 0, O, 1 if we give, it will give you some this kind of downwards value. 2 if you give, it will give you some upper kind of values. For 3 you will have the in the reverse side. Okay, in the reverse arrow, and 4 you already have it, right? or if you put O, it will be the round objects that is going to be put. Marker, can we customize? No, we cannot. Okay, so these are the choices for the marker object. Alpha, as we discussed earlier, alpha is for the same thing. Okay, alpha is for the same thing, to reduce the brightness of it. Okay, next is plt.legend title x level y level, same as others. plt.grid, same as others. So now if you see, we have a plt.savefig scatterplot.png. So this is to save the output of the curve that we discussed earlier, right? This is to save the output of it. So if I go back to my Jupyter notebook, see here scatterplot.png is saved, and if you open this graph picture, you can see, and then you can use it for your own purpose. You can attach it in mail, you can send it, or you're going to do whatever with this. Okay, so that's how you can save the figure to a nice looking image. So that the command for this is savefig, plt.savefig. Okay, so plt.savefig, that's how it works. So that's what is with scatter plot. And now next is this histogram. Okay, so is that clear? Next is histogram. So histogram is to show you counts for some numbers. So we have taken a huge data set to show you this counts. Okay, and we have created the histogram using plt.hist function. Okay, next we have passed in the array that we need to plot in histogram, and we have passed in this bins, right? So bins means where these markers will be put in. This is again intuitional, you can put it anywhere you like. So these are the markers, the marker points. So 0, 20, 40, 60, 80, 100, like that we have given. So how to, yeah, bins are intervals only, correct? So how to understand this histogram? So can you check the data? If you check the data set and if you see how many points are there between 0 and 20, 1, 2, 3, 4, 5, 6, 6, right? So if you check this, so 20 we have 1, leave it. So till until 20 we have 5 points, right? If you check from 0 to 20, what is the value? What is the y value? 5, right? For 20, so from 20 to 40, if you count, we will have 7 values. So it will be going up to 7. Okay, 40 to 60, it is really small, right? Only 1. So see here, the height of histogram shows you 1, right? 60 to 80, if you count most of the numbers. So 68, 64, 62, 60, 70, 78, 75, 79, and all those numbers. So almost 7 numbers almost. So if you check our 8 numbers, whatever, so you will see 8. Okay, 80 to 100, 3. So 3. That's how to understand histograms. Okay, that's how you need to understand histograms. So that's what histogram denotes. Histogram denotes the frequency of data points between a range. So from 0 to 20, how many? 22. So what happens if we add another bin, right? The graph shape will change radically. Why that will change? Because within 0 and 10 we don't have any point, so it has kept it blank. So we haven't put the marker over there. Now let's say we are plotting a marker in 30. Okay, we are changing this to 30. So see it, from 20 to 30 the bin has changed, right? Because we have created 2 different markers. So 20 to 30 we have a dip, right? We have a dip. So within 20 and 30 we have 3 points, and 30 and 40 we have 4 points, like that. So that's why between 20 and 40 we have total number of 7 points. Okay, that's how to understand this bins attribute, and that's how to explain a histogram to someone. Yes, right, it will be changing with data, correct? Okay, so this is to color the histogram. Yeah, so that's what I'm telling, right? So that's what I told earlier only, right? Before starting with the examples. Bar you will see when you just need to, when you have the counts of some data points, you need to display those in a graph. So that's why when you use bar. Linear equations, when fits into scenario, you use line. When you want to see the distribution of data over a plane, you use scatter. And when for image processing kind of thing, and when you need to find out counts of data points, you use histogram, right? You don't know the counts, you want to find out without writing a code. You can, if you plot a histogram, you will have the counts, right? Okay, next is customizing histograms. Again, we have provided this bin numbers. Age color we have provided as black, and color we have provided this funky red color. Okay, title, X level, Y level, grid, sefig, already you know this, right? So same thing, not wasting much of a time. So edge color and color, we can do it in all the graphs, and we can customize the graphs. Okay, so if you see this box plot, right, box plot contains the quartile information of a data set. Okay, this is the statistical plot that we use heavily. So this below line will be your Q0 and the top line will be Q4. In between, this will be your mean, that is Q2. This will be Q1. This will be Q3. Okay, 4 lines will be there. Now this is how this data will look like. Now how do we calculate those Q1, Q2s? Okay, I have considered this data set and I have calculated all those calculations. I have done all those calculations in my Word doc. Okay, in Word doc we have all these calculations. So what we are doing, we are just having the equation, we are just sorting the array. So if you sort the array that is given, you will get this kind of an array. Okay, this array you will get this one. Okay, so next what we are doing, we are finding out the second quarter, we are finding out the mean of this. So how do we find out mean? What are the number of points? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, right? So we have even number of points. What is the definition of mean? Mean is the middle point of the data set to which all the left values will be less than to that mean, and in the right side we will have greater than or equal to the mean, right? So we have taken, and for odd even number of values we take the middle two values. So we have taken these two values, we found out their average and we found 20, and 20 is our mean. Okay, 20 is our mean, and this 20 is referred to as second quartile also. Okay, now so this is the mean. Okay, so here we split the data set. Okay, here in this 20 point we split the data set. Now as we have two middle points of the data, so 2 point we can consider in the for 2 parts. First let us take this part. Okay, let us take part from this to this 20 and part from this to this 20. Let us take this 2 part. Now this is already sorted, so we will again calculate their mean. So here if you see 5 number of data points are there, so that means odd number of data. So we will have the midpoint, that is 10 as our quartile. So 10 as our mean. So this mean is called as Q1. Okay, this is the first quartile. Okay, from 20 to 70 we have 30. This is called Q3, third quartile. So what this does, this gives you this 3 Q1, Q2, Q3 informations. And if you see Q0, Q0 is the minimum number and Q4 is the maximum number. Okay, Q4 is the maximum number. These two are first and fourth quartiles. Okay, so 0th can we say 0? So that is our first quartile, second, third, fourth and fifth quartiles. So we have 5 quartiles. So we generally consider this Q0 to Q3, Q4 is the last one. So we don't really consider this as a quartile, but you can tell it like that. So this information will be pasted in the box plot. Okay, this information will be provided in the box plot that we have in here. Okay, that we have in here. So if you see carefully, for the first, this total, this is the box plot for that. What was the minimum value? 1, correct? So here it is 1. What was the first quartile? 10. What was the mean? 20. What was the third quartile? 30. And this sums it up. Okay, this 30 sums it up. So this is the box plot. This much you focus on, and the max point, that what I was referring to as Q4, that is not there. That doesn't present. That is not present anyways. So here it is. Okay, how this height is defined? From 10 to 30, how many points are there? 6 points. So that's why this box is a bit bigger. Okay, that box is a bit bigger. So this, the height of it's almost 6. So that is what this height denotes. Okay, from 10 to 30, how many values, like that. Okay, so that's what is this height about. Okay, that's what is this height about, or you can say it like Q1 and Q3. In between, this height is given. Okay, so this box means here the maximum number of data points are concentrated in here. So between 10 and 20, how many points are there? If you check, so we have 2 10s and 3 20s. So in a data set of 10, we have 5 values within 10 to 20, right? Within 10 to 20. So that kind of information you can get from there. Okay, that you can get from this box plot. So it basically shows you again the distribution of the data and the basic statistics of the data, the quartile range, and how and where and which part of the data is concentrated. Where the data is more concentrated. Okay, the height of the box is how many points are there, like that. So 10 to 20 or 10 to 30, we have 7-8 data points, so the box is a bit bigger, like that. And from 0 to 10, we have 3 data, so that is the height. Okay, it won't match with the graph, it is just for visualization purpose, it won't match with the graph height. I am just telling you for ease of your understanding. Correct, that is IQR actually. So IQR is, this is between Q0 Q1, this is between Q1 Q2, this is between Q2 Q3. Okay, so that is what is the frequency of the data, right? So that's why we calculate IQR. IQR is to give you a rough idea about how the data is, what is the frequency of the data, how it is spread in a in a range, right? So that's how this works. This won't match with the box line. So this big lines are IQR, interquartile range, and how many data sets are there, like that. So that's what is about this box plot. So here we haven't done many things. We have taken 3 distinct lists. We have taken all those into a single list, and we have plotted the data sets, and we have plotted that using box plot. Okay, that is the command for that. We have told it to show the means. We have passed in that show means to be true, so that's why that orange dots are shown. Okay, those are the means actually. So that's how this box plot works, and that's what kind of information you get from this box plot. Okay, that's what kind of information you get from the box plot. So this is what is about this box plot. Others I have already explained, so not repeating those things. And if you go on this code perspective, we have taken 3 different lists of total, order, and discount, and we have combined all those 3 lists into one using this list command, and we have passed 3 separate lists to plot it. This is just to have the information handy, because this is just to follow the syntax of the box plot, because it takes in the entire data set and it will create 3 boxes for 3 different data sets that it has. Okay, so that's how this box plot works, and that's what kind of information we do have from this box plot. And generally speaking, when you start analyzing data, you will use this box plot to quite some time. Okay, to check the data distribution and to check the quartile range, to check how it is distributed among the quartiles and like that. Okay, so that's what it is. Okay, see, don't think about the height much. So that height is basically the IQR, that is the distance between Q0 Q1, and that shows how many data points can be there. Okay, so that's what is this height reflects. Okay, height doesn't have much of an scenario here. So this is just to connect the plot and show it like a box. That's why the heights are there, and the distance between 2 quartiles are called IQR, that is interquartile ranges. Okay, so the the value of the height is interquartile range. So that is the frequency of the data set. Okay, what does that mean? So say 0 is the minimum value and 10 is the first quartile. So if you check the quartile range for the first quartile, that is 10, right? So the height equals 10. Okay, the mean is 20 and the Q3 is 30. So what is that quartile? That is like 10, right? So that's how this height is there. That is the interquartile range actually. Okay, so that's how it works. Okay, so next one is violin plot. It is the same as this box plot, but it is different. It has the same values. Okay, Q0, Q1, Q2, mean, and all those kind of things it has. But what you see here is a violin kind of a shape for all this distribution, right? So that shape that you see, the shaded area that you see outside the middle line, that is the probability density function of the data set. Okay, that is the probability density function of the data set. What does that mean? Okay, what does that mean? So okay, what does that mean? This shaded area. Okay, this shaded area. So this is the probability density function. That means probability of having a number between. So what is probability density function? Probability density function means the probability of a point being in a range or a probability of an event being occurring, right? So let's say we have a range of 0 to 10. What is the probability that in for a particular data set, what is the probability that number 4 will occur? What is the probability of number 4 will be there in the data set? That is what probability density function calculates. Okay, so that means this is the probability of an event being happening in a sample space. You can, if I go by the by default stats terms, that is how it looks like, probability of some event happening in a sample space. So that is what it defines in probability density function, and the same thing reflects in violin plot. So how can you use it? Similarly, as I show you the calculation for q1, q2, q0 to q3, same lines are there. See, only 4 lines will be in here, right? If you see, there are 4 lines, so those lines are for q0 to q4, like that. And then the outside shade is the probability density function. So how can you see, what can you configure from those? Between 1 and 20, how many values are there? If you check the data set carefully, there are 5 to 6 values between 1 and 20. So that's why the curve is thickest at that point, right? So there is a high chance that if any future data comes in, so it will be in that range. So basically you need to think it in a bit other ways. So this static data set won't explain you. So let's say you have built a model. Okay, you have built a model based on some features. Okay, how I mean, I am trying to explain when you use it and how you use it. So let's say you have built a model without seeing anything. You have put in some features, you have taken into you have assigned the features into the weight to the features. So now how do you validate that? So if some feature values are in between, lying heavily between 0 and 20 or 30, then that means when you get a test data set from that of the same pattern, it will always follow that probability density function. So that way you can understand which feature to have what kind of a weight. Okay, and which feature is having what kind of a distribution. So these things you can check. So that won't be only a single feature, that will apply for all the features. That is a machine learning data set that you will have. So this applies to all those. For ease of understanding, I explained with one, because there is only single arrays are taken into account. So this we will plot for all the features, and we will see how the data is being differing. Okay, what is the probability that in future we can have different set of data. So if we have some true false kind of skewed data set, we will have it often. So 0 and 1 kind of data set if we have, then probability density function will have 2 peaks, one near 0, one near 1. Okay, so that's how it will look like. So let me try and show you. 10 points we have, right? 4, 5, 6, 7, 8, 9, 10. See here, because this is not visible, because this is having this large values. So this value, if you enlarge it, you will see that this is stacked between 0 and 1 only, right? So you will see 2 peaks in here between 0 and 1. So that's how this thing works. So let me try this. See, you have 2 peaks, right, between 0 and 1. So as we have more ones, so the peak is flattened near 1. As we have less number of 0, so it is flattened near 0. But see, between 0 and 1, the curve is getting shortened, and when it goes so 0.6 will be their mean. Okay, because that is what we have taken as 0 and 1. Okay, so 0.6 will be their mean, and if you see from 0 to 0.6, that the curve is let's say 0 to 0.4, the curve is wide enough, right? Because till 0.5 we can consider it to be 0. So from 0.4 onwards it started to increase, because if it is greater than 0.5, we can estimate it as 1, right? So and at the 1 it has a maximum width, and at 0 it has a maximum width. Others are just shortened, right? So that's how probability distribution function you can use. So here what you can see, this is a skewed data set, right? This is a skewed data set, so this cannot fit a straight line equation or something like that. So you need to change it, you need to change the thinking, and you need to choose, explore other options. So that's how you can check that. Yes, this is a binomial function. So this is a skewed function. It will be of form e to the power x, right? E to the power x by 1 plus e to the power x. That is sigmoid function. Like that we will have this. Okay, this function will output two values only, 0 and 1. So that's how it works. Okay, so that's how violin plot works. So if this is clear, we will just I don't have examples for this because we won't need that. I will just explain these three plots actually. We won't need that much, so I will explain what are those and how they are used like that. Okay, next is this quiver and stream plot and area plot. These three we are not gonna use much. I will start with area plot. What is area plot? Area plot will show you the area covered in a line. So how you can see that? You can check like this. So let's say we have a line plot. Okay, we have a line plot. I am drawing some line over here. So let's say we have a line plot like this. So let's say this is the line plot. So area plot, what it will show this area. So it will show this area that we have inside this. Okay, that is the area plot. So that is to show you the area covered by a curve. Okay, area covered by some curve that we have. So that is what is called area plot. Okay, that is what is called area plot. Now if I show you here, like this is the quiver plot, right? So if you see all these individual data points, right, these individual data points are looking like vectors. It has some directions, right? So that is for basically magnetic field analytics and high-end physics needs. These are basically vectors. These are basically directed vectors. This is basically needed by physicians. Okay, this is basically needed by physicians. These two plots, this stream plot, this one up here and this one down here, these two things are basically required by physicists to analyze the vector and to do vector analysis. Here if you see, this has pointed ends, right? So that is the direction of the vectors that goes in or out. So electrical engineers or physicists can use this plot. So if any electrical engineer is there in class, you will understand this, right? Current inflow, outflow and all those kind of stuff. So if you have a large circuit, it will something look like this, right? So if you have a midpoint in here, what is the current input, what is the current output, and all those blah blah stuffs of electrical things will be there. So that's how this quiver plots are used. That's how the stream plots are used also. In stream plots, what is the stream plot? What is the difference? The difference is in the stream plot, we won't have that vector direction. We will just have positive or negative value for a vector, and that will be just a representation of the vectors in a 2D plane. Okay, so that's how this quiver and stream plot works. And area plot shows you the area covered under a curve. So these three plots, data scientists are rarely uses. Even if you use area plot somewhere, some down the line, but quiver and stream, let me assure you, you won't use it ever. Okay, because we are not gonna deal with vectors, right? That's how. Okay.
Also guys, if you're looking for an end-to-end training in Python for data science, Intellipaat provides a Python data science course and training which covers all of the concepts which you need to learn and also will help in getting you a job. So for more information, check out the description box below or visit intellipaat.com.
Just a quick info guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
So that's how we have image plot. So just know how to do that. If you open an image, okay. So how you can do it? You have image processing library called Pillow inside Python. Okay, you have Pillow library in Python. You can install it. No need to do it. Okay, no need to do it or remember it. This won't be used. So using Pillow library, you can use this image function and you can open an image. All images are what? Arrays, right? They are arrays of pixels. So you can convert it to a NumPy array. You can pass that NumPy. You can plot that NumPy array itself, and that would serve your purpose, right? That will serve your purpose. So this is what. ax1.imshow. Imshow is for showing the image. That is again a Matplotlib function. And if you pass in the array, the corresponding values will be shown as a image here. Okay, the corresponding values of the pixels will be shown as an image in the output plot. Okay, so that's what is image plot. And the image plot to histogram also you can do, so that way you will see the distribution of the like that distribution of the colors in that, right? Colors or pixels in that. So see here, this is at 250, this is a very high value, so it might be some pixel having high value, because see blue is having a pretty dominant color here. Blue is pretty dominant, right? So that's why it might be causing this high value kind of thing, right? So that's how is for image plot. That is not at all used. Quiver's theme, as I already told, the example is not much required. See here, this is a plotting a vector. How can you do? You can do it using Quiver, this Quiver option. Okay, this Quiver option, we have created a subplot, then we have created this Quiver option. Okay, using this Quiver, if you pass x position, y position, and the directions, so you know, right, the vectors will have two directions, 1 0 1 -1. This is the direction of the vector, so it will go from 0 to 1 upwards, and this will go from 1 to -1, that is in a downward way. So that's how the vector directions work, and that's how the vector calculations work. That's how you can plot a vector. Okay, here we're using Quiver plot. So this is a 2D plot. This is a stream plot actually. So stream plot is used for vector calculation, vector algebra, vector physics. I mean, wherever you have a vector involved in physics, electromagnetics, electrical engineering, stream analysis like cyclone analysis, wind trend prediction, like those kind of scenarios, you will have the stream plots into account. Okay, so this is just a bit different from the vector plot. And here also you have the same thing, the stream plot function. Okay, but you won't be, you will use it pretty less. Okay, see here, this is a trend analysis, a wind trend analysis kind of thing. Okay, so that's how this stream plot works. So see, the pie chart is to show you percentage or proportional data. Okay, so this can be this can come handy when you have more than 4 or 5 categories. Then box plot will take up a lot of space, and from the box plots also you will only see the values, right? The counts and the categorical values like that, but you won't see the percentage of the data that is being placed in those each of the categories. So those kind of scenarios pie plot comes into picture. Okay, I will show you the coding example for this pie chart. Okay, but it's not much left for pie chart to be customized. So let's see. So if you see, so now it will be easier for you to understand all these functions. So first what we have done, we have taken a label array of 4 and size array of 4. So that denotes in a data set what is the what are the number of dog, cats, wolves and lions that we have. Okay, so if I show you a quick math, that then it will be easier. So let's say what are the values that we have. We have 50, 45, 60 and 80, right? We have 50, 45, 60, 80. So how it calculates? So 50, 45, 60 and 80. So it comes to 140, it comes to 95, this 2 comes to 275, right? So we have total of 275. Now if you calculate 50 by 275, how much it comes? It comes to 10 by 52. So that is somewhere around 20%, right? If you calculate this, it is somewhere around 20 or 19%, right? 50 is the count of dog. What is the percentage of dog? Percentage of dog is 21.3%, right? So this kind of percentages are calculated and shown over here. Okay, for cat it is 45, so it will be around 90% like that. Okay, so that's what kind of information you can get from this pie chart. Okay, now how do you plot that pie chart? You need to use plt.py function. Within py, if you provide some, and the options I will explain now. So sizes is one variable, labels is another variable. So labels we need to pass it, because otherwise this labels of lion, dog, cat, wolf won't be shown. So and it will be equally, it need to be in the same order as the size array. Okay, otherwise the this labels will be misplaced. Okay, next is auto PCT percentage 1.1 f percentage. That means what is the display percentage, what will be the format of it. So we want only one decimal after we want only 1 point after the decimal, right? So that's why we have given 1.1. So that is the number will be whole intact. Then after the decimal, we want only 1 point. So that's why 1.1. Shadow true means you see there is a shadow effect inside. If you give it as false, I will show you. Then you will understand the difference between these two, shadow true and false. So if it's a if it's a 3D plot, I mean if so here the shadow is not really visible, but it should be if you use lighter colors. Okay, lighter colors will have you the shadow visible, so it will have a bulging effect actually. So that's how it will look. So that is not much used, you can leave it. Okay, start angle is 90 means then the angle will be 90-degree angled. Okay, so it will have a equal kind of a shape, so it will have a equal kind of a array actually, I mean sorry, equal kind of a shape of the circle. So that's why start angle equals 90. Explode, as you can see, if you mention 0.1 as an explode, then it will be those slices will be cut out from the array and it will be outside the array. So that's how explode function works. And explode you need to give 1 for each. So where I have mentioned 0.1, those slices, see, they're cut out from the pie chart, right? That's how this pie chart works. Okay, so pie and donut, I will finish it, then I will open for question here. So donut chart is the same thing, just the difference is it shows the area. Instead of showing the percentage, it shows the area. Okay, for that what we do, we create two pie charts and we combine those. Okay, so see here, we create one pie chart here. This pie chart, if I show you one by one, so this is a pie chart, right? We don't have the numbers mentioned, so we haven't mentioned auto PCT, so it haven't shown. We haven't mentioned shadow, so this kind of effect is not there. If you see these two, difference between these two, you will understand what is the difference of the shadow function, right? So this is a pie chart. Okay, we have created a pie chart using this variable that we have. And okay, this is color white, let me make it black. Black is coming as blue. Why? Okay, black only one body takes, that's why it's taken blue. Okay, got it. So that's how it will take only one word in the color, so that's why it is taken as black. If I put O is not supported. Y is supported. Okay, so Y for yellow. So you see here we have a yellow kind of a circle. So this circle is to give the blank inner filling. Now if I run this first pie and second pie together, see this effect we want to give, right? So this is a pie chart that is there. So if you remove this second pie chart, what happens? This is the entire chart, correct? This is the entire chart, correct? What is the radius of this? 1.5, right? Now we want to show it as a donut. So what we can do, we can cut out some area, right? So that without saying, if I draw it, it will be easier. So being said that, so let's say this is a bigger circle. Okay, let me change the color. So let's say we have blue here. So this is a bigger circle and we have these three parts. Okay, we have these three parts. Okay, let me change the color again. Let's say I'm taking green. So this part is green. So next I'm changing it. This part is pink. Let's say like that. Okay, and this part is orange. This is filled up. Okay, this is entirely filled up. I am not going to fill it up. So what you can do, you want to show only this much. Let's say only this much you want to show. Oops, sorry. Let me change the pen color. It will be easier for you to understand. I have exhausted all the colors. No. Let me show. Let me just think. We want to show to the viewer this much of value, this much of portion. So what can we do? We can fill it up with some value. We can fill it up with some color. Let's say we are filling this up with orange. Okay, what will happen? This shade will left upon, right? This outer side circle will be left upon. So that's what that's how you can create a donut chart. It is not an option in it. So let's say if I increase this, you will see the donut chart gets shrinked. Okay, the donut chart will get shrink. That's why we have used white here, and that's how it works. Okay, if you use 1.5, the donut chart will vanish and it will have a slight effect over there, right? If you use 1.3, it will be pretty thin, right? So that's how you can create a donut chart in Matplotlib. Okay, that's how you can create a donut chart in Matplotlib. The pie chart you will create and you will empty its center. That's how you can create it. Okay, so two pie charts combined together will give you a donut chart. Okay, so that's how this works. Okay, so for your ease of understanding, I will leave it as yellow only, so that it's better for you to understand how you create donut chart. There is no donut chart, you are fooling the audience. Okay, so next is area chart. So what you can do, you can use stack plot function, and if you pass two variables, then it will show you the variable the plot covered. So let me show you using a line equation. Okay, oops, sorry, let me copy the line equation that we had earlier. Which one? L. Yeah, so that's how this will work. Okay, that's how this will work. So for this color, if you write black, it won't work, but if you do color, it will work. Yeah, so that's how it works. Okay, so see, now we have, let's not give it green, let's give it maroon, let's give it green. So if you increase the transparency, it will be easier for you to show. Yeah, looks nice. So that's how this stack plot works. So see, this is basically denotes the area covered between a curve. Okay, a curve or a straight line or whatever is it. Okay, so that's how this stack plot works. So stack plot is basically for showing you the area. Okay, the area of the plot covered. Okay, so that is how you we have this area plot. So this area plot you might use somewhere, but not much used at all. But this quiver and stream you won't use. Pie donut you will use often. If you have some presentations, you will use this. And without from now on, what I can suggest you, if you are working on some data on Excel and generating some graph on Excel, try to switch to this one, right? Try to switch to this editor like this, like Python. Okay, so just try to switch to Python, and then you will have nice looking charts, nice looking things, and you will learn this Matplotlib library in a vast details. So that will help you. I believe whoever is there, everyone is working on this Excel heavily, so you can try it. Okay, you can try Python for generating those charts also. So that way you will learn it. Okay, you will learn it quite well. So that's how we have.
We are going to learn machine learning using Python, right? So these are like the applications, as I told you, like the product recommendation, the video recommendations, all which comes in Amazon Alexa, Microsoft Siri, all these like are the applications. You know, when we deal with the data, and we also had discussed this when we discussed the Numpy. I told you that we can have the data in the audio format, in the video format, in the images format. So based on the data, we have the different applications, right? So like movie recommendations, as Google traffic prediction, your Google self-driving cars, all these things are possible because of your machine learning. And definition, machine learning is a subset of artificial intelligence which gives a machine the ability to learn without being explicitly programmed. It's like when the machine is learning itself from the previous data, we are not going to program everything, right? Like it is not just working on our instructions, it is working on how the data, what type of data you are feeding into the machine. And data is the key and the learning algorithm. I told you that two things are important. First is your data, because without data it's not possible, and second are the algorithms. And I hope you all know what algorithm is. Algorithm is just like the set of instruction, right, which you give to your machine, that how you are going to learn the data, or what mathematical formula you will follow to learn the data and to get the right predictions. Okay, so machine learning class, as you can see that data cleaning is again a very important part. Data cleaning is basically cleansing or cleaning, you can say, that when you have the unstructured or the dirty data with you, how you are going to clean it, and that usually almost takes 70% time of the data scientist. So as like here, it's just like a meme type that this boy is behaving, Robbie is behaving bad with this girl, so the trainer is saying that I'll send you to the data cleansing class if you don't focus on this. Okay, because data cleansing is like very irritating truly, but just a part of your process. So if you are into a data analytics, right, so you need to perform it. So I told you that machine learning comes under your artificial intelligence, and then just deep learning is just the extension of your machine learning. Okay, so now let's just talk about the types of machine learning. So basically there are three major types, which are your supervised, unsupervised, and reinforcement learning. So let's just talk about the supervised machine learning, that what supervised machine learning is. So see, supervised machine learning is the type of machine learning on which the target variable is available to you. Right now, what do I mean by target variable? So before going into that, let's just talk about a few terminology which you should be aware of. So for that, I'm taking the paint window, and here I'm going to make one data set, and on the basis of that data set, I'm going to explain you what the target variable is, how actually the supervised machine learning algorithm works, and after that, you will get the understanding that what supervised machine learning is. So let me just create here one data set. Okay, so I'm just creating a random data set which suppose consists of only 3 columns. Okay, so let's just mark the 3 columns. So suppose the first column here I'm taking is the let's say this data set is basically the data set of the certain trainers, right? So trainers means like the people who provide education. So let's say that how much years of experience they have, like their number of years in education. Secondly, either that person provided the corporate training or not. But okay, that either that person provided the corporate training or not. And the third one is like based on these two particular columns, you have the hourly rate of the trainer, that how much does the trainer charge, like the hourly rate of the trainer, right? So this is this data we have. So let's just say that first have 12 years of experience, second have 10, then say again 12, then say 5, then say 6, and then say again like 10, or let's say 15. Okay, so suppose that like few data has been given to you that yes, this provided the hourly training and a corporate training, and how much does he or she charge. Suppose he or she charge $90 per hour, right? So similarly, this one doesn't have the corporate training, doesn't provided the corporate training, and he or she will charge, suppose, let's say $50, right? Again, no. So let's say that $60, right? So yes, say yes. So say $45. So just randomly I am entering, right? And for 6, say no, and say $30, right? And for like in the machine learning algorithms, again yes. And so now let's just talk about the few terminologies I was saying. So see, I told you that based on the year of experience, right, based on the total number of years or years of experience or education years and corporate training, right, and corporate training, you have to predict the hourly rate. Okay, so hourly rate will become your target variable, because hourly rate is something that you have to predict, right, for the new trainer. So hourly rate is your, there are like terms used as like, you can say this as target variable, right, and this is also known as your dependent variable. Do remember this terminology, right? Because like it's been going used a lot. This is a dependent variable, or you can say this is also known as the response variable, because that is something that you need to predict, and predictive variable as well, because this variable is I'm going to so these are something, these three terminologies: target, dependent, and response. Okay. Similarly, when it comes to your number of years and your corporate, so these are your independent variables. Independent variables means that the variables which are not dependent, these are basically your independent variables. Independent variables are the variables which are not dependent or anything, and they are also known as either your feature set as well, because based on these features you are going to predict your target. So first tell me that have you understood this terminology, that your number of years and corporate training are your dependent variable or your response variable. So see, now supervised machine learning is a type of machine learning in which you have the target variable available with you. As like this example is the example of your supervised machine learning, because for this is your new data, right? For new data you have to predict. So for your new data you need to predict, but for all of your previous data have the target variable available with you. So this is the example of your supervised machine learning. So now if someone asks you, you have to calculate that what will be the hourly rate of the new data, right, with the given set of features. That is your target. So wherever, like for the previous data, the target variable is available or it is given to you in the data set, that is something known as the supervised machine learning problem. Okay, so now this is the whole idea about supervised machine learning. Now if someone asks you what is supervised machine learning, so what you will say, the type of data or the type of problem in which we have the target variable available with us, that is known as your supervised machine learning. That types of problems comes under your supervised machine learning. Okay, so see, firstly, what do you have in your supervised machine learning? So see here, suppose I am having data, right? Listen to this, view to this chart carefully. You have data. Data has been divided into two parts, which is your features and your target, right? Features and target. Like with each feature you have the target available with you. Then you are going to pass these features and target to one machine learning algorithm, right? So here suppose I am making the ML algorithm. You are going to pass this data to your machine learning algorithm. Now this machine learning algorithm will create a model. Okay, this machine learning algorithm will create a model. Okay, then here you will have the set of new data which only consist of features, right? Because like you need to make the predictions for it, so it only consists of features. Then you are going to pass these features into your machine learning model, and then this machine learning model is going to make the predictions for the new data. So this is the complete understanding of your supervised machine learning. Now let me just move to the GPTs, what is there in it, and check it out. Yeah, so this is, so like you can see, this is a training data. This teacher is training to a robot that this is the apple, and 97% it's the apple. When this is what, so when he asks that what this represents, so the robot will say 97%. Okay, so use cases for supervised machine learning is the ham spam, as like some of the mails are go automatically to your spam folder, so that the ham spam classification, and this is your supervised test, right? So let's just talk about the unsupervised learning a bit here by looking at the see. So as you will see that in unsupervised machine learning, like one of the type of unsupervised machine learning is k-means clustering. So when you have the data like this, as there is no target variable, not the right answer you have with you, so we just find out that which features are similar and we try to combine them. So as you will see that all the apples will come combined together by looking at the properties. That something round, red in color, that is your apple. Something in the shape of cylindrical, yellow in color, considered as banana, like round, and orange in color is usually the orange. So we make the clusters, right? This.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So now let's just come to one another main concept. Okay, so see, as I was telling you that we are talking about the supervised machine learning. Okay, so see, in supervised machine learning, you people know that you have the target variable available with you, right? You have the target variable with you. So see, whenever you have the machine learning problem, always remember this, that your first step is that whenever you'll have the machine learning problem, because whenever we start any project, we usually have the problem statement associated with it, right? So whenever you have the machine learning problem statement, what is the first thing you are going to check? You are going to check either the target variable is present or not, right? Either the target variable is present or absent. This is the first and foremost thing you people will check. Now, if suppose that the target variable is present, okay, so then what will be the type of machine learning? If the target variable is present, supervised. After checking this step, in the second step, what all you are going to check is basically that what is the type of the target variable. Now let's just talk about what is the second thing you are going to check, that what is the type of the target variable. Now what do I mean by type, right? So let's just talk about that, what do we mean by type of the target variable. So see, type of the target variable means that either it is continuous, okay, either it is the continuous data, or either it is your categorized data. Okay, now what do I mean by continuous or the categorical data? So see, continuous is something as like any value. Suppose if I say that here you have the target variable is price, right? So see, price can be any value, either it can be 23.5, okay, either it can be 24.2, or either it can be 25, or any value can be there in the price. Or if I say that salary, right, if I say weight of the people, height of the people, so all these things are your continuous, where you can have, suppose if I say in between the range, or like you can have any value exist, like floating values as well. And categorical variables are the variables where you have the classes. Suppose if I say that your in your email classification, you have two types of classes, that is spam or ham, fine. And the another example, suppose if I say that you have the when it comes, suppose you need to predict the gender, okay, based on the certain characteristics, there will be two, right, either male or female. Okay, and if I say that suppose you need to check that either someone go out or not, right? Suppose go on date, let's say based on Valentine week, right? So based on the certain characteristics, you need to predict that either that person will go on a date on 14 or not. So again, there will be two things, either the person will go on date or either the person will not go on date. Okay, so when you have the classes with you, then it's your categorical data, right? All these come things like height, weight, salary, if I say that the stock price, all these things comes under your continuous variable. . Yeah, so now, so what will be your second step? That you will check that either your target variable is continuous or it is categorical. So if your target variable is continuous, so always remember that it is your regression problem, right? So if basically, now what is the thing you need to remember, that if the target variable, right, is continuous, if the target variable is continuous, then what is the problem type, or like what type of, which of algorithm you'll use basically? So then it is the regression problem. Now what is regression? I'll talk to you about that. So then it will be your regression problem, right? And if your data, like if your target data is categorical, so then it will be your classification problem, right? Then it will be your classification. Then which type of algorithms you are going to use? The classification algorithm. Now there are many classification and few regressions as well, which all we are going to discuss in detail. Fine. So let me first just talk about the regression analysis, that what actually the regression analysis is. So see, the regression analysis is a statistical tool that is very useful in cause and effect measure. Is a statistical tool that is very effective in cause and effect manner, right? So now what do I mean by cause and effect? As like, suppose when I say that what will be the effect of temperature on humidity, right? What will be the hydrocarbon level of the water, how it affects the purity when it comes to your distillation process. So something like which, where the two things are interrelated to each other. So when we need to find out the cause and effect of one another, that is something known as your linear regression, right? So I have the various PNGs with me. So regression analysis is a statistical technique, as I told you, that is very useful in cause and effect measure. And some of its examples are like effect of temperature on humidity, right? What do you think? What will be the effect of temperature on humidity? If the temperature increases, will the humidity increase or decrease? Increase, right? Process effect of height on weight, right? Height and weight of the persons are usually interrelated to each other. Effect of hydrocarbon level on purity of water during the distillation process. Okay. And other examples is like effect of number of TV ads on number of cars sold, or you can say that a number of ice cream buyers with the effect of temperature. When usually it is too hot, the people are more likely to eat ice creams. In the cold weather there are very few who likes to eat. Fine. So it's like the cause and effect measure. So this is about its simple definition, like theoretical. But when it comes to your mathematics, right? So there is one, like there is the equation. So before actually going into the equation, let me just explain you with this example, that suppose if I take the example that uh, number of cars sold, let's just talk about this example, that number of cars sold on the number of ads. Okay, so suppose that you have two columns in your data set. The first is your number of ads, right? Number of ads in TV, number of ads on TV. And second one is the number of cars sold. Okay, number of cars sold. So number of TV ads is basically something given to you, as like suppose when there are two ads, there are one car sold. When three ads, it's again one. When four ads, it's two, right? And when then 10 ads, then there are 13 cars sold. So like this, you have the data set with you. And then in this particular model, what you need to predict, that if some, suppose like on one day, the number of ads are 15. So what will be the number of cars sold, right? So this is your problem, and by looking at the problem, we just find it out that number of ads will be your independent variable. This will be your independent variable. And number of cars sold, because you need to predict that how many number of cars sold, so then it is your target variable, right? It will be your target variable, independent variable or feature as well. And always remember that in machine learning, the capital X, right? The capital X denotes the independent variables, like set of independent variables or features. Set of independent variables or features. Cool. And your y, small y, always represents the target variable. And I told you that there will be only one target variable when it comes to your single data set. Okay, so let me just remove this and open the paint window so that we have the clear picture. Okay, so as I told you that capital X, what does the capital X represent? Your set of features, right? Capital X, X represents the set of features, and small y represents the set of target variable. Okay, so what does the linear equation do? That in linear equation provide us a set of equation, okay, which describes how y is related to x, okay, and error term in the regression model. Now what is this error term? That I'll tell you a little late, but as of now what we need to understand that the linear regression, I mean this regression analysis provides us the equation that describes how y is related to x, okay, and error term. Like what is this error term? I'll tell you in okay, this is what the linear regression equation is described. Okay, so let's just understand it, right? So suppose the equation of the linear regression is y is equals to beta naught, okay, beta naught plus beta 1 x, like, or you can relate this equation with your equation of line as well. I hope you all know the equation of line. What is the equation of line? Y is equals to m x plus c. Okay, so what is your c? C is usually my intercept, right? And what is your m? M will be your slope of the line. Okay, what will be the slope of line? So the same happens in the linear regression equation as well, where your beta naught is basically the intercept. Okay, intercept means like the point from where the line cuts the y-axis. I'll show you. This will be your intercept, and this beta 1, you can say this as slope, right? You can name this as slope, or you can also say this as the coefficient of x, right? So what actually happens in the linear regression line, that suppose you have x-axis and y-axis on the graph, fine. On capital X, we always have the, like, this is your x-axis and this will be your y-axis, fine. So here you will have your regression line like this. Suppose this is my simple line, okay, or the regression line. Then this point, this particular point from where it is cutting y-axis is known as the beta naught, okay, or the intercept beta naught, or the c, fine. Yes, yeah, right, Gurvinder. Okay, so now let's just understand this with an example, that how actually does it works, and how do we find a line, how do we draw the line, how actually the predictions happen, okay, what is the formula and everything. So to take the example, let me just create a small data set and take a new file. And I'm not saving it because I have the ones. I'll share that with you. So suppose here I'm taking one small data set, okay, and this data set you consist of the two columns, the same example which I just explained you, number of TV ads and the number of cars sold. Okay, and then we'll take the few value of them. So okay, so your first will be the number of cars sold. Okay, or you can say number of TV ads, yeah, because number of TV ads is your set of features, number of TV ads, and here you have the number of cars sold. Okay, 5, there are 5 values I'm taking. Okay, and just the small value, so that we have the small data for the calculation. Number of TV ads 1, and let's say number of TV ads here 3, and with the corresponding let's say number of cars sold 24. Okay, then 2, and then say here 14. So a little bit calculation is required, so please be ready for it. You can like put out your calculators, or you can use tab or phone calculators as well. 17, and then you have here 3 and 27. And oops, let me write it here again, which is your when 1 there are 14 ads. Okay, so as I told you that capital X will be your set of features and small y is your independent variable, right? So now let's see that how we are going to calculate the how we are going to draw the regression line out of it. Okay, so as I told you that to draw a regression line, we have the equation which is y is equals to mx plus c, right? So what all do we have in this equation? We have x with us, right? This refers to x, and we have y with us. This. So what we need to find out? We need to find out the m, and we need to find out the c. Okay, once we have m and c with us, so then we can find out the predicted y. And let's just take that, suppose you need to calculate it like when there are 4 number of TV ads on TV. Okay, what will be, how many cars are sold? Okay, or the 5 TV ads, any value you can have, then how many cars are sold, and y is your dependent variable, right? Fine. So now what do we need to find out? We need to find out m and c. Fine, where y is your target variable, x is your independent variable. Now just tell me, are you all good with the example? Understood that what we are going to find and everything? Okay, Rahul is good, Sweetie is also fine. Okay, mostly all of you are good. Okay, fine. So see, now to calculate m, fine, the first task is to calculate the m. So to calculate m, we already have the statistical formula with us, which I am going to write. So that formula is summation of, fine, summation of x minus x bar, where x bar is the mean. I told you that we always represent the bar with the mean, into y minus y bar into y minus y bar divided by summation of x minus x bar whole square. Summation of x minus x bar whole square. So this is the formula with us, okay, which is already there to calculate the m. So now we are going to find out the value x minus x bar, y minus y bar, put it in the formula, and then we have the m with us. Okay, so let's just do it together. So what is the first thing we need to find out? X bar and y bar. Okay, so what first thing we need to find out here? X minus x bar, right? So x minus x bar. So what is the value of x bar? And here what we need to find out? And suppose I'm representing with a, okay? And here we have y minus y bar, and let's say I'm representing it with b. Then we multiply both of them, x bar into y bar, and then we have x minus x bar whole square. Okay, x minus x bar whole square. Okay, so x bar is 5 and no, x bar is 2, y bar is 19.2 and x bar is 2. 3, 3, 6, 7, 8, 9, 10. 10 divided by 5, okay, 2. So x bar comes out to be 2 and y bar comes out to be 19.2. So here I am writing that y bar comes out to be 19.2. Okay, cool. So now let's just fill the columns. X minus x bar. 1 minus 2 is minus 1. 3 minus 2 is 1. 2 minus 2 is 0. 1 minus 2 is again minus 1. And 3 minus 2 is also 1. And what will be the values? Please tell me, like 14 minus 19.2. Minus 1. Yeah, 5.2. 14 minus 19.2, yes, minus 5.2, right? And then we have 24 minus 19.2.
Also guys, if you're looking for an end-to-end training in Python for data science, Intellipaat provides a Python data science course and training which covers all of the concepts which you need to learn and also will help in getting you a job. So for more information, check out the description box below or visit intellipaat.com.
Which comes out to be 4.8, right? And 14 minus 19.2, again minus 5.2. 17 minus 19.2, 2.2, and then 27 minus 19.2, right? 27 minus 19.2 is 7.8. Cool. And now I need to multiply them, okay? As like, you know, x minus x bar multiply by y minus y bar. 5.8. 24 minus 19.2. It's 4.8. 17 minus 19 is minus 2.2. Yes, here it should be minus. Okay, so now let's multiply them. 5.2 multiply by 1. Let me change the color and let's take it this one. Is 5.2. Cool. 4.8 multiply by 1. It's again 4.8. It is 0. It is 2.2. And it is 7.8, right? It is 7.8. Okay, then x minus x bar whole square, 1, 1, 0, 1, 1. And summation means that now we need to sum all of them. So can you please tell me the sum of all of them? So here it is 4, cool. So what will be the sum of x minus x bar multiplied by minus y bar? 5.2 plus 4.8, 10, then 2.2, 7.8, so near about 20. It comes out to be 20, right? Yes, so it is 20. So what will be the value of m? M comes out to be 20 divided by 4, and we all know that 4 5s are 20. So the m, the slope for this particular data comes out to be 5. So see now what equation do we have? We have the equation y is equals to, what is the value of m? 5x plus c, right? 5x plus c. And now what we need to find out? We need to find out the C now. Okay, we need to find out the C. C has been left. So see now how we are going to find out the C. See, always remember that whenever we draw a linear regression line, okay, whenever we draw a linear regression line, it always passes the x, the mean of, you have the coordinates like x and y. Okay, the points are there, the data points. So there will be always one coordinate which is the mean of x and the mean of y. I mean, let me show you. Here I'm explaining you that suppose here I'm drawing one regression line. Okay, let's say like this. Suppose this is my x, okay, and this is my y. So for my x, of course, there will be for all the values of x I am having, of course, there will be one mean of x, right? And for all the values of y I am having, there will be one mean of y. So it's always been it is always the case that there will be one data point, okay, in this particular line. I mean, not the data point but the coordinate. It can be data point or it cannot, but there will be always the coordinate which is x bar minus y bar. It means that the linear regression line always passes through the mean of the x and the mean of the y. And by using this principle only, we will find out the value of C. So here we just replace them with the mean, y bar and x bar. So what is the mean of y bar? 19.2, right, is equals to, what is the mean of x? That is 2 plus 2. So 19.2 minus 10 is equals to C. So what will be the value of C here? I mean, what will be the intercept? It's 9.2. 9.2. Okay, so now the equation of your line is, that is y is equals to, what is the value of m? 5x. 5x plus 9.2. Like this is your linear equation, like equation of the on the basis of this data set. So what is going to happen is that when we have this equation with us, okay, we have the y's with us, which is 14, 24, 14, 17 and 27, and we have x with us as well. Okay, so now what we are going to do, see, y is your actual target, actual variable, like target variable being given to you, and now we are going to find out the y hat. Okay, let's understand this clearly. What is this y hat? Y hat will be your predicted y. I mean the y which your model is predicting. Okay, so see, y cap will be your predicted y. Find something, the y which your model is predicting. Okay, I mean, when you have actual variable and then you have the target variable. Yes, Rakesh, I'm going to upload all the images on the link. You have predicted y. Okay, so now let's just find out the predicted y. So see, we already have x with us. Okay, so for first point, the value of x is 1, right? For the first data point, for the first data point, the value of x is 1. So it will be your 5 multiplied by 1 plus 9.2. Am I right? Which is 5 plus 9.2. So what will be the 5.92? It's 14.2. Okay, so the predicted value, I mean, like if for this particular variable only, if for this variable only we draw the predicted y, the y which we are predicted from the equation, from the model, the equation of the model we get, it comes out to be 14.2. So, and for the second time x is 3, right? For the second time x is 3. So how we are going to find out the predicted y for it when x is equals to 3? 5 multiplied by 3 plus 9.2, that is 15 plus 9.2, which comes out to be 24.2. Am I right? Then you have x is equals to 2. So 5 2s are 10 plus 10 plus 9.2. So which comes out to be 19.2. And then you have 5 into 1. So 5 plus 9.2, it's 14.2. Yeah, and when you have 5 3s are 15 plus 9.2, 24.2 again. Cool. Okay, and similarly when y is equals to 4 for the predicting variable, what will be the value for the predicting variable? 29.2. Okay, so of course 0.2 will not be considered in this, so it comes out to be your 29 only. Okay, so let's say because we are predicting the discrete variable, so it will be your 29.2 and approximately equals to 29. Okay. Now we are going to draw the regression line. Okay. On x-axis and on y-axis. So suppose if your regression line, I mean, what does your y comes out 9.2? Suppose if your regression comes out to be a regression line comes out to be this. Let's say that this will be your regression line. Okay, and the actual data points, right? So there will be some actual data points and then there will be some predicted data points. So actual data points, what is the coordinate of your first actual data point? 1 comma 14. It means your x-axis should be 14, sorry, 1. This is x, this is y. So here I am predicting the actual data points. Okay, actual data points, what will be your actual data point? 1 comma 14. Cool. 1 comma 14. So your 1 comma 14 will definitely will lie on this line. Suppose this is your x and your y is somewhere 14 here. Let's say this here. Let's say the here x is 1 and you have this point 1 comma 14. You can draw it on a graph. Okay, here we don't have that much clear picture. Then next and then the next actual is 3 comma 24. Cool. 3 comma 24. So it will be somewhere here. Okay, here I'm drawing the actual point. So suppose these are my actual data points. 3 comma 24, 2 comma 14 again, and then 1 comma 17, and then 3 comma 27. Similarly, I have the predicted data points also. So predicted I'm representing with the blue and dot. Okay, so suppose this is my predicted 1.1 comma 14.2. So 14.2 will be somewhat here because it's 0.2 difference, right?
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Similarly, 3 comma 24.2. So you can say somewhere here again above 24.2. It's actual 24. So again 0.2 difference somewhere here. Then 2 comma 19.2. So 2 comma 19.2 will be again at this place maybe. Cool. Then 1 comma 17, like this we have the few predicted points. Cool. So what actually the main thing in the regression, that this distance, okay, this distance, the distance between the regression line and the predicted data points, you know now how to predict, should be as least as possible. Of course, because that is something considered as your errors, because on the linear regression line you'll have your actual data points. Cool. Yes, may not, you have some curves as well, Prashant, but here like we expect that they fall on the on the line or nearby the line, we can say. So we try to find out the best fit line, which always says that there should be the least distance in between the linear regression line and the predicted data points. Okay. And there is one more term, which is error, because I was saying, you know, that in the linear regression equation we have the equation plus error. So what will be your error in the linear regression? It is your actual minus predicted, that is y minus y cap. Y minus y cap. This is your error in the linear regression models. And what do you think, that we should always reduce the error or increase the error? Error should be less, of course, because it is error, right? It should be as less as possible. Yeah, so we need to reduce this term, we need to minimize this function, and that is something also known as your cost function. Although I'll talk about the cost functions in detail, but still this is something your all linear regression is about. Now let me show you some of my previous notebooks, okay, in which it is clearly explained. So the definition, and then we took this data set, okay. So in the same way we took the data set, we find out the predicted y. See, this is also X number of cars sold, Y number of TV ads. We have the data set, we find out all the thing. To find the best fit line, one of the coordinates of a line should pass through the average or mean of points, as I told you. Therefore, by using this, we will able to find out the small c, right? Once we have the c with us, then we can draw the linear equation line like this, okay. Your blue are your actual data points, red are your predicted ones, and then you need to reduce the distance in between the two. And in linear regression, this error, cool, this error is also known as the residual. Residual also, what does the residual means? Residual also means that it is your error, okay. And we, as I told you, that we always need to reduce the error, so therefore we need to minimize it. And in order to minimize it, we just do the summation of, because it's for only one, okay. But suppose if you need to calculate for all of them, so yi minus y cap I means like when your first data point, second data point, third data point, just square this term, okay. And we need to minimize this. Why we need to minimize this? Because we need to minimize the error, okay. And this particular function is also known as your cost function of your linear regression, or your least square method, okay. Because you are like y minus y cap whole square is also known as your least square method. And let's just create one more. Yeah, so next we have to discuss is the coefficient of the determination, right? So see, you know, to make a model, okay, now we know the mathematics of the model, but the sklearn library always helps us to do all these mathematics by itself, but we still know how does it works, right? And that we learned. But the things comes in that how do you find that what is the goodness of it? Goodness of it means that suppose you applied a linear regression model on one of your data, and now you want to find out that how much accurate this line is. I mean, how much, although errors we can find, I do mean square error and all, okay, as like with the error function, but still there is one more parameter which will tell you about the goodness of it, that how good your line is, okay. So to do that, to understand that, we need to understand few more terms, okay, as like sum of squares due to regression, sum of squares of error, and sum of squares in between the sum of squares total. So let's just talk about them. Fine. So suppose here I am having a equation, a linear equation line, okay, x-axis and the y-axis. Okay, so here I draw the regression line, let's say. Cool. So I'm just taking the example that this is suppose my regression line. Okay, and I also said you one thing, that your regression line always pass through the best fit line of your regression always pass through the mean of x and the mean of y. Okay, so let's say that this point, this point is the mean of y. So let's represent it by y bar. Cool. Let's represent it with y bar, and here I'll cut this with this at this point. So where it is cutting the regression line, it is cutting from this point. Let's draw a small one. So this will be your y bar. Okay, and now let's say that you have one data point. Okay, suppose on this equation line you have this data point predicted. Fine, this is your predicted data point. I'm marking it as predicted. Something which you are predicting, okay, data point. And here at this point, let's say that you have the original data point. Okay, at this point of your data you have the original data point, so it will be your original. Okay, so see, now there will be the error, okay, which is actual minus predicted. Suppose if this is your actual, cool, and this is your predicted, so there will be your error, this one, this distance. Of course, this distance is the error, as I told you that error will be the actual minus predicted. So suppose if I say, so here it will be your actual, that is your y minus y cap. That is your error one, actual minus predicted. Cool. And this error is known as your SSE. Okay, so there are terms which you need to remember. SSE, always remember, sum of squares of error, and it will be your summation of sum of square of error, SSE. Very simple term, summation of actual, cool, yi minus yi bar whole square. Then after this we have one more error, which is this one. Let me take it with this. That is this error, and this error is known as your SST. Sorry, this is known as your SSR. That is sum of squares due to regression. Okay, and the formula for this is predicted. See, now this point is what? This point is predicted, right? So predicted, we are saying yi cap, predicting, minus mean, that is yi bar whole square. This is your sum of square due to regression. So let me write down. This is your sum of square due to regression. And how it is defined? Sum of the predicted value and the mean of the dependent value. I also have bar in place of cap. Have I see? It is your predicted by I cap, and for mean it is bar. So predicted minus bar. Okay, and then it comes to your one more type of error, which is your SST. Okay, which is your SST, and SST is your sum of squares total. Okay, sum of squares total, and your SST is SSE plus SSR. So it is the important that in calculating the total error, the SSR also been used. So sum of the squares total. Okay, we have this formula, that is SST is equals to SSE plus SSR. And now next we are going to discuss about the assumptions of linear regression. So I have one blog on the assumptions of the linear regression on Medium. Let me show you. So let's just talk about the assumption. And it is a model that assumes a linear relationship in between the variable x and the single input output variable y. Of course, because it's a linear regression, so its first assumption is only linear distribution, that your data should be linearly distributed. And what do I mean by linearly distributed data? That the data should be in the linear distributed manner. I mean, like something like this. Your data point should be like this. That they can be counted linearly. Now, suppose if if I say that your data is something like this, okay, where you cannot draw a line, right? So of course, this is not your linearly distributed data. So your data should be linearly distributed. This is the first point about it, right? And now let's just read about it, what has been written, and what is the things that what should be taken care of before applying the linear regression model on any of your data set. So linear distribution, so it is defined as the relationship between two features, where change in one feature can easily explain the change in another feature. That is, the relationship between each independent variable and target variable should be linear. Okay, it means that they should be dependent on each other, right? And like on one increases, other decrease, maybe one decrease, other increase. So some kind of relationship should also be there, always be there. And how to check the linear distribution? We can simply plot a scatter plot. We know how to do that. PLT dot scatter, right? Understood the first one, linear distribution. There are total 5 assumptions. The first is your linear distribution and the simple one. Cool. The second is your presence of normality. Okay. Now, what do I mean by presence of normality? See that there is the concept of the normal distribution. And the normal distribution is the data that which is something distributed like this. Okay, which is the bell-shaped curve. When your data is like this, it means that your data is normally distributed. Okay, and in statistics, we have one theorem which is known as central limit theorem. Okay, so according to central limit theorem, if the number of attributes, I mean the number of rows you can say in your data is greater than 30, okay, is greater than 30, so then automatically, okay, automatically that data set will follow the normal distribution. So automatically the distribution of data of that data set becomes normal. So this is what something known as the central limit theorem. So here it says that as we know, there are n number of distributions in statistics like uniform, normal, Gaussian, exponential. There are n number of distributions, and if the number of observations is greater than 30, okay, in any variable, if the number of observations is greater than 30 in any variable, we simply assume it to be normally distributed, and this theorem is known as the central limit theorem. So it means that your data should be normally distributed, and it will be definitely, of course it will be if there are more than the 30 observations in your data set. Okay, and how to check the presence of normality? To presence of normality, we can always draw the histogram. Okay, below I have one example where in the, it's been given as you see. Let me show you. So suppose if this is my data set, right? I'm having the features like TV, radio, and newspaper, and on the basically sales data, that how much advertising dollar spent on TV by a company, how much advertising dollar was spent on radio, and how much on newspaper, and then on the basis of that, how much their sales has been affected, right? So if when it comes to a linear distribution, so we always draw the scatter plot. As you know that TV, radio, and newspaper are the independent variables and sales is your target variable. So just they should follow the linear distribution. Presence of normality, we always draw the histogram. So histogram should be look like this in between the newspaper and the sales. Okay, so once you go through this article, it will be very much clear to you that what does it mean. So now it's multicollinearity, fine. So that is your third and very important assumption. First, let's just discuss what do we mean by multicollinearity. So see, multicollinearity means that the two independent variables, okay, or two features shouldn't be heavily dependent on one another. I mean, it's like that changing one may not change the other. Okay, so we need to have very little or no multicollinearity in the data. Let me explain you what does it mean. That suppose if I have one column in my data is date of birth, okay, another column in my data is the age. So first let me tell you that what does the multicollinearity means, that two features, okay, should not be dependent on one another, should not be highly dependent, means like strongly dependent on each other. Highly dependent, should not be highly dependent. So if suppose if someone's DOB is 12 to 94, okay, then age of birth will be let's say 27, right? So if means these two are representing the one thing, don't you think that they two are highly dependent on one another, date of birth and age? Means if you make some changes in DOB, there will be some changes in the age as well, right? So this should not be the case. Two variables shouldn't be highly dependent on each other. There should be only one variable. Either you can drop the DOB or either you can drop the age. So this concept is known as the multicollinearity in the data set. And even this question has also been used in the interviews many times, that what do you mean by multicollinearity? So it's very simple, that two features shouldn't be much dependent on one another. And how you are going to find out the multicollinearity, that is the multicollinearity exist in your data, that is by checking the correlation, by using the Pearson's correlation coefficient or the heat map. As I told you that the correlation values always lies between -1 to 1. Okay, 0 means no correlation, very much close to 1 means highly correlated to each other. So there should be no correlation. So this is your multicollinearity. Yes, in pandas we discussed, right, Prashant? Okay. And then it's your fourth assumption, which is your autocorrelation. So let me explain you the autocorrelation here. So and this is how we draw the heat map. Okay, autocorrelation is that your vector of prediction, okay, shouldn't be dependent on the previous assumption. Okay, so let me just explain you that suppose if you have the sales data, okay, so autocorrelation say that sale, suppose there are 3 days, 1 2 3, okay, so sale of one day, okay, I mean like the sale of the second day should not depend on the sale of first day. Similarly, sale of third day should not depend on the sale of second day. So this is something your autocorrelation. That autocorrelation doesn't exist, and it usually happens in the time series kind of data like stock market or something. Okay, so the rare problem which we come, but it is considered as one of the assumption that the vector of prediction, okay, shouldn't be dependent on the previous day prediction. This has all been written here. Sometimes the value of yx plus 1 is dependent on the value of yx, which is again depends on the value of yx minus 1. Mostly stock market or the time series analysis data set can be counted as an example of autocorrelated data, and we can use line plot or geometrical plot to check its presence. And now the next comes is your homoscedasticity. So homoscedasticity, it means that a homo means similar, okay, and sedasticity means error. It's always good to break the complicated terms into two. So or homo means similar and sedasticity means error. So it can be defined as a property of regression model where the errors are almost similar across all of the input values. Okay, if the errors keeps changing drastically, the result in a funnel shaped scatter plot can break our regression model, and the condition follows heteroscedasticity. It means that the errors should be kind of similar in between the target variable and the independent variable and the dependent variable. If they are not similar, so then you have the kind of example like this. I mean, suppose if you draw the error in between the dependent variable and the independent variable, if the result comes like this, so it should be fine. I mean, there should be like the similar type of errors. But if it is like this funnel shaped, okay, so then this shouldn't be there in your data. So homoscedasticity is something should be present and heteroscedasticity shouldn't be. So now let's just talk about the data set. So see, when you look at this data, so you'll see that there are many features. Fine. So the features are like your longitude, latitude, housing median age, total rooms in a house, total bedrooms in a house, population, households, the median income, okay, the median income of the person who owns the house, the median house value, and the ocean proximity. It means like either it is near ocean or whatever, like near bay or something. So by looking at this data, the problem which has been given to us, that on the basis of these features, that what is the housing median age, it means how much old the house is, how many total rooms are there in the house, how many total bedrooms in the house, how many people can actually live in the house, what will be the median house value, okay, that is, and all this is in dollars, median house value. So median house value is my target variable over here, and rest of them are the features. Okay, so see, now everything seems to be good, but when it comes to your median income, okay, so here the median income is like $8.32, $7.25, $3.84. So do you think that the people who have like this amount of median income, okay, like can own such houses? Yes or no? I mean, like if you have such a less amount of median income, so can you own such type of houses? No, but most of the time the answer is no. So therefore, if we look at this data set, so we find out that this median underscore income column is scaled. Okay, now what do I mean by scaled? That I'll tell you a little bit later. Scaled means that we can scale our largest values to a specific range, and for scaling there are many feature scaling parameters available. But as of now, let's say that this your median income is the scaled column in your data set. Okay, and if I talk about the info, housing.info, so you will see that how many total values are there in your data set. There are total 20,640 entries. And how many columns are there? There are total 10 columns. First, you have the data set with you. You will check, you have the problem with you. Then you will, of course, use the info function on the data set, and we'll come out with this. So let's see about the null value. So see, when we check about the isNA.sum, so I just find out that there are no NA values in any of the column, but in total underscore bedrooms, I have 207 null values, right? In total underscore bedroom, I am having the 207 values. So now see, there are total 20,640 rows and 207 null values are there. So now there are many ways to deal with the null values. You know that either you can remove the rows consisting of the null values, either you can drop the entire column as well, right, which consists of null values, and even you can fill your null values as well. So now before actually deciding that which method we are going to use when we have the null values in our data set, we'll check the correlation. Okay, the correlation means like you know what the correlation means, but the correlation in between the column which is having the null value with the target variable, that either that column is important, it is correlated with the target variable or not. Like if it is highly correlated, so then we should keep it. Like, and even if it is less correlated, so then we can drop it. Why to then waste time in filling the null values if that column is not correlated with your target variable, right? So what we'll check about the correlation first. So how to check for the correlation? What was the formula? House dot correlation, right? So once you use how dot corr function, you'll have the correlation with all of your continuous variables. Cool. So now by looking at this data, this is your positive correlation graph.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
This is my negative correlation graph when one increase and other decreases. And this is something like my no correlation graph, like when there is no correlation in between the data and the feature and the target variable. Okay, so here we can find out that strong predictors are median income, total rooms and housing median age. Weak predictors are total bedroom and household. For total bedroom, it's minus 0.007. So like negative and also very weak predictor. And negative predictors are longitude, latitude, and the population. Population is not negative, it is 0.004. Okay, so let's remove it. Understood. So now total underscore bedroom is having the very less amount of does not correlated with my target variable. Therefore I just decided to drop the total underscore bedroom from my data set, as it consists of the null values. So what I will do, how to drop, by using dot drop method. Okay, by using dot drop method. See, longitude is negative, it is minus 0.04. Population is negative. I was checking that population is negative. Okay, so what I'm dropping the total underscore bedroom, because I'm thinking that it's a weak predictor, because for total underscore bedroom it's very less, 0.04. Okay, so therefore I'm just deciding to drop it instead of filling with some null values. What I do, I drop it. So how to drop, that you all know. House dot drop. Column name axis is equals to 1 for column, and for permanent changes in place is equals to true. And then you have house dot head. So what does it mean? That your total underscore bedroom has been dropped. Okay, so I think we should proceed now. Cool. So I just dropped this column. See, now all seems to be good in my data set, but the problem is with the ocean underscore proximity column. I told you that we cannot pass the text categorical data to the machine learning models, right? What we need to do, we need to convert this ocean underscore proximity, we need to encode it. I mean, convert the text categorical into the numeric categorical, because we cannot pass it directly to our model. So first I need to check, because in the first 5 rows I can only see the near bay. Okay, so first I checked for the value underscore counts function. I told you about the value underscore counts function in the pandas. So there are total like 1H ocean, inland, near ocean, near bay, and island. There are total 5 categories of ocean underscore proximity: 1H ocean, inland, near ocean, near bay, and island. Okay, and now we need to convert this text categorical column into the numeric column, and for that we need to use the label encoding. Okay, so for that we need to use the label encoding. And to use the label encoding, we'll take the help of your sklearn library. Okay, how you are going to write? Do listen this from sklearn dot what see first let me tell you what actually label underscore encoding is. So label underscore encoding is that it will directly, as you'll see that there are total 5 categories. Okay, so what it will do, it will just assign the number 0, 1, 2, 2, 3 and 4. Okay, value underscore all counts always return in the descending order. So in this way, this just encode your text categorical data. I mean, one edge ocean been represented by 0, inland been represented by 1, near ocean now by 2, near bay by 3 and island by 4. Okay, so kind of ordinal values label underscore encoder provide, okay, as like in one particular descending order. Okay, so now I applied this. So to apply, we need to make the use of sklearn library. So from sklearn dot pre-processing, I just import the label encoder. Okay, label encoder, and then le, I mean I'm taking one object of it is equals to label encoder. And label encoder, you can read about it when you press shift plus tab. Once it's been executed, I'll do that. See, encode the target variables, target labels with value between 0 to n number of classes minus 1. Okay, so this is how it works. And after that, I want to make the changes in ocean underscore proximity. So house data set, on which column I want to work, ocean underscore proximity is equals to LE, that is your label encoder dot fit underscore transform, and then which data, house data, on which column I want to apply ocean proximity, and then I have the result like this. For all was near bay, right? So near bay is been encoded to 3. Now just have a look on 8, 12 and 13 and let me know if you have any questions. And either it is working in your system or not, please write the code and check it out. Yes, kind of same. One hot encoding is different in a way that it provides you the different numbers. I mean, like different columns are there. Suppose 5 columns will get created, right? And 0, 1 will only be there. But in label encoder, it's been like 0 to n minus 1. That is the difference in between one hot and label. Okay. And after that, I just applied the describe technique on it. Describe, you know, provides you the descriptive statistics, mean, median, mode, count, under self-explanatory, minimum value, rest are the percentiles and interquartile range, right? That's cool. And I just draw the scatter plot in between the median income and median house value. So it comes out to be this. You know, so highly correlated data is there, and also following the linear concept as well.
Also guys, if you're looking for an end-to-end training in Python for data science, Intellipaat provides a Python data science course and training which covers all of the concepts which you need to learn and also will help in getting you a job. So for more information, check out the description box below or visit intellipaat.com.
So let's have a look at the problem statement. So consider yourself to be the manager of a supermarket, Walmart. And your task as the manager of the store would be to increase cross-selling. That is, you'd want to encourage the customers to buy items related to what they've already bought. And to do this, you'd have to find the association between different items. That is, you'd want to figure out if a customer buys item A, how likely is he to buy item B as well. So you'd have to start off by understanding the transactions. So you'll have to find the total number of transactions. Then you'll have to find the total number of items available in the inventory. After which you'd have to find the total number of items purchased. And then finally find out the 10 most frequently bought items. So let's go to our studio and implement these. Right guys, so we are back to our studio. So we are supposed to load the A rules and A rules Wiz packages. And I'll be loading them with the help of the library function. Right, so we have loaded both of these packages. Now it's time to load the dataset. So now to load the data set, I'll be using the read.transactions functions. So this read.transactions function helps us to read a data set in the form of transactions, right? So the file name is marketbasket.csv and I have a parameter format and the value which I'm assigning to this is basket. So this basically means that each record in the data set would be in the form of a transaction. Then I'll go ahead and remove the duplicates. So I'm setting rm.duplicates to be equal to true. And then I'll skip the first record. That is, I'm not reading the first record and I'll read the rest of the records from the data set. And I'll be storing this in a new object and name that object to be market basket. Right, so we have successfully loaded the data set. Now let us have a glance at the summary of the object which we've just created. So summary of market basket. So you see all of these values over here. So these values basically tell you the number of items which were purchased in each transaction. So let's take this. So this basically tells you that there were 1359 transactions in which the number of items bought were 2. Similarly, if we take this value over here, so there was one particular transaction in which the customer had bought 548 items. Similarly, if we take this value, so there were 433 transactions in total in which the customers had bought 19 items. If we take this value, so this is 165 items. So there was one particular transaction in which the customer had bought 165 items in total. Right. So we had to find the total number of transactions and the total number of items available in the inventory. So the transactions would be the number of rows. That is, the transactions are listed in the form of rows. So the number of rows would give us the total number of transactions. And since the total number of rows are 18,440, the total number of transactions would also be the same. That is, the total number of transactions in the data set are 18,440. Now the columns represent the items. So that is why the number of columns which we have would also represent the total number of items. And since we have 22,346 columns, that would basically mean that we have 22,346 items in total in our inventory. And then we also have a value of density. So this density value basically gives the percentage of all of the non-empty cells in our matrix, right? And then we'd also had to find out the total number of items which were purchased. So to find out the total number of items which were purchased, we'd have to multiply the total number of transactions with the total number of items available in the inventory with the density value. So let's go ahead and do that. So I am multiplying the total number of transactions with the total number of items available in the inventory with the density value. And this is what we get. So you see that in total 4,08,582 items were purchased. Now let's actually have a glance at the first 5 transactions. So what I'm doing here with this command is I am giving the name of the object which is market basket and I am inspecting the first 5 transactions. So these are the first 5 transactions, guys. So in the first transaction, the customer had bought just one item and that item was medium ceramic top storage jar. And this is the second transaction. So there are around more than 30 items in this, right? So in the second transaction, the customer had bought more than 30 items. Similarly, this is the third transaction. This is the fourth transaction and this is the fifth transaction. And the final task was to find out the 10 most frequently bought items. So let's go ahead and make a plot for that. So now since we want to give different colors to the different bars which we are making, we would require the rcolor package. So let me go ahead and load that. Right, so I have loaded the rcolor package. Now to find out the frequency of different items, we have the item frequency plot. So I'll be using this function. So let me guide you through this function. So first off, we will give in the name of the dataset which consists of all of the transactions. And then I'll give in the number of the transactions of which we'd want to make this plot. And since we'd want to make a plot of the top 10 most frequently purchased items, I will give in top n equals 10 and then type is equal to absolute. So this will give us the absolute count of all of the items which have been purchased. After that, I will stack the bars horizontally. So horizontal equals to true basically means that I am stacking all of the bars horizontally. And then this brewer.pal, this function comes from the rcolor brewer package. And I am assigning 10 different colors from the spectral palette. Right. So let me hit enter and this is what we get. So guys, these are the 10 most frequently purchased items from the entire data. So this white hanging heart tea light holder is the most frequently purchased item, right? So now that we're done with the first task, let's go ahead and build our first set of association rules. So here we'd have to build a priori algorithm with support value 0.005 and confidence value 0.8. Then we'd have to sort the rules with respect to confidence and inspect the top 5 rules and also the bottom 5 rules. After which we'll go ahead and sort the rules with respect to lift and inspect the top 5 rules. And finally, we'll plot the rules using different methods. Right, so let's go ahead and perform all of the above mentioned tasks. So we were supposed to build an a priori algorithm with these parameters. So let me put in the command over here. So what I'm doing is, on top of the market basket data, I am building the a priori algorithm with these parameters. So here the support value is 0.005 and the confidence value is 0.8. So the support value of 0.005 basically means that out of all of the transactions, I am selecting those item sets which occur at least 0.5% times. So I'm reiterating guys. So the support value of 0.005 basically means that out of all of the transactions, I am extracting only those item sets which occur at least 0.5% times, right? And then we have this confidence value which is 0.8. So this confidence value of 0.8 basically states that out of all of the item sets or out of all of the antecedents which we have extracted, the consequence should be present 80% of the time. Right? So we have assigned the support value to be 0.005 and the confidence value is 0.8 and I am sorting the rules with respect to confidence and I am storing it in an object and naming that object to be rule 1. So let me run this. Now let me have a glance at the summary of the rule which I've just built. So summary of rule 1 and we get a summary of this, right? So there are 6 rules which comprise of 6 items including the LHS and the RHS, that is including the antecedent and the consequent. Similarly, there are 79 rules which have 5 items and there are 211 rules which have 4 items, 201 rules which have 3 items and 64 rules which have 2 items, right? So this is the length of the item sets and this is the count with respect to those item sets. Now let's inspect the top 5 rules. So I am giving the name of the rule which is rule 1 and I am inspecting the top 5 rules. So these are the top 5 rules when sorted with respect to confidence. So we see that if someone buys garbage design, that customer is also likely to buy key fob. And the support value is 0.005 and the confidence value is 1. So the support value of 0.005 means that out of all of the transactions, garbage design would be present at least 0.5% times. And this confidence value of 1 means that if someone purchases garbage design, then he is 100% likely to also buy key fob. And then we have this next rule over here. So if someone buys elephant, then he is also likely to buy birthday card. And the support value is 0.006 and the confidence value is 1. So the support value of 0.006 means that out of all of the transactions, this elephant has been purchased 0.6% of the times. And this confidence value of 1 indicates that if someone purchases elephant, then he is 100% likely to also buy a birthday card. Right? Similarly, if we take this rule over here, so for this, the support value is 0.006 again. So this means that out of all of the transactions, retrospot was bought 0.6% of the times, and this confidence value of 1 means that if retrospot is bought, then birthday card is likely to be bought 100% of the times along with the retrospot. Now let's go ahead and glance at the bottom 5 rules. So we given rule 1, and from this rule 1 we are inspecting the bottom 5 rules. So that is why we're using the tail function. So these are the bottom 5 rules, guys. So let's examine this rule over here. So there are 2 items in the LHS and there is 1 item in the RHS. That is, the antecedent comprise of 2 items and the consequent comprise of 1 item. So for this, we have the support value to be 0.006 and the confidence value to be 0.8. So the support value of 0.006 basically means that out of all of the transactions, customers are likely to buy this item set 0.6% of the times. And this confidence value of 0.8 means that if someone buys this item set over here, then he's 80% likely to also buy a set of 3 wooden stocking decoration. Now let's have a glance at this rule over here. So on the LHS, the item set is lunch bag apple design, lunch bag pink polka dot, and lunch bag woodland. And on the RHS, we have lunch bag red retro spot. So for this, the support value is 0.006 and the confidence value is 0.8. So the support value of 0.006 basically states that out of all of the transactions, this item set was bought 0.6% of the times, and this confidence value of 0.8 states that if someone buys lunch bag apple design, lunch bag pink polka dot, and lunch bag woodland, then he is 80% likely to also buy lunch bag red retro spot. Now let me go ahead and also sort the rules with respect to left. So rule 1, and I'm sorting this rule 1 with respect to left, and I'm storing the result back to rule 1. Now let me inspect these rules. So I'm inspecting the top 5 rules over here. Right, so after sorting the rules with respect to the left, this is what I get. So if I examine this first rule over here, on the LHS, the item set is Dolly Girl Children's Cup and Space Boy Children's Bowl. And on the RHS, or the consequent is Dolly Girl Children's Bowl. Right, so for this, the support value is 0.005 and the confidence value is 0.96. So again, here the support value of 0.005 means that out of all of the transactions, this item set is present 0.5% of the times. And this confidence interval of 0.96 means that if someone buys Dolly Girl Children's Cup and Space Boy Children's Bowl, then he is 96% likely to also buy Dolly Girl Children's Bowl. So now let me go ahead and plot these rules. Now let me change the method. So I'll be plotting the rule 1 again, but the method which I'm giving would be toKey. So let's see what is the difference which we get over here. So now this time the coloration is with respect to the length of the item set. So if the length of the item set is 6, then the color of the dot would be yellow. Similarly, if the length of the item set is 2, then the color of the dot would be purple. Similarly, if the length of the item set is 5, then the color of the dot would be green over here. So let's examine this rule over here. So since the length of the item set is 6, so there are 5 items in the antecedent and there is 1 item in the consequent. So here the support value is 0.007 and the confidence value is 0.9. Similarly, let's examine this over here. So the length of the rule is 3 over here. And the items in the antecedent are pink Regency teacup and saucer. And we also have roses Regency teacup and saucer. So if someone buys these two, then there is 80% likelihood that he would also buy green Regency teacup and saucer. So here what we are basically doing is we are segregating these points with respect to the length of the item set. Now let us make the final plot. So this time the method which I am using is graph. So let me hit enter and let's see what do we get this time. So this time we get a graphical result over here, right? So let me zoom in. So we have all of these rule numbers over here. So let me put my mouse pointer over here, right? So this is rule number 92, which states that if someone buys herb marker mint, herb marker parsley, herb marker thyme, then he's also likely to buy herb marker chives. So for this, the support value is 0.007. The confidence value is 0.89. Now, let me zoom out. So the distance or the gap between these two graphs basically means that there is absolutely no association between these items and these items over here. Similarly, let me zoom back. There are two items over here as well. So these item sets are completely different. These item sets are completely different, and these item sets are completely different. That is, there is no association between these three set of items over here. So let me zoom in again and let me have a glance at this rule. So this is rule number 100 over here, which states that if someone buys Dolly Girl Children's Cup and Space Boy Children's Bowl, then he's also likely to buy Dolly Girl Children's Bowl. Similarly, let me zoom out and let me have a glance at this rule over here. So this is rule number 87, which states that if someone buys pink vintage spot beaker, then he is 87% likely to also buy blue vintage spot beaker. Now we'll go ahead and build the second set of association rules. So here we'd have to build a priori algorithm with support value 0.009 and confidence value 0.3. Then we'd have to sort the rules with respect to confidence and inspect the top 5 rules and also the bottom 5 rules. And finally, we'll plot the rules using different methods. So we'll make the second set of association rules. So this is the command for that. So this time again, on top of market basket, I'm building the a priori algorithm. So for this, the support value is 0.009 and the confidence value is 0.3. And I'm sorting the rules with respect to confidence, and I'm storing the result in an object named as rule 2. Let me hit enter. We have successfully built the a priori algorithm. Now let me have a glance at the summary of rule 2. So here we see that the length of the item set could be either 2, 3 or 4. So there are 16 rules where the length of the item set is 4. There are 288 rules where the length of the item set is 3. And there are 537 rules where the length of the item set is 2. Now going ahead, let me have a glance at the top 5 rules and the bottom 5 rules. So this is the command for that, rule 2. And I'll be inspecting the top 5 rules using the head function, right? So these are the top 5 rules. So here, let's have a glance at this first rule over here. So if someone buys set 3 retrospot tea, then he's also likely to buy sugar. And for this, the support is 0.013 and the confidence is 1. So the support value of 0.013 means that out of all of the transactions, people are likely to buy set 3 retrospot tea 1.3% of the times. And this confidence of 1 means that if someone buys set 3 retrospot tea, then is 100% likely to buy sugar. Similarly, let's have a glance at this. So the rule is backdoor gives us key fob. And for this, the support value is 0.012 and the confidence value is 1. So again, if the support value is 0.012, this means that out of all of the transactions, backdoor has been bought 1.2% of the times, and this confidence value of 1 means that when someone buys backdoor, he is 100% likely to also buy key fob. Now let's have a glance at the bottom 5 rules. So I am inspecting the bottom 5 rules with the help of the tail function over here. Right, so let's examine this. So here the rule is, in the antecedent we have home building block word, and the consequent we have white hanging heart tea light holder. So for this, the support value is 0.011 and the confidence is 0.3. So the support value of 0.011 means that this item is bought 1.1% times, and this confidence value of 0.3 means that if someone buys home building block word, then there is only 30% likelihood that the person would also buy white hanging heart tea light holder. Similarly, let's examine this rule over here. So for this, support value is 0.012 and the confidence value is 0.3. Similarly, if someone buys Jumbo Shopper Vintage Red Paisley, then there is only 30% likelihood that he'll also buy Jumbo Bag Baroque Black White. Now let's go ahead and plot these rules. So I'll start off by making a simple plot over here. So I'll use the plot function and I'll give in the rule 2 over here. Engine is HTML widget, which gives us an interactive plot. So you see these bright red colored dots over here. So these are the dots with the maximum lift. So the lift of these dots is more than 85, so it's around 89, 90, right? So if you want a lift of 90, then the confidence should be greater than 0.8 and the support should be less than 0.01. Now let's go ahead and make another plot. So this time we'll be making the 2-key plot. So the method is equal to 2-key. So again, we have 3 different colors over here. So yellow is for all of those rules where the length of the item set is 4. Green is for all of those rules where the length of the item set is 3. And purple is for all of the rules where the length of the item set is 2. So if you have a closer glance at this, then we see that those rules whose length of the item set is 2, they are mostly scattered, right? So they are present everywhere. But when it comes to those item sets whose length is 3 or 4, then for them, the support should be less than 0.015, you see. So these item sets which have 3 items in them, so they are mostly in this bracket over here. So for them, the support needs to be less than 0.015. And if we take these yellow dots over here, so for these yellow dots, the confidence value should be greater than 0.6 and also the support needs to be less than 0.015. Now let's go ahead and make the third plot. Right, so let me hit enter. So we get many different sets over here. So this item set is not associated with this item set. Again, this item set is not associated with this item set. Similarly, this item set over here is not associated with this item set. So let me zoom in and have a glance at these set of association rules. So let me have a glance at rule number 96. So here, if someone buys herb marker parsley, then he's also likely to buy herb marker rosemary. Now let me zoom out and let me have a glance at this association rule. So here, this is rule number 59 and this states that if someone buys set of 3 wooden tree decorations, then he's also likely to buy set of 3 wooden stocking decorations. Let me zoom out. Let me have a glance at another rule. So this is rule number 20 and rule number 21. So this tells us if someone buys blue happy birthday bunting, then there is 71% likelihood that he would also buy pink happy birthday bunting. Let's examine this. So this tells us if someone buys Scandinavian paisley picnic bag, then there is 62% likelihood that he would also buy pink vintage paisley picnic bag. So now we'll build a third set of association rules. Here we will build a priori algorithm with support value 0.02 and confidence value 0.5. Then we'd sort the rules with respect to support and inspect the top 5 rules and the bottom 5 rules. And finally, we will plot the rules using different methods. So guys, we are back to our studio. So let's go ahead and build the third set of association rules. And this would be the command for that. So here on top of the market basket data set, I am building the a priori algorithm where the support value is 0.02 and the confidence value is 0.5. And I am sorting those rules by support. Right, so now let me have a glance at the summary of these 3 rules. So summary of rule 3. Let me maximize this. So we have item sets with just 2 different length distributions over here. So there are 26 rules with the item set length to be 2. And there are 3 rules whose item set length is 3. Now let me examine the top 5 rules. Right, so this is the first rule which tells us if someone buys jumbo bag pink polka dot, he is also likely to buy jumbo bag red retro spot. And the support for this is 0.029 and the confidence for this is 0.62. Now let me have a glance at the bottom 5 rules. Right, so rule 3, and I am inspecting the bottom 5 rules with the help of the tail function. So these are the bottom 5 rules, guys. So this is the first rule over here, which tells us if someone buys alarm clock bake like pink, then he's also likely to buy alarm clock bake like red. So for this, the support value is 0.02 and the confidence value is 0.64. So the support value of 0.02 states that out of all the transactions, 2% of the times alarm clock bake like pink was bought. And if someone bought alarm clock bake like pink, then there was 64% probability that he would also buy alarm clock bake like red. Now let me go ahead and plot these rules. So plot of rule 3, I'm making a basic plot. Now we see that we can't really find some association with this. So these are quite scattered over here. So let's go ahead and make the 2 key plot now. Right, so I'm using the plot function. I'm making the plot for rule 3 and the method is 2 key. So we have 2 different colors over here. Yellow is for those rules where the length of the item set is 3 and the purple is for those rules where the length of the item set is 2. So now if we take these 3 dots over here, this is for yellow. So this is for all of those rules whose length of the item set is 3. And we see that the support value needs to be less than 0.02 and the confidence value needs to be greater than 0.7. Now let me make the third and the final plot. So this time the method is graph. So these are the different set of association rules which we have. Let me zoom in. So this is rule number 2, which tells us that if someone buys green Regency teacup and saucer, he is also likely to buy roses Regency teacup and saucer. So the confidence for this is 0.78. Now let me zoom back. So let me have a glance at rule number 19. So this tells us if someone buys Dolly Girl lunchbox, then there is 68% likelihood that he would also buy Space Boy lunchbox. Let's have a glance at this. So this is rule number 5. So this tells us that if someone bought alarm clock bake like red, then there is 60% likelihood that he would also buy alarm clock bake like green.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So, did you know that whenever you talk to any of the customer services, customer supports, or any of the other tools out there, there is a 90% chance that you're actually talking to a chatbot and not a human being? Did you know this? Well, 90% of the time. So, let's say, you respond or you communicate with certain companies, for example, like 10 times, out of which 9 times you're talking to an artificial intelligence powered machine and not a human being. Did you guys know this? Well, this is a fact, and I think this is amazing to begin with, because whenever you are concerned with talking to Amazon, for example, Amazon is a very famous e-commerce site, as most of you would know. So you can leave them a message saying, hey, where is my order? I ordered, for example, this item, this mobile, or whatever it is, on this date, and I don't know where it is. So certain responses like this, instead of having a human reply to you, they can actually program in such a way that there is a chatbot sitting at the background, and this bot will basically have all the details about your order, and it can tell you where your order is, when it will reach you, if there are any delays, why there are delays, or much more. So for mundane tasks like this was just a very quick example for you guys. Chatbots have been implemented everywhere. For example, when you think about Netflix as well, even Netflix, for example, let's say your subscription was ending or something, and you just ping them asking, hey, I just paid, but my Netflix still says my subscription is not paid for. In that case, there is a chatbot which will actually reply saying,